we are doing SDFs again. To be honest, I don't remember what I did between this week and last week off stream, but I feel like shit, so I don't care about remembering. This is what my game currently looks like. Still having really big issues with trying to work out exactly what color I should set things when they're overlapping. I just mentally cannot work out how to do it. I did find some bugs that I worked out that like now my merging code works. Like one of the things I need to do is set this to negative infinity, which in this case is just 3 times k. I should probably also fix my SDF. At the moment, my sign distance fields are backwards where positive numbers are inside of shapes. I don't remember why I did this. I think it was to do with being able to calculate the percentage inside of shapes when it won't work very well for something like gray marching because it's like no longer can you judge the distance because it's just outside of shape. But the negative infinity that we start at is basically saying that like if we start at 0, it counts a bunch of stuff as being inside the shape that isn't inside the shape because we look through every shape on the screen for every pixel means that like the pixel over here gets this shape over there and suddenly that shape means that it pulls the pixel off of 0, I guess, like into the negative or into the positive, I guess. But then it means like when this shape comes, it's like, well, now it's blending these two shapes and it ends up with this being inside or outside in it. So it needs to start at negative infinity, which is just far enough outside that it doesn't count if it doesn't get used. I think that's the biggest change I made. I also did some like optimizations that I don't really need because as you can see here, while it's not moving, once they move around, they drop it down about 700, but running at like over 1,000 FPS. But I made it so that when we do the first loop through, that works out what the K value, which is the like sign distance value at a specific point, is we loop through every object on the screen and take the maximum of the K value or the smooth value of the current K value and the current C value. And then if the C is greater than negative 2k, which is the biggest distance I think that two objects can actually interact with each other, we add interactions. This is all about calculating color. This is still not working, but we go if the first iteration is equal to view length, which you can never get to because it's less than view length. So basically the idea is if the length of the number of shapes, like if the first shape is off the end of the list, you are the first shape set first to I. Then we set last to I as well, which is basically just saying that the shape that we just checked is valid, so it is the last shape that we found. And then we also set S to being the smooth between S and C. I think S just starts at 0, yeah. So the idea is that we then calculate what the sign distance value of this pixel will actually be, whereas because the K starts at negative infinity and takes the maximum of K no matter what. I don't think this number is accurate to be used. I'm not sure. It's really hard to get these numbers to print out in any way that means anything to me. But the idea is that we get the S value and we use this later. Then down here we go, hey, if K is like negative, it means we're not inside a shape, so we can just discard this pixel, and this is how we end up with these pixels not colored in. If K is greater than 0, we're inside at least a shape, so we set I to 1, which I think I was using for debug. I don't think it actually does anything. Yeah, it doesn't seem to. But then we iterate from the first object to the last object, which results in it being able to tally up the colors basically without necessarily having to check from the beginning of the list to the end of the list. It can pick just the window that includes the first shape that actually contributes to this value and the last shape that contributes to this value. It still checks every shape in between. So what I could probably do, I don't know if it would make it any faster because it would need a lot of lookups, and would also add limitations to the number of objects, but I could make like a list where it keeps track of exactly what objects to check in the second pass. So the first pass picks out exactly the objects that will have an impact, and then the final pass actually pulls them out. But I don't think that's worth it, and it means that like you'd have to have a fixed number of objects that can ever interact with each other. So for now I'm ignoring that. I'm missing something in my mental model of this to work out how exactly to blend colors, because if I just go with the minimum color, like I'm mixing color based on the power. Because at the moment, I think so inside the second loop, we switch out the shape. I should make this its own function because this is a lot of, like, it's repeated up here as well. But anyway, so say if C is less than -2, means that this shape is too far away. It's more than 2k values away. It cannot possibly make the sign distance field big enough. So we return, or we continue. We go to the next shape. So it's this shape definitely has no impact. Then we calculate what V is, which is the smooth between the S, which is the final value that the spot got, and the current object that we're checking. And then we say, hey, if this object is less than 0, it means that this isn't actually outside of the this shape, even with the smooth blending, doesn't count. So we continue. Then we get F. I don't know what F is actually at this point. Oh, S my factor. So we say if X is greater than 0, which means we're inside the shape, we calculate this, which is like the smooth power. Like if I turn off the other one, if I just say F is equal to 0, I think. I just go here and just say this. Just don't do this. So now F will stay 0, and we do this is like the gradient that we get, where like a shape split to a shape that doesn't have any other colors. Like it's brighter in the middle and gets darker. That's this function here. So basically, it says like if you're inside this shape, you take 1 minus the power of E. It's a really expensive function, I believe, but what I could come up with to get like a nice gradient, so it's brighter in the middle and darker at the edges without ever going to 0. Then we say, well, actually, they're not going to 0. It's this pair here, but so the F, when it's outside the shape, we take V plus 2 times K divided by the circumference. So V is the smooth value. We add 2 times K. I think this was just to make the value like not plummet to 0. And then we divide by Y, because so we know this value is fascinating. So this value is definitely positive because otherwise we would have discarded it. So it's a positive value divided by the radius of the object. The distance from the object, the distance we are from the center, basically, or the maximum distance percentage. I don't know why is in this particular case just the radius, but it'll be different for different shapes. The idea is that we're dividing where we are. So if we were here, we would have a value of like 1, because 1 pixel inside. Yeah, so it'd be 1 here, and then we divide 1 by the radius, so we get like a really small number at the edge. So it'd be darker, and then we add K to divide by K2, because if we do the math, so it's like if we had something like say K was 5, because it makes the math easier. So we had like 1 and a radius of, so we had a value of 1 and a radius of 10, we'd get 0.1. But what I'm doing is I'm saying we actually have a value of 1, which gives us a K2 of 10, so it's 11 divided by, instead of dividing by 10, we divide by 20, and so we get 55 instead of 0.1. So it just means that the values don't get as low, which may actually be why my colors look so bad. So if we drop like the K down a little bit, because it means that like sort of basically the maximum value that you can get is proportional. It's I don't like it because it ends up with these colors here. Somehow I need to be able to clamp it so that if you're outside of the actual shape itself, the tapering doesn't happen anymore. Like we need to taper down to this and then be flat from there out. But I just can't work it out. And I don't know how to add these colors together. Like that's what's happening here, is it's just adding up the color too much. So here what I'm doing is I'm clamping it from between 0 and 1 and times it by 7.5, which basically just shrinks the value down a little bit, and then we add up quarter, which means that the value, the minimum value it can ever return is a quarter, which is why I don't understand why this is so much darker. Anyway, I feel like if I did this inside here, we'd get only the gradient when we're inside there. Otherwise, we get a value. Question is, can V ever be greater than CY? Can we ever get a value greater than 1? I don't know. We do this. Do we get a different? It doesn't look any different. Did I not save it? Okay. It still looks the same. So something here is, it's probably because it was clamping, and then, yeah, so this means that this value is greater than this. Okay. But basically the idea is that the V value, in this case, means we're outside of the shape. So V has to be, yeah, we have to be within the smooth region of this shape, but not inside the shape itself. And then we do it by C, and then we say power. This is just debugging, so power is equal to F because I had something else there. And then we mix the color together, which I think we should probably just not do. We should just say, I think what I was doing was color plus equals object.color times by power. So what this means is none of the other shapes should matter, and then the shapes where they blend get multiplied. I don't understand why these colors don't have the gradient to them. Like if I output power and all that, like I end up with a gradient. I think it's because the gradient of this circle perfectly cancels out the gradient of this circle, and they end up with being equal to the same value, and it's just the amount they overlap by. The idea of that was that smaller circles should have a stronger impact holding their color because they're smaller than the bigger circles. Otherwise, the small circles just get overpowered by big circles. But yeah, now we got a lot of code that I just cut out. Anyway, the trick is if I just don't do colors, it looks great, because if I just swap this to returning white, it looks great. Like the shapes will blend how I want them to blend, but it's like it just can't do colors because I don't know how to mix the colors properly. It's really hard to work out how to mix the colors properly because I don't know how to work out exactly what proportion of color to get. I did read, it's like this is some kind of mixing function. So when we like take S min of A, B, and K, the S min here, because again, this is designed for the opposite of what I'm doing. I'm doing positive numbers are inside shape, negative numbers are outside shape. So they're taking min because negative numbers are inside shape. But what they're doing is they're somehow calculating the minimum value using the quadratic polynomial, which is how you smooth. And then they're working out which one's bigger, say A or B, and then based on that, returning the M or 1 minus M. And this tells you how much of which material to add. The issue being that this only works when you have exactly two shapes. Like what I'm struggling with is working out how to blend multiple colors. Anyway, it's like I can take inspiration from it. I just need to work out exactly what they're doing. It's like they're working out H, which is the minimum of the absolute of B minus. So if I take this, I think I've actually got this rewritten down somewhere inside like this. Yeah. So I haven't saved this yet because obviously this is not valid code. But so the S min here takes in an A and a B, and then it gets this. And so this is the S min. This is the quadratic version. So this is the doesn't return a material. So what's the difference? So the K times 4 is there. And then the absolute of A minus B, so then K minus. So it takes the maximum. H is equal to the maximum. Where do they work out the material? So M, which is the material value, is equal to W times by 0.5. And then S is W times K. So it's HHWK times by a quarter. The minimum of A and B minus, so yeah, which is what they're doing here. So the minimum A minus S. Yeah, I don't know where this times a quarter is coming from. Probably the min between that and 1 minus this. I don't know. I don't know why they're timesing by a quarter. The maximum of this and 0. So the W, so the H here, which is it's probably the divide by K, because they times by a quarter here when they divide by K here. Because we multiply K by 4 here is, but they don't multiply. They multiply K internally, not externally here. That's probably where the divide by, like timesing by a quarter, is removing this multiply by 4 that is applied somewhere here. Very confusing. But they work out the weight by multiplying the height, or H value, because it's all abstract fucking types here. And then the material is just the weight times a half, because it's two shapes. And that's my issue, is I don't know how many shapes are present to be able to multiply the weight by. Can I work out how many shapes are present? One would assume that I can keep track of like found. The issue is that the just tracking the number of found shapes doesn't mean that this shape actually gets to have an impact when we get down to here. And then if I just so we would need to keep track of when we set last here. What does this set div? So we can say like div plus equals 1, right? Like this. So this sets a div value, and the div value will keep track of how many shapes we actually found, and then when we add pow here, we want to like times it by 1 divided by div, and then yeah, so it doesn't work. Like it should be a gradient here, but it's not. And I just don't understand why. Probably the way I'm calculating this value. I mean, we could probably just make f be f again rather than like picking a different f. It's obviously my gradient's just not working properly there. Okay, that's better. They still end up with this, like, it's just the same color where they blend. Like, it's not gradienting properly. And I don't know why. You also get a different color when you're outside of this shape. I think it's because the number of colors that I'm adding is the wrong number. Like, what that was really weird. I suspect, like, somehow, depending on what order the shape checked in, is adding different amounts. Like this one here going this way, ever so slightly, implies there's a shape over here that we can't see that's pulling it out this way. Which is probably like this orange shape here is pulling it for some reason. But I don't know. Maybe we should just not do colors and just actually work on adding shapes instead of spending forever. I'm curious how fast this is. If I press E, which I really should rewind that to F3. Unpause time. And we're back down to 700. So something I'm doing is taking a really long time to write shaders to the thing. I just need to work out how to make this. It's so close. It just needs to be a gradient instead of whatever it's doing here, and it's crashed. That's not good. It's very much not good. I want to actually know why you've crashed. Oh, and it continues. Okay, that was weird. It has been running for like days, so maybe something in here. Performance. Yeah, something's memory leaking like a sieve. And you're using 26 gigabytes, so there's a memory leak somewhere. Something's memory leaking somewhere. Okay. Well, we're just gonna exit you because that's a lot of memory. How many like gigabytes of page memory was it? Weird. I mean, Chrome's still using fucking shitloads anyway. Cool. So let's just rerun that and go. I wonder how much better it'll run now. Probably not any better because. Anyway, I'm thinking we need to actually work on adding stuff now. So my suspicion is that it's this here. It's like because we're clamping F and we're passing in this, and this is like then we're passing in a negative value. So the thing is that, well, one, we shouldn't be using F. We should be using V. Okay. So since we know that we don't know that V is positive, which is what we were checking, this could actually be a negative value. Interesting. Okay, so what I think is we need to say like that if C is or C dot X is greater than 0, which means we're inside the shape, we need to say that F equals negative dx like this, and then it, we could just take the absolute and see what that does. Else. Okay, and then we pass in, instead of doing that, we pass in F here, which we don't need to then make negative because we've already, don't minus equals, just do just equal. What does that look like? I mean, better. There's still like a really obvious, like the wrong color. But as you can see, like it's actually backwards. Hey, wait, it's backwards, which means that we need to do 1 minus. And what I mean by backwards, I mean that if you look here, you can see that where the two colors meet, the ring further away is more red. See, like the orange ring is here and the purple ring is here, and it's because it means that orange is adding more when it's further from orange, which it means if we invert that. Okay. So it's definitely that this is not the right way of doing this. This means that they cancel out and we end up adding the same amount of color everywhere, which I guess it means that basically, we pause it again so that we can actually like look. So what's happening, or my suspicion of what's happening. So, welcome to the stream. I think what's happening is that this one here, as it's adding itself to the overlapping section, is it's adding like a tiny amount of itself here and a lot of itself there. And then this one is adding a tiny bit of itself there and a lot of itself there. And this is resulting in the gradient actually being the same color because the amount that both of them add is equal. The other issue is that we end up with like colors blending where like the red was overpowering because they're going to end up some kind of yellowish color instead of blending between. So div tells us how many colors it finds. The other possibility is that div is incorrect because div is counted up here and it's any shape within 2, which any shape within 2 is a lot more shapes. Like the issue is if I get rid of this, I think it breaks the thing. Like it has to be 2 because yeah, otherwise we end up with black because shapes don't get counted. So anything that's not greater than 2 means like this is. I guess this happens because all 3 of these are causing this to be black, which means that none of them individually are close enough to actually fill it in. And that's why it needs to be 2, is because we need to be twice that, because otherwise, yeah, interesting. Got something to do with the blending. Can we do like what do we do like 1.5? What I'm trying to work out is if I can reduce the K value, do I get like less overlap and therefore like the colors don't equally add? No, okay, so it needs to definitely be 2. It's good fun, you get multiple weird stuff now. Okay, so it's definitely K2. Well, technically it's not because of what I'm doing. I'm pressing F5 to refresh it, but yes, you can just if you go into your Cairo.toml and you say feature file watcher, if you change the shader, it will relaunch and like it will change the shader will be reloaded anytime it changes. You can do this with literally any asset. Like the file watcher causes Bevy to watch the files that are loaded. The only reason I have to press F5 is because I'm actually doing my game is in this crate and my shader is in this crate. And I'm using a symlink so that I can have the shader in my main game be the same shader as in my crate. But symlinks don't work with file watcher. The file watcher can't see that the symlink has changed. So I have to manually tell it to reload it. But again, that's because I'm trying to develop a plugin that's independent to my game, but Bevy doesn't like doing that. I'm trying to think how to explain the. It's my jank setup. Basically, if I actually do manage to get this plugin to work properly and release it as a plugin that other people can use, the shaders will be baked in as internal shaders, and hence I want them to be inside the crate like this. But Bevy doesn't. Well, I guess he could, but like it won't let me load the shaders relative to the crate itself. They have to be relative to the root crate. So it loads them when I call load from the root directory's assets folder, but I need them to load from the shader asset folder, so hence I've got them through a symlink so that they're the same file without. But yeah, that just breaks the file watcher. So I have to manually tell it to reload them. But yeah, that's it. Yeah, Bevy can do it automatically. Anyway, what was I doing? I got distracted. I really should just stop working with colors. I've been working on this for like 3 weeks now, and it's just not working. How do I make you gradient more? The hardest bits is like why don't I probably just drop it down to only a few colors and like actually get it to work with just like 2 shapes that I can like then print values out. Because the issue at the moment is if I try to print like the K value out, then like eventually hit any shape and do it, and it's like eventually one of these shapes will be 0 and it'll do it, and it's like anyway. Yeah, basically not quite. It's the symlinks aren't watched is what's happening. The Bevy will when you call let's see if I can find it. Where's my crate that reloads the shader? I think it's actually part of this, which is probably not the best place to have it. Update visible somewhere. Let's just search shader. It's called like reload shaders or something. We'll look for F5. Okay, F5. F5 and be case sensitive. That should find it. There we go. So the reload shaders system here, it literally just calls asset server reload and the shader path. But when you use the asset server, like if I say asset server, can't spell, dot load, like this, and then pass in like, you know, shader, like, yeah, it the load function here can only load from the assets file. It can't load from here. I would have to give it like a relative path. So I would need to be like, I want you to get out of the assets folder and then go into crates and then go into, you know, my shader. Like I have to give it a path relative to this file, and then it would work. Yeah, and symlinks just don't work at all. So that's why I have to manually reload it. But yet I can pass in the correct path. I'm shading shaders here, which is this assets. Means that when the crate's deployed, it would work fine. It's only in development that it needs to be manually reloaded. In theory, I could also do another way of doing it. I don't remember how. You can like make embedded, like if I was, when I actually publish the crate, they'll be embedded files rather than relative files like loaded in the assets folder. They'll be in binary, baked into the binary. But again, it's hard to do development because I can't modify the baked, like this core here. This is baked in, which means that if I modify this while the application's running, it won't do anything because it's using the baked in version, not the version that I can reload from a file. Yeah, Bevy has, there's not just file watcher as well. There's also, you gotta, think here, we'll go to crates. Nope. We'll go to, what is it? It's docs.rs, and we'll go to Bevy. There's a whole bunch of them. I just don't remember them all. Down here, and we go watch. Nope, spell it right. Watch. So well, apparently there's two of them. There's embedded watcher as well. So this one enables the watching in memory asset provided by Bevy's. So if you embed files, you can also make those watched as well, which I guess would be what I would want, but I don't know how to set it up. I had to like custom write a macro that I stole from the main build of Bevy rather than the 0.16 build, because they have a feature coming in the next version that lets you load shader fragments from the load shader libraries, which then embeds the file automatically and like makes a handle and forgets the handle, and all this fancy stuff, so that you don't have to like have a whole bunch of like, so this is how you do it in the current version of Bevy. You load internal asset, you pass in the app, you pass in the handle, and you have to like individually make these and hard code them with UUIDs, and then you pass in the relative path. I think it's from here. So like this folder, which is the lib.rs, that's why I'm going dot assets. So this is relative to here. So we go up one, which, so we're in SCR, and we go out of SCR, and then we go into assets, into shaders, and then this shader, the shader core. And then we have to provide an asset loader. So this will actually bake this into the binary, whereas they added in the main version of Bevy, which is going to be, I guess, 0.17 when this comes out, is the load shader libraries, which just shortcuts like the need to specify the asset loader and the handle, because if we go to this, it when you call this, will create the embedded path. It will create a handle, and then it'll load the asset to that handle, and then it'll forget the handle, which means that you have a strong reference to a loaded asset that's just never going to be dropped, and if it doesn't get dropped, it won't ever unload. So it's a way of like basically making static handles that you can always reference, because the shader's always loaded, but you never actually need this handle because it's actually the shader. If we go to the shader, I'm getting very distracted for questions. So where I'm using this import Bevy SDF core, this is that this shader has to be loaded, or the shader that exports that, which is the core shader, obviously. So this defines import path SDF core, And then, so when do it? Oh no, how do I fix that? Go, wait, no. Please. I kind of don't want to do that. Can I get you back down here? Okay, cool. So when I load this shader, it makes this available to other shaders. So this shader needs to be loaded, but it doesn't actually need, I don't ever need a handle to this shader. And that's what the loading libraries does, is like forces that to always have a valid handle, even though the handle is never used. Anyway, back on to oh god. Okay, so I need to work out some kind of way. So it needs to get more gray. So what I've been doing in the past is to try and debug this is we need to go like, when we add this color, we have power, which is what we're multiplying the color by, and then we say let power equal F. So we're gonna say I need we can let I, yeah, sure. Then we say .0 because the compiler is garbage in this thing. We are going to say that I plus equals power times by 1 times divided. So this is telling me how much power is added to each segment, and then when we get to here, we're just going to return a vet4 with a vet3 of I and 1, like that, and then we just turn this one off, otherwise it yells at me. And then we go, fine. Did I not save it? I mustn't have saved it. That at some point I added, oh no, that crashed. Yep, that's not good. Sometimes it doesn't work. I don't actually know what causes this. This is bad. Well, hopefully it actually crashes and gives me an error. Instead, it may have just leaked a lot of memory. No, it hasn't leaked a lot of memory. I actually want you to crash. Nope, it's just hanging. Okay. Well, that's concerning because that makes me feel like I may have made an infinite loop or something. Divided by 0, maybe crash the shader. I don't know. We should also probably calculate that outside of the loop instead of every single time, but okay. So now if we go back into our E and then go to our debug settings and pause our time so we can actually look. This here is the amount of each color we're adding. So as it gets whiter, we're adding more of the color, whatever color we're adding. But this is all equally gray, which is incorrect. It should be getting more, it should be getting darker as we get to the center, because we actually are getting further away from both circles. In the center is the furthest from both circles, and therefore the least color should be added. So that's what we need to work out. See, whereas this one, it's the same thing. We're getting more gray, but then when they start to overlap, we start going into the two grays, which should give a different color here than here and here. Anyway, you need to get this to being the same. Well, technically, it should be the same gray between the two. Interesting, actually. What if we instead said if x is greater than 1, then we're outside of the shape, and then can we just say that you're actually equal to 1 divided by. What if we did that? Don't add k. Just divide by the rate, which means that like if you're outside of the shape, you just add a constant based on the size of the shape. Still looks all the same to me. But what does that look like when we turn the color back on? Does that actually like give us? It gives us like a weird gray. We're also somehow getting colors that aren't getting reached, which is, that's fine. There's too many colors. Okay, so it can't be this. What if we did, so we know that x is in the negative. Well, see, I don't need it to be gradient outside of the shape. What I need it to be is not adding this. So we can't do that because we don't know the other shape. That's the issue, is that I need to do this in an agnostic way that doesn't care which shape we do first and which shape we're inside of. And that's what's going wrong, is that when we're adding it, we're adding the same amount to every shape. I think this v divided by this makes the most sense, but it apparently also just doesn't make a difference to the color. Can we add k and then wrap this with this? I think it also needs to be negative, might be what's going wrong. Yeah, probably. Well, that would actually make a lot of sense then. So if we said -1 divided by, because we're passing it in to our function, and I'm assuming this function, if you give it a positive number, is probably just plummeting them to 0. We'll just do that for now, and then we go. What does that look like? Oh, it did something. Something changed. Still not doing. I really should just be adding other shapes. Anyway, plus k. I think this is not giving us an actual gradient anymore. No, that just makes it lighter. If we did k divided by y, I think v divided by y would be the most logical. Oh, don't paste that in. V divided by y, because it still means that we get a number. We also know that v is definitely positive. Right, we need negative v divided by y, because we need that number to be negative. Hey, okay, that did something. Still doesn't blend them right, and it just wrecks the colors when they're outside, so that's not right at all. It's probably this clamp that's causing it not to change our color. I need to turn back on this one to return us our grayscale. Yeah, I don't know. 1 divided by div. Can we just? I'm just gonna go to saying, like, I don't know why I'm optimizing this. It doesn't make really much of a difference. Anyway, we're already at thousands of frames. But anyway, I was going to say times by div. And then technically I think the better thing to do would be to add div at the end, but we're going to go div equals div divided by 1 divided by 1 divided by div. So that should have exactly the same numbers, because we're just doing the calculation outside of the loop. Anyway, so I reckon it's probably got something to do with this being clamped. Oh, first off, again, we need negative v. Okay, wait, negative v doesn't work. But I think negative v is actually doing what we want, because as you can see, it's getting brighter where they overlap. It's just that it's too much brighter. Interesting. So we need to clamp that value at something. Maybe it's because we pass in f there. So if I said, like, you do this, you do this, you do this, and then you could do something else, but value with this would be what comes out here is we end up with black outside, because f is now a negative number. So if we go back to being positive, because we never clamped it, see, what's weird is it's darker where they overlap, but here it's lighter where two things are overlapping and getting darker around the edges. And then it's the same color outside, but different color where they overlap together. See, yeah, here's where you run into the issues. When we blend this way, it's correct, but when we blend this way, it's wrong, which means that we're actually not doing something that's agnostic of direction, which is annoying. It means that this is working correctly, because while we're inside the shape, but... So this needs to give the same value, which is why I was doing it all external to the thing, because whatever value comes out of this needs to be the same value that we get, so that we add the same amount that way. It's just not working. Okay. So the S and the V and the V, so the V and the... I reckon we need to divide pop smooth. And we're saying, wait, first off, you return a thing, so shouldn't it be v.x? Oh no, the smooth union takes 2 colors. And we're picking c.x, okay. And then again we're going to c.x. This is less than 0. Add yourself, yeah. And then do this. We need to work out what color amount you need to add when you're not here. Anyway, can we just say that f equals 0, which means that we are actually going to be adding nothing if we're inside the shape, which means we only see the color that comes, okay, which implies that we'll if we go to negative v now, we should actually get a color. Right. So this is the gradient that we're adding whenever we're inside of a shape. Interesting. All right, we're adding that to I, right? Yep, okay. So see what I'm doing here is I'm just zeroing out f if we're inside of a shape. So the only shapes that are contributing are shapes that we're not inside of, which concerningly is giving this a lot of gray, which implies that a lot of values, like all of these values, are getting color from you. No, that means I'm doing something wrong. Oh, it's just always 0? Wait, why is it gray then? That's concerning. I plus equals power times I divide, but power in this particular situation, oh, because we clamp between 0 and 1 and add 0.25. Yeah, don't do that. That's why it's gray in the center. Okay, now it's black. So if it's black, it means we didn't add any color. So these are adding color only where we overlap. So now we need to work out some kind of way of getting a different gray. This is kind of fine, to be honest. One option would be to clamp it, but I need to make this just a gradient. That's the trick, is to get this to be darker through here. So the issue is that something's happening here. So whatever value is coming out of f here, I reckon, is always the same value. So if we don't do that, and then we still clamp it between 0 and 1, and then times by 0.75. Okay, now we don't pass this out as a negative number because we want a positive number. No, we only need a negative when we're passing into that. So what's happening is no matter where we are, we're basically just always getting the same f here. So v, whatever comes out of v, divided by c plus k. So what if we just divide by c? Basically just means the smaller circles has a bigger impact. Okay. What if we said, I need this to be, so what if we said 1 minus the absolute of c dot x divided by, well, we know that it's negative, so we can actually just say negative c dot x. Alright, we're going to say else if c dot x equals 0, else this. So if it's equal 0, we're just going to say f just equals I know, basically whatever the lowest number that can come out of here is the issue with that. So we do this, and we add 0.25. So I reckon if we put this all in here, right, so this is the clamp it and sets it to 0.25, but then we've got the equal 0 just to clear that out. But we're going to say if c is exactly equal to this, we're just going to say that f is equal to 0.25. The f just tells us how much color to add, and so we're going to say, hey, if you're exactly on the border, which is interesting, because first off, let's say that f equals 1, I guess, so let's just make it white. And then anywhere we see a gray, which should only be the very pixel that overlaps. Interestingly, we're ending up with a gray here. Oh, because there's two shapes. That's why we're ending up with a gray there. Maybe this two shapes is causing us a problem. I don't know. Anyway, if x is equal to exactly 0, we're going to add just 0.25. Sure. So you add a quarter if there's more than one, if you're on the border. Okay. So I got to work out a way to get this to be a gradient. So if you're now 1 equals, why are you not turning into a gradient? Like, you should be a gradient. What if we, I need to work out how to not include the second shape that gets here. Var first equals true. I mean, the other option would just be only do first, but this is easier to remove later. So we're going to say if first. Okay, and then else, first equals false. False. Spell it right. There we go. All right, so the first equals false, and then we go, this should only show us, nope, apparently it didn't like that. Oh, no, wrong. I guess we'll just say show, and then we're gonna go show and show. Okay, so this means that we should get the gradient. Interesting. See, what I'm not following along here is surely this should only be lighting up one shape. So we say if C is greater than X, else if C is equal to X. So this is if you're inside the shape. Maybe we need to go. But the issue is I don't care about this. We only want to. So, but I think what that's doing is it's writing black, and then we're ending up with that. No, because it's always black, which means that you're drawing that, and then you're drawing that, and then they overlap. Okay. So how do I get you to not? Where am I getting white from anyway? If c.x equals 0, we're multiplying. So don't add that if it's exactly 0. So that's not what's causing it. This sets it to 0. This sets it to some value that apparently is just too high. What? How are you showing more than one circle? Like, it should only be able to render one circle's worth of stuff. I guess what's happening is it's hitting the first condition on this one and then hitting the second condition on that one, so it's drawing both of them. So I think what we should do is we should say show is equal to false if you're here. Okay, so now it's only rendering the gradient of this color. So only this circle gets rendered at all in terms of like, this is the gradient for this circle. So if we now turn color back, does it render what we expect it to render? Like, well, kind of. So it's all orange here, which is the kind of orange it gets, and then it tapers down a gradient here. Why is this still grey? I do not know. Something's adding to that color. Okay, what we could do is say power. Where's power getting its value from? F, and then F is set to 0 there, set to 0 there, and any other color but the first shape checked should return false. So I don't know where you're getting color from at all, to be honest. And that would probably track down my issue. Somehow you're pulling a color from somewhere. 1 minus negative. Well, I guess, because can't be, C has to be negative to get here. F is 0 there, so we don't add any color there. And then times by 0 is 0. We're just going to say F equals 0 for the sake of not having you render any color. How are you getting color? Because it's obviously not getting any color, so something's not setting it there, which means the only reason that this is different to that is that this shape is setting that color. Show equals false. Show equals false. Now, the only way is that U exactly equals 0? No, that doesn't make sense. If V is less than 0, continue. That implies some level of you're not rendering here because you'll know because they're adding together. Why? Where are you getting your color from? So c.x, and then this is negative. We know it's positive. Wait, first off, you go here. negative cx divided by y. Then we take the power of that, then we clamp that, and we do that. And but we set it to 0 anyway, so it's not that it can't be coming from there. My only thought is that somehow that shape is getting skipped entirely. If c dot x is less than negative 5, right? So what I need to do is work out when are you rendering the color? So yeah, I'm guessing it's if the wait, so something about these values is giving us a grayish color, which is possible that it's just like it's false for both of them, and then because of the way that I'm doing color, I'm starting. What color does the color start? White, black. So no, something is definitely providing two sets of color to you. Somehow you're getting hit twice. We're doing this to this. Okay, so 0.25. You know what it is? It's probably where there's two colors overlapping, which we're then dividing. We're multiplying by 0.25. So you're 1 minus this negative x, except we know that x is positive in this situation, don't we? No, we know that x is negative. I don't think it's going to make any difference. But, okay, and then we're going to go here. We're going to say if... Or can we just return? Sure. Color times f. C. So we definitely set the gradient there. We also just need to like make that weaker. So can we just like say plus k? Ooh, let's make it very orange. See, I need it to only be k that side. Times by div. Well, I guess times by div. The issues. So that's making that number bigger. We need that number to be smaller. That's making that number. Okay, so what we actually want is negative that, I think. No, we need the opposite of that. Okay, so we just started a smaller number. So we just go like 0. Ooh, what if we did, what was it, div? Oh, also multiplying by the div, which is now the negative value. So yeah. Though, yeah, no, you're still backwards. Okay, so we actually want div minus, and instead of multiplying those two together, we can div minus that. Okay, so it needs to be the other way. So we need to say div plus that, because that's going to be a negative number. Interesting. So now we gradient from u to u, and then in theory when we turn that one back on, it should gradient from u to u. So at the moment we're just returning that color. Interesting. So if I get rid of this entirely, first off, it's going to break this, and I don't know where this color is coming from. How are you getting? How is the cyan getting here to add that back in? The cyan should just never be show. Show is true once per pixel. So that implies that for these pixels, this is the first color and this is the second color. Can I say that show is equal to first, and then if obj equals equals I guess we could just say first. We don't need to even store that extra data anyway. If obj, then we just don't bother. We'll just say. Alright, I don't care. Okay, so this is going to mean only show the first object you check. Yeah, so I don't understand this because the only time we set f and our color here and this is equal to first, so that implies that this div plus this, and then we f, which is our power times div. Maybe it's this times div that's causing the problem as we're adding it back in. Somehow we're getting like a gray. See, color object is object times this, but when is pow not 0? Because pow equals f, and f, do we have to state that f equals 0? Is it like doing some kind of annoying thing where it's not initializing it, so it's using whatever value is there? Okay. So it was using uninitialized memory, which means that whatever value happened to be sitting there was the value we were setting. Which is always fun. Now this actually kind of needs to... See, because we're always getting 1 here. But we actually want it to gradient away, but we need to... The issue is that that doesn't overlap 2 shapes, which means that that's not correct, which is more like we need the gradient to be equal to that value there. Now, what is that value to begin with? What is that? When is that the case? Well, that's when div is equal to 1. Okay. So f is equal to div plus that. But we need to clamp that value to 0.25 because I think that's the maximum that this can put out. This can put out max. Nope. This can put up minimum. This can put out a minimum of 0.15, which means that if we said clamp this between that and 0.25, 25. So that should mean that this grey, this orange here, darkens down to the same as this orange here. Not quite, which is interesting because that implies that div plus c.x divided by c.y, when they overlap, is not 0.25. Interesting. So I know that the value is getting smaller. Maybe we need to put it through this. Okay, so if we do that, if we put f equals that f of that, well, we are all black, but that's because we actually want f to be equal to probably just this value. And then we need to work out what that value is in terms of like what range this value can give us. Here it is. And then we say, so f is equal to this, and then what do we do? We're adding f out. Okay, so then we go f out. So this is the opposite of what we want. So then we want this value. We want to say div minus this value to invert the direction of it. Okay, yep, which means we get gradienting slower, but we need to take so 1 minus, okay, so what if we instead said clamp of div between 0 and 0.25 minus that. Okay, so it means that one, it can't quite get far enough. And again, they still don't blend here, and it doesn't blend there. C.x divided by y. Because you're giving it 0.25. Okay. What if... So I'm passing that into there. So if I just get rid of this whole div thing, doesn't that cause it to gradient even on those edges? That's what I'm trying to work out. So if I just set f to that, this gradients properly. It's just the wrong direction. So I guess if div is less than 1. Okay, so we need to like work out that value. It's all good. Okay, so I'm still trying to work this stuff out. Okay, so basically this is I think incorrect, but interestingly, I think this is correct. Actually, no, we need to invert you too. We need to invert you by a different amount, I think, maybe. Because what this is doing, this is saying that you're equal to this, and I need to take the, it's not 1 minus. 1 minus this. Okay. Interesting that 1 minus this becomes basically grey. So what if I said 0.25 minus that? Okay. Now, my question here is, why is, oh, because we multiply by a smaller power. Right. So that's because we're multiplying by, down here, div is big. Right. Which means that because there's 2 of them, okay, so div can just be equal to, well, 1 minus there, which is kind of hilarious. So if I flipped you, what if I said 0.25, which is 0.25 minus 0.25? Okay. So that's giving us a number that's too small, because this number can be quite big. All right. So if I said like 2. Okay. So I need to invert it somehow. Okay. So 1 minus. Well, what if we just did that? Because that's what the 1 minus is doing. It's inverting. I'm trying to invert it back. What if we just pass this in? Okay. No. I don't understand. I'm not clamping it. I'm multiplying something. So why does 1 minus give us the correct gradient? Obviously reduced down, but the correct, like we've got a gradient. What if we instead passed in 1 minus here? Does this invert our direction? Well, it gives us a number that's way too big. Or I guess it's giving us a number that's negative, maybe? Okay. That's giving us a much bigger number. How are you doing this? Do I need to invert? No, because that just gives us a number that's always big. I don't, how do I invert you? Okay. We should probably go back to not outputting the color and instead just outputting that. And the main reason we're doing that is now we're going to this, which means, as you can see, we're just outputting white all the time because the value is just like really close to 1. So we had it at like 1 minus. Right. Okay. So how do I invert you? But only when there's 2 shapes. Because this looks right, but it's actually incorrect because it's still darker here and then gets lighter. So I need to invert you. What we should also be doing is maybe saying that here f equals 1. I think this is going to cause issues because it's going to... No, okay. So, as you can see, it's got this black line around it, which means we need to invert the whole thing. So, how do I invert the whole thing? Well, you just get rid of the 1 minus, but then that's giving us a number that's... So that's inverted, which I think is giving us a negative number, maybe? We can save. There we go. Go back here, F5. Okay, so now everything is white except this. Interesting. I think also I need to go back to this being F, this, because I think it's just adding too much other stuff. Interesting. Sure. So what's happening here is we're always getting a value that's... Wait, so F equals... So this value is just like always greater than 1? What if it's a negative 1? What's this? This is going to subtract color, which gives us negative colors, which gives us black. Okay. But if I make that color bigger and say like, hey, 2, I just need to know like what range. Okay. So what if I... First of all, I think I want this to go back to just give me black, please. Like, do my head. Okay. So. 3. Right. So if we go back to doing like 1 minus this, I need to work out like basically what that number is. So what's throwing me off here is we need to say, is this number really big or is it a negative? If f is less than 0, this is still not adding new shapes. Return, we need it to be red. So if it's red, it means that f is less than 0. Else, if f equals 0, we need to return green, and then else, apparently clamping, okay, no. That's not what I want. We're going to return back for 0 0 1 0 1, please. Don't make it transparent, that would be dumb. Okay, fine. So it's all blue. All blue means that f is not less than 0, f is not equal to 0, so f is greater than 1. Okay, so if f is greater than 1, and then if f equals 1, I'm assuming this function has some kind of rule that like it can't ever exceed. Interesting. So it's not greater than 1, it's not equal to 1, which means that it's less than 1. So it's less than 1. We should turn them green, red, right, red, yeah. So it's less than 1, which means that this value is always less than 1. So this is a value between 0. Okay, so what if I said less than like 0.5? Like, are we getting values between 0 and 1 and 0.5? It's blue, so it's only interesting. So where's blue? Blue is neither of these. Yeah, okay. So f is greater than 0.25. So basically, like, unless it's 3 circles, it's almost never greater than 0. Always greater than 0.25. Interesting. F is greater than 0.25. It's always greater than 0.25. But it's never less than. Okay. So it's always greater than maybe 0.3. Okay, 0.4. Why are we getting a value that's basically always identical? Wait, we're in the green. Yeah, in green. So f is greater than 0.4. So, but if f is greater than 0.5, it's still green. Else, if f is less than, oh, wait, no, I'm an idiot. So f is not less than, so it's always greater than 0.75. Okay. So if f is less than 1 and f is greater than, less than 1, it's red. Okay, wait, no, so it needs to be, if it's greater than 0.5, make it red. Okay, well, again, it's always red. Right, and then we want to say it, so if it's greater than 0.775, make it red. Right, do we ever not have red? Okay. So, and if it's greater than 0, make it green. That's confused me. Okay, so that means that we're making it green if it's greater than 0. So as it gets closer to here, it's a bigger number. So these numbers are bigger, these numbers are smaller. Is that actually how that works? Right. So we'll make it green if f is greater than 1. Okay, so it's never greater than 1. It's greater than 0.9. So it's never greater than 0.9. Wait, no, because it would hit the red every time. No, don't. So if it's less than 0.2. Okay, so it's never less than 0.2. 0.5. Okay. 0.25. Wait, that makes it the other way. So it's greater than 0.7. What is the 0. If it's less than greater than 0.7. So less than 5. Okay, so like it's always basically less than 0.75. Now if I make you like 6. Okay, we get lots and we get this starting to show up. All right, so that means that basically here, when you're here, technically that should be proportional to the radius of the circle, hence the green shows up. Okay, so maybe 0.5 is the correct answer? I don't know. Yeah, why? Why are you like this? So I think we want one minus this. All right, and then we're just gonna go, please render this. I don't understand. All right, so we know that the value is between here and here, so we need to clamp. I need to work out how to invert this, because this is, I think, incorrect. What if I said -1 minus this? Okay, well, okay. We need to do that, but then we need to say something like if f is less than 0, continue. Yeah. Okay. No. Plus. Does that number always be positive then? Okay. So interesting. Right, we're just like ignoring the shit. The f is less. Interesting. Wait. No, because I thought I concluded that f was never negative. If f is less than 0, color equals or just return red. Well, that's the thing, is actually returning blue. Okay. Returning blue. See, we're never returning blue because okay, so that means that at least on the first shape, maybe we should just get this to being every shape. Do that. I just want to see, like, does it ever return blue? Doesn't seem to ever return blue, so f is never negative. Okay, now we can slowly increment f. So if f is less than 0.2. Okay, so it is possible to get an f that small, which means that basically f ranges. Hey, look at you, you're inside of it, and entirely inside of another shape. Is that when? Oh my god. Okay. So first off, you're actually correct. Hilariously, if you're inside of the shape. Wait, what the fuck am I setting f to? Why are you correct now? That doesn't seem right. I think that's actually that this shape is just getting colored wrong. Like you're setting it to 0, something else is coloring that shape in. Okay, so blue means that f exists, but f is really small. Okay, which makes sense because I don't want you coloring in. Okay, yeah, that's probably means that. Why are you? So you're correct because you should be adding yourself, which to me implies that we need to find that I don't know which shape we were working on. We need to find a shape that has the characteristics that IU is looking at. Something. We need to find shapes that only overlap partially. Okay. Well, first off, we should probably turn back on the only do it on the first shape, because otherwise what ends up happening is I think they smooth over each other. But so if obj equals first. So now it'll only draw it on the first shape, which gives us a better understanding of what's happening. What's throwing me here is that this is interesting, or not. It is kind of correct, because it means that you are like lighting that way, but we need to like scale it better. But I think to scale it better, we just like pop you by like 0.5 maybe. Does that make the gradient harsher? No, it makes the gradient gentler. Interesting. We need to find those two shapes that were fucking doing what I was looking. This will do. Okay, so what is happening here? So F, this never happens. Right, and so we're saying that F is never, okay, so F is equal to the power of that times 0.2, which to make, how do I make the gradient steeper? I times you by like 0.1, smaller number, that's steeper gradient. I think that's actually more gentle of a gradient. Hard to tell, because I think again we're getting to the point where they're all adding their color on. U equals 0 and U equals 0, which means that the only shape that's adding any color is this shape, the first shape it checks. Okay. That one's gonna be annoying because there's multiple shapes in it. No, you have more than one shape, I can tell. Interesting. All right, so you're drawing this. Why are you not gradienting at all anymore? Interesting. You're not returning anything like that. Right, so what if I just said this? Right, what do you look like? What if I said, I'm 10? Does that harshen the gradient? Okay, that does harshen the gradient. Interesting. Y plus equals times div. Well, we can probably just get rid of this times div. I just want to know that power is correct. Right. So timesing it by, okay, so bigger number means harsher drop off. Okay. Okay. It's good to know, good to know. Okay, so if I then, instead of doing all this, just like let it fall through. Now, that's what it looks like. So you're gradienting that way, right? And then so we can say that the color is equal to the color times the power times the divider, because if there's multiple shapes, we only want to, right. So if I just turn that color back on, does that not just like work now? Like, shouldn't you be like mostly? Okay, so the issue is that this here, when the divisor is 1, so color times the power, so that implies, no, because we just, this is, I is just was just equal to power, which means that that is correct, but for some reason c dot x divided by c dot y, why is this not gradienting? So the divisor here is just 1, but that implies that power is just equal to 1. So we're going to say if power, if f is greater than, like, let's say 0.5, if it's more than 50%, return green. Okay. We didn't like that. If f is greater than, right. So all of that, f is greater than a half. That makes me feel like this just isn't grading at all. Greater than 7.5? No, okay, so it is gradienting, it's just gradienting very quickly. Interesting. Okay, so I guess that's the point. I'm multiplying by a huge fucking gradient factor. So if I did like a gradient, well, actually, if I did like 100. Okay. Interesting. Interesting. I should really return it like S and find out what the hell is going on. So if I just do that, and that gives me a gradient like that. So I just need this number to be like way bigger. So like times by 5. Because I still want it to reach across, but I don't want to reach that far. Okay. So somehow I need to work out, because apparently your gradient, like that, this is tapering down. It's just not tapering down as quickly as it should. You need to somehow clamp that value to start at 0.25, because 0.25 is the start of outside, like when we taper down of a shape. When we get outside that shape, we're at 0.25. So we want to continue tapering down from 0.25. So what if we did 0.25 times by this? Right. So that should continue to taper down and then continue to taper down. Now, why is this number? Why are you so much darker? Why? Oh, because it's a divisor of 2. Interesting. Right, so that's anywhere the divisor is 2. So what if we just didn't do times divisor? Then we end up like that, which is actually what we want, which is mostly this color when we're close to you and mostly that color when we're close to you. Now, if I turn this back on, we might have to go and show. Why the ampersand show is because I don't want it to be rendering the other color yet. I still want it to only show me the specific color I've got, which is this should look like a nice continuous gradient down. And then it goes and blends into this other color and it stops only where the 2 colors intersect, which we could still see a slight seam. Interesting. So here's the issue. So the blending is almost going to be perfect. So now if I, in theory, got rid of these requirements, this is just the else case. First off, it should just still look... Okay, so it's not quite blending out here. And you can still obviously see where it stops, which is because the exponentiation here, which is negative cx, so this is faster than this. No, it's slower than this. So the rate that you lose color from yourself is slower than the rate, hence you can see the sharp line. But that looks really good there. You can't see the sharp transition line as long as there's no exiting and entering. Okay, that's interesting, because that means it's basically a threshold problem. It's a when blue blends in, because blue blends deep enough in, we need to clamp something. Do we need to clamp something? Then we need to clamp it after. So the idea is we multiply u by 0.25, so the maximum that can come out of here is 0.25. But I could make that number bigger, and then because we multiply by 0.75. Interesting. Okay. So that seems very much correct. So what I want to do is go back to just only outputting the power that we're multiplying everything by. So one of the problems was we were multiplying by div. Okay, interesting. Here's the thing. That blends, but it doesn't quite like the transition because you're dropping to near 0. Interesting. It's because you're dropping to near 0. But for some reason, when we go to the edges, we never get to near 0. We never drop so sharply to 0. We probably do, you just can't see it. No, we never get that far out. Which means we need to clamp u to whatever the value is there. So I need to, I guess, clamp. The output of this is basically what it comes down to. We are adding the color, we're adding the power. I need to go and show if show, right? So this should do it. Okay, so as you can see, you can still see it there, so we need to clamp it. Basically, it's just connecting it to 0. So we take this and we need to say like f equals f clamp. Well, maybe it's adding a negative color. It's not. Okay, so it's never getting negative. Oh yeah, no, f is never negative. Okay. So we times it by 0.25, but then we want to clamp it between well, I guess it is 0.25, but that's besides the point. We want to clamp it between like 0.05. I don't know, how would you work out what to clamp it to? That's the issue, is that like we need to make sure that this value never drops low enough. That value can never drop low enough to end up with a seam. We need one with a better seam. See here, because it's adding the two colors together, we're mostly white here. How do I get you to not have a seam? Well, I guess the idea would be to plummet it. Maybe we're not going fast enough to 0. No, because it's basically that it's brighter, and then it drops really quickly. Like if I make this a 10, I'm assuming first off it'll shrink it in, but that line still exists where we transition from one to the other. Interesting. Well, the one option would be to make this 0.5 and say that the minimum that this can be, by 0.5, means that most of the time it's mostly white in the middle. Interesting. Okay, so that kind of works to hide it because it means it doesn't drop nearly as close to 0. What if I said that you're clamped to 0? Okay, so what I need to do is make like the minimum color it can go down to is okay. Interesting. The idea is that this one's adding black there, and then when this one comes through, it should blend that back to white, which I guess we can do by removing. If we move, I guess we just do this on its own line. We can say close else open like this, and then we just comment this one out. Go, okay, now render the whole thing and show me what does it look like when they're all blended. Okay, so the outside where there's not two shapes looks fucking perfectly blended across. Well, not quite there. When there's only, okay, interesting. So it implies that this should be darker, but that should be fine because again, you're the only one adding that color, and then you blend in and then blends. Okay, this all seems very correct except the annoying seam. Oh yeah. Yeah, that would explain. Interesting. What if I said greater than or equal to 0? But I think greater than or equal to 0 would just give you 0. Okay, so what if we go first off back to only showing show now? Do you have that horrible seam now? No, so the seam was basically introduced because we were just setting a value to 0. No, interesting. I mean, it's looking actually really good. Like it's gone now. So I think that fact we were setting that this is else equals f equals 0. That doesn't actually make sense because f is reset every time. So why would setting f to 0 there have any impact at all? Okay, but I think this is where we need to set our value. This is like our at the transition boundary color, and then we clamp that, and that should work. Okay, so let's turn off show, turn this on, and go, can you see the transition between them now? Well, there's a really obvious line there, but that's because I boosted this by half. So if I send it back down to 2.5, I don't know, this back up to 7.5 and this down to 2.5, like that, and we go, hello. Now you transition, the boundary's kind of blurry there, then it gets kind of dark, and the boundary gets... I don't see a sharp line. Let's see if we can see it with the colors turned on, because obviously the colors are much more impacted by the... Ew. Okay. First off, we're multiplying this by 10, which multiply by 5, which will slow the gradient down. It's back. Okay, so it was basically that we were making sure that no matter what they were blending outside of the shape, they always blend in there. And then when they're inside, you can sort of see the edge, but it blends nicely. Okay, so you can still see it. Right, but I think what's happening there is we're setting f equal to 0, which if we just turn that off, what if we said that when x is equal to 0, we just have to equal 25, 0.25, because that's saying, like, that's why there's a sharp transition, is we're saying when you're inside the shape, you're at minimum 0.25. And then when you're at the very edge of the shape, you're not 0.25. Okay, so that should give less of a distinct seam, but you can still see the transition. Now, why can you still see the transition? Because you can clearly see where this shape ends and then it starts blending, and then you can see where the blending just stops. But what that tells me is, well, partly that this needs to keep blending to yellow, or we need the yellow to actually peter out before it gets to red. I think that's what's happening, is that this, maybe this needs to be K. Huh. Okay, so we need to boost this, whatever, like, so 2.5 is too little. Like, it's quite clearly getting quite black outside of the shape. But that's interesting. We could also say that you only get the div. I don't think we use div anyway, but what we could do is we can count div up to tell us how many shapes we hit, because these shapes technically hit no shapes. Which means we could make them brighter, because they just never hit any shape. So I don't think we use div anywhere after this, do we? Do we use it before that? Okay, so we were using div, but then we decided not to use div. Okay, that's good. There's one over here. So what's happening now is that we've just made it big enough that it always merges across the in the join, but it means it still works even where they're not joining. Okay, so, and then case 15. So okay, interesting. So first off, I feel like if we just made this not so small, okay, now we're getting a boundary layer between that, and that's what that was about, is it was clamping it down, making sure that this value and this value are the same. So when f is equal to 1, right, otherwise you get the halo effect. Interesting. All right, so first off, I feel like I need to make this taper less aggressive. Right, so now there's like just less of a taper in the general shape of it, and then we can keep a rather aggressive taper here, but now we can clamp U205 and U205 like that, and then we go. So now they just sort of taper less, which means it comes back, because we now say, okay, so that means that this value doesn't actually need to be K. This can be whatever we want it to be. We're going to make it 10. Okay. So here, how do we make you blend properly? So I just need it to not transition from having some yellow. What is your... That's the question, is what is your value here? And how do I make sure that value... So what we were doing is, it was like we needed to multiply 0.5 times this. We need like half of this value. That doesn't seem right. Okay. Thing is you can now see the borderline. You can see where it transitions from one shape to the other, which means that that's actually not doing it correctly. You shouldn't be able to see where we transition from one shape to another, like from one blend, from inside the shape to outside the shape. It needs to just blend out. Yeah, so you can see it here, and it shouldn't be doing that. But is it really doing that, or is am I just noticing it because I know it's doing it? Oh, you need the same thing. We need, if we clamp the minimum at 0.1, no. We had it looking much better. So interesting. We definitely don't want to do that, because clamping your minimum just causes you to bleed. Okay. But if we, so what are we doing? We multiply by half and then add a half, which then we clamp, which is not actually the same thing. So we do that plus 0.1. Yeah, okay, so so I think we definitely don't want to do that because it's pretty obvious when you're doing one from the other. Interesting. So it's happening here because this shape is, the transition's not, it's not fading out quickly enough. But how do we work out what quickly enough is? Because otherwise it's just arbitrary. We need it to fade out to 0. And the maximum fade distance is k, which means that you actually should be the maximum distance you can be away is k. Right, I think I'm onto something. So the maximum you can be is negative k, because if you're more than 2 times negative k, which means that we want this value to be k divided by c dot y. The interesting. So it's made everything much darker to start with, which is not correct. But it's interesting because I think that's somewhat in the right direction. The issue is that we need this value here, which I think 2.5 definitely fucking looks way, way better. So we're going to go back to 2.5. So it makes that 7.5 and then this was 2.5. 2.5 just felt like you couldn't see the transition. Like it just feels like you get outside and it drops much quicker. Okay. I think you can still see it, which means we need to have the same blending coefficient, which I guess would actually mean that we need to times this by like maybe times by 2. That should make it gradient faster. Interesting. We gradient it by 10. Interesting. What's throwing me, right, is that we're still quite clearly, you can tell when we go from one gradient to the other. I want it to taper out. I guess it's never possible because one's R and the other's so we'll go back to the regular taper. Okay. So they just sort of fade out. They just sort of fade out. You can still see the transition, but it's fine. It actually looks pretty good. Okay. So what am I doing wrong? What I'm doing wrong is, so first off, we don't have showtime. Okay, so it blends so well here. Like you can still kind of see it, which I guess is an issue, isn't it? You shouldn't be able to see this. How come you can see this? It's because we're not blending proportional to the distance we're inside of the other shape, which is where div was coming from, right? Because div was telling us how far into the other shape we are. So I think what we need to do is we need to say, hey, if c is greater than 0, so we're inside a shape. Only if we're inside a shape do you add div. Now, that does kind of mean that we probably need to start div at not 0. Okay, well, we don't use div anyway. So then we say 1 divided by div, which annoyingly is going to give us infinity. So I don't know if that'll crash, but we'll get infinity if we're not inside any shape. So we're going to say if div equal. Okay, so when we say mol, we're going to make this let mol. I don't know if that's allowed, but anyway. Then we're going to say if div equals 0, we're going to we're going to say that your color, or discontinue. Right, so this, if I understand correctly, should mean that anything outside of the shapes is black. Right. And then we need to say, hey, when you do this, which is mol, so when we add power, we need to times mol, right? Then we do this. Ooh, no. It's interesting because it's saying that like this will blend better, but we need to do that. So what's happening now is, because that's the only spot where two shapes are overlapping, so you go, okay, so that's it. Okay, you go back to 1, but because we're inside of the other shape, not ourselves. Interesting. So we need that to be interesting. So how do we know? Because div is okay, so but that's the issue, is we know that div is greater than 1, so we know it's blending with us, but we know it's not us, which is where we can use only set, right? So only do this while you're inside yourself, maybe, right? So we go F. Oh, okay, so apparently that doesn't work because power hasn't been calculated yet, and power is just F. So F, right? So we do that, we go F. So now what's happening? So we're well, first off, we're adding color twice, so we need to get rid of this. We go, okay, so F. Interesting. Now it's just got no blending because we just only when we're inside of ourselves, right. And then we need to say that do the same thing, but we want to add we don't want to use mole here. So this is like if we're inside of the other shape but not inside of ourselves, add our color times F. Interesting. So it's actually the other way. I think we want to so right, if we're the only shape, then mole is equal to 1. If there's two shapes, so we need to gradient from U to U. So first off, we just don't want to do this for now. So that gives us a nice blend. Now, what we need to do is basically go, hey, if so I feel like this isn't gradienting, but I guess it is. It's really obvious where you transition from one to the other. So maybe we need to say times mole, which means 10. No, so making this number smaller slows the rate of gradient. Times mole, which means you slow down the transition. So div is the number we found. So if we say div, we say speed up the gradient when you're inside of a. I mean, that kind of makes sense, but now it's even fucking obvious. But that's. Okay, so this is only the ring, so it's not actually going to change anything that we're looking at. But it's one. F5. No. Save that and then come here and F5. Okay, so to make this transition to red, so first off, let's just stop this from doing that. So now we'll just have that. We need to go, hey, I need you to like kind of, you don't really look like you're blending at all, to be honest. Which is kind of like we need F times div times 10. So when div is 1, we just do 1. Okay, so that's making this gradient faster. But we only want a gradient faster. So that's divide by. So mole times 10. So basically if mole will be 1, which means it will be 10, but if there's two shapes, mole will be smaller. Okay, so it's actually, annoyingly, we would need to say F times 10, F divided by, no, F times 10 makes it gradient faster. So if a mole is equal to 1, we want to not do this. Okay, well, we can probably just do that. So we can say like, if mole is less than 10, we want to say that f equals times equals 10. Okay. If mole is less than 1, because obviously molar means that you only found one shape, then times equals, okay, so no, not plus equals, times equals 10. Right, so means we gradient faster, which I think it actually seems to be backwards. So I'm almost certain making this number bigger, like times by 100, should make it gradient faster, right? Like that's how that works. No, that makes it gradient slower. Okay. Which I think means that we just times that by mole. Making this number smaller, and then more colors will make it gradient faster. This should just be f is equal to 1. Why are you... Okay. What's throwing me now is this is not what it looked like before. Why do you not look the same? Surely it's not this. That would imply that mole is always less than... Okay. That looks more correct. Okay. So, first off, we just don't want to do that. Then we want to say that mole times... f times mole. Right. That means as we get smaller, we gradient faster the more colors are involved. Okay. Interestingly, that seems to make it, again, it's like a sharper edge. If I get rid of this, if I just do this, that makes no sense to me. If I times you by 10, this makes the gradient slower. Maybe. I think that's slower. Versus if I times you by 0.01, like a tiny number, the gradient is, well, apparently just very small. So if we pass in a very small number, we get a very small number out. Interesting. But I think that's actually making the gradient slow. Am I doing something with this? Oh, wait. Are we modifying f? No, we're setting f to this, which makes f a very small number. We're clamping f and we're adding, so that the smallest f can be. So the smaller we make this number, the closer to very interesting. Okay, can we do this instead? Hey, like, what the fuck am I doing? Like, why are you getting gradienty slower? Okay, so smaller number makes slower gradient. Bigger number makes slower gradient. Okay. Bigger number means further out before we go to gradient. So in terms, a faster gradient to 0. More stable in the center. Probably mostly because of this, but so wait a second. E to the power this, e to the power x. You're negative, so we're to negative powering. So okay. Interesting. I mean, this seems correct. So this is what we want to do, but we want to say is if mole is less than 1, then say f times equals mole. That makes it smaller, which will make its gradient faster. Okay, interesting. See, because we have no idea, we can't work out how far inside we are, which is okay, so it's always going to have that problem, is that as soon as we transition, so we just can't do that. We can basically use div to determine when we're inside of the other shape, but we can't really correct for it being inside the other shape because okay, if we just gradient faster though, like if we just said times by, like, let's just say 2, make this number bigger, makes us gradient faster, which just gives us a less obvious edge for where the shapes transition from one to the other. my issue here is I feel like it's possible if you have 3 shapes overlapping for this value to get greater than 1. So we need to say you do this for every shape, right? And then we need to say here, and we say, hey, well, first off, for some reason we've got this thing called pow. Okay, power is equal to f, and then I plus thing. Okay, so what I need to do is say if I is greater than 1, I need you to return vec for 1. No, it needs to be like 1. Yeah. Okay. So if they see any red, yeah, so these reds mean that something's wrong because we're so what we need to do is what we're doing here, right? So we take this, then we're clamping this value between 0 and 75 basically, because it's 0 and 1, but we're multiplying by 75. So we're scaling it down, but clamping between 0 and 1, scaling it down. Now, when we scale it down, we need to probably also multiply it by mole. And then we add this, we need to add 25 times mole. So in the case of there only being one color, we're adding 25. But if there's more than one color, we're adding that. So that should work that when we do this. Okay, so it's still possible to get greater than, but that's only possible because I think that's actually because this out here is adding those extra bits there to do that. Okay, so it's still possible. Interesting. So that's probably why the colors look so, I mean, technically the colors would look wonky only out here. So we did this and did this, and I just turn that off and then go, hey, what's it look like? Well, legitimately you can't see it because it's only, but if we can find the shapes that we're going, hey, these shapes look really obviously blended. Okay, so first off, I've broken everything. That's annoying. Interesting. So we need to turn this back on. Let's get rid of the times mole like this. There we go. So now we're adding color multiple times, which is incorrect. We don't want to add color wherever we're adding color here. Okay. So then it's just color times power. Okay. Let me do this. We just save this. We do this. We go. Okay. So you're having a problem because for some reason we're using mult somewhere. Okay. So the issue is that we're using mult like here and here. And do this. Okay, so now they all blend properly, except, you know, obviously here, but we're gonna go turn on our debugging red if they're getting a value greater than 1. Okay, all of this looks the same color because it's all just greater than 1. That's why it doesn't trend the gradient properly, is because we're just somehow returning a value greater than 1, which means we need to somehow work out, but only here. So I think the idea of that is we're adding the 0.25 twice. So if I reduce the amount of 0.25 by mole, which means that basically if there's 2 shapes, we halve the minimal amount we add, which is the minimum color they can get down to. All right, so that transitions like these, which like it looks better, but it still needs to be interesting. It also somehow makes these colors get greater, which makes no sense to me, to be honest. Like, I don't know how this bit here got greater than 1 by setting that value lower. It implies that somehow this value got to a negative number, but that doesn't make any sense. Okay. Yeah, see, I don't follow, first off, like how that actually happens. So like, how does multiplying that by mole, like, first off, can mole somehow get negative? It's actually probably that it's there. I'm just actually seeing the transition. Okay, that's what's happening. Right. So adding less as a baseline add, which maybe that's our problem, is that we are just sticking in no matter what, adding 25. Like, if we just get rid of that, and what do we just like Well, I mean, it kind of fixes the problem, except you still sort of plummet to 0. So we need to not let you get to 0. How do I make you not get to 0 without allowing multiple iterations of you to get? How do I shift this up? That's the question. That's the question. What if I make this number always slightly smaller, like minus 0.01? Means that like you never reach. Hey, okay, so you never reach 0. It's still, when there's lots of shapes stacked on top of each other, possible to return that. But does that actually look okay? Not really. It kind of looks a bit stupid when you stack too many colors on top of each other, too many shapes on top of each other. But we should probably also turn this bit off so it stops messing with the okay, so they still don't really blend into each other. Interesting. But it does mean that now it's interesting. You don't. The issue is, I think this all sums to the same color. It's not gradienting here because U plus U sum to the same number. Okay, so if we instead output what the sum of the gradient is, right, the sum of all powers that we apply, this is all not gradienting anymore. But that kind of makes sense, because as you transition this color, you transition that color. So it actually makes sense for this to but this darker section here is what the issue is. The fact that it drops in intensity. Because we don't peter out into it. Which, if we just make this like, so again, does that, I'm trying to work out what it's doing. It could be that we're doing this multiplied by 7.5. Like, now that I'm doing it this way, that it's not important. Kind of. I just need this value to like never be too low. See, it's still always gonna have that. But I guess that's the idea of the other one, where we can blend it when we know we're outside of the shape. So I think if we set this like, I think 0.2. Right. So now the issue we're getting, which I guess we need to still return this, is, hey, are these values ever getting greater than 1? Then do you have an issue, and please just don't. Okay. Yeah, so we are in fact having issues where two colors overlap. Because see, the issue is that it's all one. We need it to transition. It can be one in the middle, but we need it to not be. It can't be one at this boundary, which is annoying. If we add k, I'm just trying to like work out what the generic is for. Okay, well that apparently negative x divided by this add k. Right, now you're doing the division first. It's this, like this. Okay. So it should make it always get smaller, which means that the... Okay, so hopefully with that means that it'll always be completely inside. You make sense because you're actually all one color. Like, this is a circle completely inside of another circle is what's causing that. Okay, so they all have that dot, but in there, what does that look like with our colors turned back on? Okay, no, not with that turned back on. That can... Oh, I guess we have to turn that off to be able to see the other option. We need to turn this and swap that and go, okay. So, do they look blended properly? I guess. There's no obvious transition from the red to green. And then this one, I think, is just that the green's more obviously contrasted on the red, or because we're closer to the center of the red, it's more obvious of a drop. Which is fine. Now, I would say, actually, if we scale it by 0.75, does that break everything, or does that actually, was this scaling not doing anything? Right, I think. And then we need to add back the 0.25. Right, like this. Right. First off, I don't think that works properly. So basically they're kind of transparent, and then we save this, and then we go over here and apply this. Okay, so we can't just be adding the half. Adding the half is what's causing this to happen. Okay, because we're dividing by k. Right. What if I always added it a little bit? It was always subtracting a little bit. What if I always add? What if I add 0.25? Because right now it doesn't really fucking do anything. It's basically capping it out. That it means that it's always hitting that minimum. Right. So if we get rid of this. Well, get rid of this too. Okay. It's probably that 1 minus. Why don't we f equals this. Then we're gonna clamp. What if we clamped that between 0 and 1? Right. And then I'm gonna clamp that between 0 and 1. Well, it actually doesn't make any sense. What does that actually do? Right. And then we want to say we need to invert it. So it's 1 at the edge, 0 in the middle, and then it says 1 minus. Right. We could also just like times it by 5. So the issue is that, again, this section here is getting a value greater than we times that by 0.5. Well, actually, wait. So there's the option of scaling it down by 0.5, or we could just clamp it between that and 0.75. That means that the gradient just sort of cuts off. Okay, that's why you don't want to just cut the gradient off. That means you want to go like multiplied by 0.75 plus 0.25. I think that's actually the other way around. It means that it's always minusing at least. Right, so you want to clamp that between... Well, we also already know that that can't be outside of 0. Well, actually it can if this number is greater. So we need to clamp that between that and that. And then we need to go, actually, your 0.75 minus that plus 0.25, which gives us a minimum value of 0.25. Okay. Sure. I think the issue with this is we're just like getting the edge, we're not grading it away. So I actually just think that just 1 minus this clamped between 0 and 1. I think I'm trying to be too fancy with it. It's just not working. And I've also, again, I've spent fucking hours not implementing squares. No, okay. This color blending shit just does my head in, and I can't work it out. Why did my shader not compile? Because I said clamp and then didn't give values to clamp between. Wait, what? 1 minus... because one of these values is an integer. I don't like this. Like, the shaded language is pretty angry at you for not doing the right types, but also like does type coercion for you, and it's like, it doesn't make sense. Anyway, so this blends properly. The issue I feel like I'm having with this is that this blends to 0, and then when I turn this back on, which I don't remember how to do this, I think it was this one, but I've got too much shit. If I do that, Now we jump to that because we blend to 0. So we need that. What we need to have happen is to not have you blend to 0, which was what adding 0.25 was about. Which in reality, I think just means multiplying you by 0.25. Oh wait, 7.5. So now the maximum you can get is 1. Yeah, there we go. Hey, it blends, and then it blends, and okay. So I just need to. I'm still not actually showing anything outside of that, which is because if div equals 0, so funnily enough, we can just say, hey, if div equals 0. It looks so motley and horrible. So the thing with that is that implies that we can actually have a different blend function, because we can just check if div equals 0 for the outside here versus this blend here, which means this is the blend, this is this bit. So we can say if div equals 0 means we're the outside blend, so we can do that, but we can say this is the blend that we use only when there are no other shapes to then this is else, because that means it's doing it all the time now. Only when div is not equal to 0. So it should look identical because we didn't actually change the formula, but that means that I can do something like I can make that's a faster. That's our starting point. Because basically the idea is that you can never get below that, so we want to start from there. And then if I say like 5, then only outside of the shape. Hey, okay. Now interestingly, you run into the same issue, I think, because this has 0 shapes, but this also should have 0 shapes. It's just that, like, they obviously don't blend into each other. Now, why are you not blending into each other? Surely it's not just that 10... 10 feels like a magic number, and I don't understand where 10 is coming from. Why does 10 work? My suspicion is that, like, anything greater than a certain number will work, because it's, like, it's basically blending it into oblivion. No. Well, kind of, actually, because they blend perfectly here as long as this blends out before that blends out. They have to finish blending between the two shapes, which annoyingly means that probably S is somehow related. S is the sign distance function. God damn it. Which probably means we actually want to use... I want to go, like, if you get to here, can we say, like, if S, because this should be in 0 shapes, so if S is greater than 1, can we return red? Right. So this is, okay, so anywhere that S is greater than 1. So can we say if S is less, because we know at this point S should be positive. Yeah, so there's nowhere outside of the shape, because we're in that specifically outside of the shape. The S is at least, so does that mean that if S is greater than K? Okay, so where S is greater than K, both shapes overlap. Right. Interesting. Wait. If I said if S is greater than K, like, is this anywhere that both shapes overlap, or is this anywhere inside of a shape where at least... Interesting. Well, actually, it's interesting that it's there too. But it means that, like, it's not where they gradient out, which means we can have a different gradient there than the gradient we have for here. Right. So if you're less than 0, chuck that in. If you're equal to 0, chuck that in. But that means that we can actually distinguish between the inside transition, which is good. That's interesting. Okay, so this here is outside both but shared, right? And then else. So this would be outside outside both but not shared. So this is where we'd need to gradient from that down, which I think is what we're doing here. This is this gradient here. So that means that we kind of want to say, we comment this out. So first off, I want to put the comment on its own line because technically the comment applies to. So this is outside of both shapes but shared. And then this is outside of both shapes but not shared. Right, so if it's not shared, use K15. I don't know if that's actually a good gradient. It looks like a pretty good gradient. Like it sort of blends in, it looks good. So the only spot that we have a different thing is these black spots where it's shared. Okay, so I need to somehow highlight this section here and obviously this section here that you can't see, which is interesting that you can't see it. Outside of... interesting. First off, K is great. Yeah. See, because this is shared though. Black, oh yeah, but shared. So this isn't shared, which weirdly means that this shape doesn't actually have enough of an impact to do that. This is really obvious, which is interesting. I need to work out how to highlight just that. So when is just that? That would be here, right? Like if we just said, so first off, if we just, well, I guess never set F, right? Well, no, we need to not never set F. We need to like return red, I guess. So if it's red, that doesn't work because we have stuff after the return. Show equals false. Never actually using show. I feel like it's better to never use show. The show was just doing what show was doing. So if I do this, so red annoyingly is the shape. So basically, if we get to red means that we are in the blending section, but also inside the shape. So this is inside other within blend. Right. Okay, so if we get to here, that means we're inside the other shape, but within blending range. Now, how do we get you? I just feel like this just needs to be a sharper drop-off. Like, that's the issue. But I can't actually tell, because, again, you can't see that the red's doing it, which makes me wonder if the red's actually... Well, obviously it must, because it's still... Okay, so... Is it just that I'm picking shapes that just look kind of bad? Or, like, shades that aren't supposed to blend together like that? Like, it could just be that... These all should be pure colors, though, so... Here's the thing. So... Something's wrong here, because these aren't blending to nothing. These aren't blending at all, which tells me that it's probably that power is getting greater than 1. Yeah. No, because it's still doing it here too. Interesting. Interesting. Okay, so... Well, actually, the thing with this one, actually, I never actually tested this, is if we go here and say, like, return green, yellow. What I should do, actually, is stop setting the color altogether. Alright, so this makes everything, well, apparently non-existent. Well, because it didn't compile, so I said return Y. It doesn't exist. Okay. We do this. Okay, so now we're only red where the number is greater than 1 and we're black everywhere else, which means we can now start setting colors. We can say, hey, if we get here, I want to say, first off, don't return this. Right. So we're going to say, hey, if you get to here, we're going to say, color dot x equals 1. Right, and then if you get to here, color dot y equals 1. And then if you get to here, color dot z equals 1. So we should only get primary colors because it implies that these are all exclusively never reached by anything else. Yes. Okay. Good. Now, what is red? Red means outside of both but shared. It technically should be outside of all, but outside of both but shared. I'm curious why this isn't shared, but that's fine. And then, so green is Y. So this is outside of both but not shared. Okay. Interesting. I still don't have any fucking idea what's going on. Okay, so green. Green needs to be a gradient from the color we are to 0, which is green, which I think is you. You're from 0.25, which is the outside of a shape, to green, to 0, right? 0.25 times the power of u to u, which I believe when... Wait. Should be x divided by maybe k? Because we don't care about the radius of the circle. We kind of do care about the radius of the circle. We want to drop based on k, like when we are k units away, because that's the idea. Is I don't actually understand how far away this is. Can we say if, so just don't do this because this sets a color, I believe. If c dot x is less than, right, we have to be less than 0. So if it's less than k, can we say that c dot y equals not c dot y color dot y equals this? Okay, so this, we save, did it compile? Did we reload it? Okay, is it reloading? Yes. Okay, so this implies that x is always less than k. Well, because that's because x is a negative number, less than negative k. Thank you. Okay, so that interestingly is another section. So this is a different distinction. If you are less than, there's the issues. Okay, so then we want to go do that. So if s is this, else if s, so that, and does that work? I don't know. The formatting on this is getting horrendous. Yeah, shift tab. All right, so what we're looking at here, and this off, is that if x, so if it's red, it's outside both but shared. If c dot x is less than negative k, see, this is the thing, is it's shared, but it's like a transition shared. It needs to blend between both. If it's green needs to blend between both. Red, interesting. Red doesn't need to blend between both, maybe. It does, but it's like okay, so I guess red doesn't transition to 0. Okay, outside of both but shared. So this is also outside of both. Outside of both and shared. Okay, so outside of both but shared. So they're both outside of both and shared. But this one, if you're here, if s is greater than k, then you not to 0, right? So you just never go to 0, not to 0. And if you're outside of both and to 0, right? And then this one is then, we need to set its color. So we probably turn off the Z maybe, and then come here and turn on the Z here. So we go anywhere there's blue. Where is blue? Okay, didn't like that. Else, we have an else somewhere. Outside of both and shared and to 0. So we have an else somewhere. What do you mean? Where is this and why are you complaining? Line 150. Do you think that's not acceptable because you close that, right? Okay. I do that. Okay. So anywhere it's blue. Oh, interesting. So multiple things can trigger the cyan area, which means that whatever cyan is that it's outside both. Interesting. Okay. So for it to be getting outside of both and shared to 0, so to get yellow, I'm assuming that was yellow. Was it? No, it's not yellow. Fine. So those sections were green, right? Yeah, green. Okay, so it means that it's both green and blue. So this is outside of itself. So the blue section, the blue tells me that I need to pivot this to ground, which actually makes sense because that means that we want to blend. We want this to go from 1 to 0 or from 2.5 to 0. Okay, so interesting. So not shared. Okay, so this. Okay, so this one goes from 0 to 2.5, right? And this one is the same. This is from 0 to 2.5. Sorry, from. Okay, so that means that when you're both, you need to. Interesting. So when it's cyan like that, it means that it's blend from you to you and blend from you to you, which as they do that. So when we get to this purely green, what would purely green be? Outside of both and shared, but they are shared here. This still has some shared. So it's not that they're shared or not shared. Well, green is always shared. Green is 100% shared. So if you ever get to here, then you are shared. It's that you're not shared because you are also outside of both from. So it's specifically here we need to add our self, which is this? So this is from 0 to 5. Right. So the thing with this is if we do this, and we go. First off, you're apparently just not doing anything. Right, we have to start adding power back with color. But what we want to do is we want to say don't set F here. So we're going to do is show because we don't use it. We're going to say F equals 0. So F equaling 0 means that all our internal shape should still be 0. Okay, so what does this actually look like? Interestingly, that is the only part of that. Okay. Why do you have a tiny red ring? You are dropping awfully quickly, which I think is because it's C to X to okay. Interesting. What if we said X divided by, so the smaller this number is, the slower it drops. So I think we actually want you to, well, let's turn back on the main color just so we can see what that looks like as well. Does it blend nicely from one to the next? Okay, it blends nicely from one to the next, which means that that's actually probably a reasonable value to have. Ooh, actually, interestingly, you are like outside. Like you don't blend nicely together. You don't blend nicely together, so you're fine. What is this black? What is staying black forever? What do I never color in? You. Right? Interesting. Which implies that you must be like really close to 0. So if I just said like color.z, well, yeah, you wrote it as a comment. That's helpful. AI. You right. So I definitely need to include K then, because the idea is that if you're too small and you're expanding out, you just sort of taper off to nothing, which actually would be fine because as long as this tapers off to nothing, what we need to make sure is that we set some kind of value like I here. And we say if I, because I is like the amount of times I've added power. So if I equals 0, if I equals 0, we need to discard. Discard. Right. So because we're adding I every time and power and F and color, so we need to make sure, which this should just make everything disappear, right? Yep. Okay. So first off, if you ever get to here, then I equals 1, right? Then that means it won't discard these colors, and we're discarding anything where I is equal to 0. So if we turn this off and turn this on, and then we want to actually go only in here do we turn I equal to 1, I equal to 1, because then when we set an F, I equals I plus equals this, is that going to cause no? Okay, so you for some reason, this black here is still getting its I set. Maybe we stop setting I here and here, because at some point we set some I. Interesting. So the green gets set at some point. For some reason, Maybe I need to clamp that between 0 and 1. Maybe it's just that it's just such a tiny value. Because we plus equal I here, so we need to clamp. So it's like it's between I mean technically between 0 and 0.25. Right. So if I do that, that should mean that I need to what if I clamped it between 0.1? If I made you 0. Well, actually, what you do is you clamp. No, it still has the same problem. I need to clamp it between. I need to make it like twice the size. Then clamp it between 2.5. Well, you just clamp it between that and like 0, 1, and then you minus 0, 0, 1. Except I need you to be like 2.6, and then you also need to be 2.6, so that the value ends up like that, and then we go. Okay, so that actually kind of works. That's actually interesting because it means that like the fact that it's transitioning to black means I can basically say if you ever don't set your color bright enough, just don't render it. So I think we don't use I for anything. Yeah, there we go. So what that means is we can basically say, hey, if you ever like, so this it's F, and so we say F is power. Okay, so what we need to do is we need to say get rid of this, because this just feels like witchcraft. Like it doesn't feel right to be doing that. But I think what we're going to do is we want to come down here and we're going to say if F is less than 0.1, maybe even smaller, 0.01, continue. Actually, no, always add F. It's that where it's specifically saying if I equals 0, discard. If I is less than 0.1, we even make it 2.5 and just So now it just doesn't transition down to 0. If it's too low, we discard it. But it does mean that we need to say that I equals 1 on anything that we want to actually keep. Right. So these are the things that we need to. Interesting. Well, outside of the fact that, like, what if I just went back to just doing this? Maybe the issue is that we are literally just keeping too much I. So we just say F is equal to this. Okay. So if I just do that on all of them, well, first up we need to not do this, not do this, not do this, not do this. Okay. And go, what the hell does that look like? It sort of smooths it, but I feel like the value is too low. Which is that basically we need to say, so this is outside of both and shared not to 0. Interesting. So would you just be the power of the two then? And then you're outside of both and shared. But I don't think you need to exist because again, you're interesting. So part of the issue now is that this gradient here, this magic fluoro gradient, is happening, but you're not happening. Interesting. So I don't think you want to be x divided by y. I think you want to be like x divided by k. Interesting. So wait, x divided by k seems to it got rid of something. C dot y. Okay, so it's either the k is too big. So I think it's the. Okay, so maybe it's c plus k. Okay. Okay, I don't think that changed really much of anything, which is good. feel like this value might be too high. See, that's the issue. So you're pulling it out this way, but you're not actually adding any color to it. So anyway, these gradients actually look great. They are not quite. You're not really perfect. But I think that's actually because that is probably going to be one of these. Like, it's going to be like, if we set y equal to 0, do that there. So that's actually where it looks like bad. And like, if we look at all these, I think everywhere that the green is actually where it looks bad, which is that the bright green. So that's interesting. That's interesting. So first is that it's starting way too high. So first off, if we just got rid of you and we went, okay. So what's adding color at the moment? You're adding color as well. Okay, so that's the green sections only. So it's actually you that's doing it wrong. So I think we want to also add K to you. So like plus K. All right, and then we do that. We go, okay. But again, they're just starting too high. You aren't supposed to start at whatever value that is. That's like starting at 1 or something. You need to start wherever this one ends off, and that one ends off because you're 0.25 times by that number, right? Because again, but not to 0. Interesting. Why do I have not to 0 written next to it? Like, also, why are you not turning up? Is it because I don't set y? Okay, I'm not setting I. Anywhere I set that. Okay, so interestingly, you're all blending. Why are you like that? I think that's probably because I'm setting this value. Is that why you're turning up like that? No, so this is just the wrong color for some reason. Probably because I is greater than 1 would be my guess. You're not gradienting it. No, you are gradienting. Okay. What color are you supposed to be then? I think what you want to do there is you want to go get rid of this piece here. Okay. So now it's all black. It means that when we set colors, right, like this, we go, who the fuck is setting that? No, it's not a blue. That's for sure. Is it this blue? Probably that blue, because we're not actually doing anything with that color. No, it's not actually. Interesting. So hilariously, that means I'm actually not doing that at all, but that's fine. Which also, because this is doing that, it implies a certain level of, you go from 0.25 down to 0. Okay, I think that's why you actually don't need this, is because so we set F, we had this, we had that. Okay, this is all working, right? Yes. Okay, so I think what's happening is this is really bright like this because you're supposed to be doing this as well, maybe, like, so it's actually supposed to be brighter. Ooh. I mean, it kind of worked, but no. So 0.25 times by this means that when we do that, where'd that one go? So you now blend nicely, and then so I guess you're also 0.25 times that. It's just that it's just too powerful. Okay. Now you blend nicely, but okay. So these bits are having issues, but because I've got that turned on. Okay. Are you going to be working now? I think that's right, because I think it's actually you that was causing the issue. So if we turn this off, no. Well, it worked. It was one of these. One of these was set wrong. Anyway. Okay. So you'll blend nice. You'll blend nice. Where is specifically not blending nice? Here, which I think is because we have this turned off, right? So just turn on this, and I think we just want to turn off the rest of the colors so we can only see where this is going to have an impact. Which, if it has an impact here and here, then that's what we want. So no. Okay, so it's not you. You need to be fixed, but we need to set I as well. Okay, so What is that one? And how do I see you? So you're not a Z, right? Right. Maybe you are a Z. I don't think you are. Okay. So it is not a Z. Z, like, Z is kind of related because Z's the part that looks wrong, but it's actually the bit after Z, which would probably be outside of both. No, it would probably be, it has to, it had to be outside of both and shared outside. No, so we're inside of other within range. Wait, you. Inside of other within blending range. If I turn this on, right, but that's not correct. Oh no, because you're not, right, it is you. You're just not grading to nothing fast enough. Okay. So it means it's in here that we need to mess with. Right. We can turn the color back on so we can see what it looks like. Let me go F. Why are you not quite? So you're blending. Somehow we're getting a value that's kind of too dark here, which I think probably has something to do with this. So we need to make sure that F is greater than a certain value. Well, that would kind of work. So it's specifically that when you're getting here, you're too dark. But which is too dark? Like if we just said that you times 10, does it still have the dark line? Like is it that you're getting too bright? Yeah, okay, so you're setting it to too bright. Right, so you need to taper off faster to blend properly. Why? Like, why is it specifically here? Why is it only you? So it's you or adding some color to here. But any of the other shapes have it. Maybe it's just a really bad contrast. Like nothing else. Everything else actually looks really good. We just need to, work out what color to put in this green. Also, obviously something's wrong here, which I'm assuming is actually that when we, can I say that you're actually equal to 0.01, implying that if you hit it multiple times, it should, okay. So you should do it, so you've also got the same issue where you can see the transition border. Why? Okay, first off, so I just get rid of this, and then do that. You lost. Okay, that's good. I still understand why you can get so dark though. I would have thought that your cropping would have happened and you would have not done that. Anyway, we need to work out this green. So the thing with that green is I'm pretty sure if we turn on you, the bits that are visible here are only, yeah, they're the cyan bits. But that's why they're visible, is because they're the cyan bits. Okay. So like the idea is if we turn that off, they should just, what if we have that blending and we have that blending, which means we actually want this to be checked after, which is, so this is, so you're only if we flip this and put you in here, it should look exactly the same. Okay, nothing changed. Right. And since nothing changed, it implies that when we turn this back to blue, and set I equal to this. Right. No. Multiple colors are hitting this. Right. I mean, that should be fine. So where it's blue implies that both colors. So why not just do both then? I feel like that is just a place you do both. See, like at least one of them hits here. So I guess what you would do is maybe you make this color like even lower, like this. So first off, what happens if we just do exactly the same thing? My suspicion is we want to do maybe k times 2. No, that just disappears, which means that that entire if k is greater than -1 is just pointless, because why are you not here? Why are you not here? Something's obviously not rendering here. So if I just said, we just get rid of the whole thing about discarding. That should go like, you're supposed to have something. It's just that that's kind of why you have to keep the whole thing, is because if you discard some of it, I just don't like that this gets it. So the idea is that if I is really low, we kind of want to scale all the colors up. So that's because you're this divided by that. Okay, so this is the core color, this is the exact transition. See, this being equal to 0.25 makes me feel like this is just incorrect. Like this, I don't think this needs to be here, but maybe it does. But maybe that's what was causing the blue to bleed in like that, is that we were setting the value at exactly the border. So save that and we F5. Okay, it's still visible. Interesting. Okay. So how do we make you sort of blend better? So what's happening there, I think, is because we're doing, it's probably this one. So if I just said like, hey, x equals this just sets it red. So no, it's not you. You're not the one that's doing it. Is it you? Okay, so you're the one that's responsible for the small circles having, so when I turn you off, it's, so we're dividing by y, okay, so, right. And so the issue is that if the circle's really small and k is quite large, or if the circle's radius is small, okay, so what we could do is take the max of c or k, which means that actually it wasn't even you. I don't want to do it on you. There's no point in splitting them out if they're not going to all have individual behaviors, so we just take the max of c and k, and we go, what's that look like? No. Okay, so why? So it's definitely this one. It's that this, it's probably because that 15's too high. Right, we just need you to taper off like one way slower. For one thing. So doing that should mean that like so this is also only the border between, this is the edge that goes out to 0, or doesn't technically go out to 0. Anyway. So they also don't blend together now because the values are different. So I have to make all of these 10. So what I'm thinking maybe is that, ooh, that just made it so much worse. And again, that translates into that annoying thing of e and x, and that you need to go from 0 to 1. See, it makes it magic numbers again, because it means like if it only works when exactly 10, that would explain why this line was here, is it just so happens to be at the boundary. Yeah, I didn't know that. So first off, I think maybe if we go back, can we just go back to c plus k, right? And then we go f. All right, so you obviously have quite a transition. You have a transition, so, and you have a transition. So who's actually getting the transition? So it's partly there. Okay. So if see, so which one is so? So it's not you adding it. Interesting. So how do I make you bigger? My thought to making you bigger is maybe if we said x, then we need to be a negative number, so I think it's x minus k, because we know at this point that x is negative, so we said x minus k divided by that. What does that do? That makes the number more negative, right? So if we said it's actually x plus k. Now the question here is, do we know that the number is definitely not negative 2k? What if that made it way brighter, which is actually kind of interesting. You're very pink, and then you transition down. So it's x plus k times 10 times 0.25. So we need to clamp you between 0 and 1. Clamp between 0 and 1. Right. So why do we have to clamp that between 0 and 1? Is because when this value is positive, it allows for... Whoop, didn't like that. I probably put the clamps fucking wrong. So something comma e. So clamp, pow e. There we go. Okay. So if I do this and go here, okay. So interesting. It's still like incredibly wrong. I should really be saving some of these changes and committing them and whatnot. Okay, so that's too bright because it's not this. So we want like the negative of the absolute of x plus k, maybe. So we need a negative number, and we just need to know like, hey, x plus k is going to be positive some other time. Yeah, interesting. Yeah. Actually very interesting, because if we can somehow get that to invert. So what if we said k plus x, c dot x? No. Alright. K minus x. That's kind of right. We just need the brightness to be bumped up to begin with. The initial brightness is too low. What if we didn't multiply by 0.25? It's not quite there. Interesting. Okay, I really need to just set this back to a state that works. We just need to say that it's actually c dot x. Why? Okay. So this all works and kind of looks cool. Right. So they're not quite blending together properly anymore. Is it because I set this value too low? Like, can we just set this to k? That would explain where the magic number is coming from, actually. Is it's not a magic number, it's k. Like, that's why they need to be multiplied by that exponential. Yeah, it doesn't really work. They are blending really nice. I just need to work out it was this one. So I just need you to not. If I get rid of this here, if we just divide by that, do you fill in with red? No, you still don't fill in with red. You just make that look really bad. If cx minus divided by y plus k, why? Interestingly, they're all doing this, which means we could probably say that f is equal to this, and then make it negative here. You're making it negative here, and then these all want it. It's all negative here, which means that actually, technically, because we know that it would be positive here, we can just make it negative there. I don't know if it makes shader any faster, but like theoretically, we could say like, take this, put it here, except we want x divided by c plus that, and then we want to say that f, you're negative f, and then these are all f. So yours is f times k. Now, interestingly, I've got a times 5 up there, but what if it was just times k? F times k. Right, I think they all need to take the same amount. The issue is that now they're all doing exactly the same thing. Which ironically implies that all this logic is unnecessary, because it's just as soon as you hit this else case, just use this. Okay. It blends so nicely, except in very fucking niche edge cases. Now, why are these niche edge cases happening? Am I discarding anything? I don't think I am. No. Okay. Why do the niche edge cases happen? I reckon it's this pow K is actually the answer to what like a lot of my problems were, is that what happens if I turn you into K? Okay, we end up with a much more obvious line. And wait. So we're timing you by 7.5. Wait. So timing you by K makes that gradient even faster. Because I'm wondering if the reason that K is important here is because we have to power it to K so that like the values will all fall within the K range, the blending distance. How do I, so you're actually not that obvious. It's also, you can't tell where one circle sort of begins and ends anymore. You can really tell there though. That's probably that those colors are really obvious. You can see the transition, which means that we need to work out what am I doing wrong. So if I just said, hey, you go down to 0, I think that would, yeah, okay, so you going to 0 is a problem. But it's because negative K times F times 0.75. So this means that the minimum you can go down to is 2.5. I think the issue with that is that makes all these other ones just too fast. Or, so can we say if F is greater than less than equals 0.25? Can we then return red? Right, so this should, oh, interestingly, F never equals 0.25. Is less than 0.25? It should never be less than 0.25 either. Yes, okay, 0.65, which means that we're basically saying like anything on, okay. Right. Radio. So we said maybe make it like, just to give us a nice red line. Right, so basically that's our transition. That's the edge of our circle, which is at 2.5. Interesting. I still think you need to be like K divided by 2, just so that we actually reach out, like we slow down the gradient. So technically this is just anything. K divided by 2. I don't know if this is computed every time. I'm assuming the compiler will catch it and do constants, but anyway. Right. That's interesting, because that implies that, first off, it never actually gets down to the lowest value possible, but anyway. Interesting. I mean, it's kind of working. There's only certain shapes and there's only certain colors that have a horrible border, and you need to work out what the issue is with you transitioning to you. This is an issue I think with 3-color transition. But other than that, it actually looks done. Like, can I actually say that blending colors is finished? Can I get over this goddamn hell that has been blending colors? I feel like something needs to be incremented here. Maybe it's this. Maybe this is the problem. Maybe we need to do it to infinitum. Did that make it better? Make it worse? Didn't really change anything? Probably took a couple of frames out, but that's interesting. Because basically I was doing this going, hey, you're too far away to have any impact, but something's telling me that this here, which we're doing something where, right? So if the equals, okay, so if div equals 0, continue. Right, so something about this, some reason you have like a hard cutoff where you just stop applying the rest of the color. Somewhere I'm saying something along the lines of less than K or equal to K or something. If S, the thing with this is I would do this on the fucking same thing on all of them. So why do you suddenly stop? Is something being clamped? So this is only applied when you're inside the circle. This applies if you're outside of the circle. This is outside, but not in it's inside within blend range. So funny thing is that I'm doing this all the same. So if I said that color dot x equals 1, so set red, and then we go F5. Okay, so as we can tell, it's not there that's doing it. Is it you that's doing it? Yes, kind of. Now, what's interesting about that is it implies because we can get here multiple ways. Anything with a red. So it's something in here. This needs to do something. Also, I find it interesting that it's impossible to get to there with a c.x is greater than... So if s is greater than k, else if c.x is greater than negative k. So what if I just got rid of this entire thing? This is going to make all outside shapes black. Right. Else, inside, well, within blend range. Do they all look like they blend properly? They're all looking like they blend properly to me. I'm not seeing any harsh, sharp lines, which does kind of imply that it's something to do with like a third shape coming in and blending something wrong. That is exactly what I want. This looks perfect. I don't see any errors. Right. I should probably go eat. I don't want to just move all the blobs, start to move the blobs all moving. This works perfectly. Okay. So we now have 3 states that the blob that they can be in. Now, the question is, if I do this, I go this, nothing changes. But if I said that color.x equals 1.0, does this break other colors? Does this now get transition lines? I'm gonna say no to that one. That is definitely outside of both and shared, but not to 0. Like that never touches. That never touches. Now, here's what's interesting about it, is that you're saying for some reason that you need to blend between these 2 colors. I don't think it's actually correct. You usually blend between those 2. S is greater than K. S is greater than 0? What does that do? That's everything outside. So, I think that's just everything. Like S is just, it's not. What? How? Is a different color coming in and clobbering you? Like, how is S not greater than K? Also, how are you blending out to nothing? That implies something else is touching your color. Excuse me? Oh, because you're okay. So you're blending, and I'm setting the color to X. That's interesting. Because that implies, first off, that you never set this, but you set this. Right. So inside other within blend range, but you apparently are never inside. Oh, because you're never inside the. No, you're never inside the other within blend range either. So this is never procced, and this is also never procced. But somehow I'm gradienting you, which when we add our own color, it goes power, which actually implies that this must be giving a negative number. That doesn't seem good. If f is less than 0, return vec. Wow, just 1, please. Okay, so if f is ever less than 0. Hey, would you look at that? F is less than 0. Why am I setting f and why is it less than 0? Because anytime you're outside of here, we're clamping between -1. So we clamp you between 0 and -1, which means that f is 1 minus, which means that that has to be positive. They physically cannot be negative. We say that f is equal to the power of f times 0.25 times the power of f, which in this case is a negative number, times k, which means that how are you... Is this one of those I forgot to initialize f to actually being a value? No, I did. It says c divided by x. Okay, so yeah, you're negative. Okay. So if we get to here, can we say that f equals 1? No, f equals 0. Yep, f equals 0. Because f is the amount of the other color we want to, the current color we want to add. So what's happening there, right, is that it was setting the value based on u and nothing else was ever overriding it. So we just never hit any of the other conditions. Okay. So if s is greater than 0 outside, this is outside of both shapes and shared to 0. Okay, no, apparently it's all red. Why is it all red? Excuse me? If because s is greater than 0. So s is greater than 0 means we're always greater than 0. Greater than k divided by 2. Where the hell does this put us? Outside of shared. Apparently s is not always. Okay, so greater than half k. So I think just k makes the most sense, but it could be k too. Okay, what we're trying to work out is there ever a situation where maybe it's k times 2? Because what I'm thinking is the fact that these have these sort of harshish lines where they're straight up, but sometimes they get this straight away, makes me think like there must be some kind of value. Like if I do a value and it will be like it will never go up, it'll only ever go across. So maybe it's k2, right? No, so the s is never greater than k2 apparently. Interesting. But what is the value then? Like, surely there has to be a value with 1.5, where it's blending. No, so it's almost exactly k plus 1. See, I'm thinking like, because this is almost right. It's the fact that you go up, so plus 2. Again, we're adding magic numbers here, but see, what is this number? Like, why do you only go across and you only go across and then you only go up and up? And you never step out, you never move away. You never move away. So s is getting bigger as we go this way. These s's are bigger. So what if we said that s is bigger than the absolute of c dot x? Right, it would be like the opposite of what I want. Right, because it starts at 0. What if we said k minus c dot x? That doesn't seem right either, because that's just everything. No, okay. For your well, see, I know it's negative, so I can just subtract it. Interesting. So this would be a set of colors. But this isn't what I'm actually looking for. See, this just, I mean, kind of. Well, this is what again, be like blend the other shape, but only a certain amount. So this is incorrect. So it's somewhere around C2. So here's the thing that's good about setting each individual color, is that I can say, hey, now you add so if you're greater than that, means you're outside of both and shared. So color dot x y, and then color dot v. Right, so this should reveal our 3 sections again. Now I suspect that there's something else. So x, so it is. So this highlights everywhere, and it also gives us a few spots that overlap. So something special about this cyany thing, that has to be its own thing that we need to work out. Like, what exactly draws that circle? Because I feel like that circle is something. The green, I feel like, is a really obvious circle. Like the green, I think, just gradients away. Green is really obviously just a gradient away from. So green is. So this is just obviously just a gradient. The power at k apparently. And then I think the best you can ever be is 0. You can be a 7.5, which means that we can just add this, and this should just gradient away. Interesting. Except that's not gradienting away. It needs to gradient faster than that, please. F times k. C. What do we just do at F? What do we just gradient away at F? It apparently just doesn't go any faster. Interesting. I don't get it. What I'm not following is that if I make this number times 1000, this should just like gradient away like instantly, but it's not. It's just actually not gradienting it away at all. And F is equal to C. Will that make you a small number? You gradient faster now? Here's the thing, it doesn't seem to be gradienting at all. Is it because I'm tacking on a different color? I can't imagine any of these are doing any kind of impact. Nope, they're black. And if I turn this one off, you should turn black as well. I'm not like, yeah, okay. So why does first off changing anything not make you gradient at all faster or slower? Like if I times you by like 100, my suspicion is because the values you get, the values of the F must be very small. Because your CX, so your X, which in this case I believe is a negative number. So we're gonna go, hey, if interesting. I don't think you can get anywhere else to set. Oh, you set F to 0, that would be why. These all need to set F to 0 then, I guess. We got 0, and you also need to set F equals 0. They just need to set it so that it does its thing. Okay. Oh, that didn't like that. Because something about it. Oh, we went here that doesn't do anything. Okay. So first off, apparently you do nothing because we're timesing it by 1000, which means it's basically just plummeting to 0. All right, times by k. Do this, and it goes, hey, so you gradient away, and you gradient it properly. Okay, good. Right. I do feel like I should be doing some specific point, like maybe half the color and then the rest of the half. That basically means that if anything, I could actually probably just, since every shape does it, we could just actually make you not do anything. You just return yourself. I just got the blending how I like it. What I was thinking is I could make it that you're just the center of this shape is just always always just your color, unless you're inside another shape, at which point that could actually be done. So that would be like if div equals 0, so it would be like if div equals 1, else. Actually no, technically you would go inside that, wouldn't you? If div equals 0, so we say here, we go, hey, if div happens to equal 1, I just want you to return yourself, otherwise return a gradient of the other color, right? So do this, else do this, right? Otherwise you just f equals 1. Right. I think you still want to gradient it somewhat, but I feel like if I just do that, then yeah. Okay, so then it does that, and then it still blends them nicely in the middle. So I need some kind of gradient, but I just need I can make the gradient maybe come down to half. I feel like that might be a mistake because I feel like that's going to result in color sort of chopping. But anyway, we do this, and we say instead of coming down to 25, come down to 0.5. Right. So that just basically keeps the more gradient. We can also make this K now because that means we can give it like a steeper gradient. Like I think K is a steeper. Okay. And then we just need to make you start at I think it was U, right? 2.5. No, 5. Now you're 0.5 instead. No. Okay, don't do that. All right, right. You stay at 2.5 because you're the meeting point of two colors. That's here. Inside other within blending range. That's here inside of other within blending range. So as long as you stay 2.5, you stay 2.5, but that means that you become 0.5, right? Which should then blend out more slowly, which gives us a more solid color blending out, and then that still blends nicely. This bit here is not blending as nicely as I would like, but I don't know if that's just because I haven't got the other stuff doing what it's doing yet. Okay, so we want to say you are now color red, and you are. No, you need to go away. You're never supposed to be. Your color is it. Yeah. So this. Okay. So the red is somehow needs to blend between the two, and I think the red is what's going to make us blend those two, and then the blue, which weirdly means we're going to turn like this off so that we can see the blue. Ooh, it turned white. The blue, apparently. Oh no, which one was it? Okay. Okay. So blue, something turned white, which is even more confusing to me, to be honest. Why do you start white? Oh, because it's F is less than 0. Right, we need to say that you, because you're not running F equals 1, F equals 0. Right, so we don't want to add. Okay, so the blue is the transition from the red. See, this is what we want. This is what we want. So the question is, do you hit any of the yellow? So what the blue is we don't want. I need to work out how to get you isolated. So I think the issue with this is that both of these colors set this, and that's why this ends up being cyan, is because it can get in this from one shape and this from the other shape. Yeah, so anywhere it's green is just this color. Anywhere it's cyan, it's both. Okay, that should be fine, I think. Maybe not, though. Maybe not. It should be fine, though. Okay, so I think we can turn you off, and then... Okay, we want you to blend nicely. Play nice, please. Okay, so blue. How do we blend blue to 0? I think blue... The idea with blue is if we just start at an even lower number, the question is what lower number. So this is our base multiplier. So instead of doing that, we do this. Okay, so you start at 0.5 and you start at 2.5. I think that might work. Right. So then you blend out, and then we need to go you are 0.25 times k. So let's just stop setting F to 0 and then do that and go. Okay, so. That's not looking correct at all. But why is it not looking correct? Because like F is just really low. Maybe, I don't know. It's can we just turn the red off too? Just so it's not blinding and overpowering. Yeah, okay. So first off, something's setting a little bit of green in here. A little bit of green, a little bit of green, green, green. Actually, is that green getting set by this, or is that getting set by something else? Ooh. That's the wrong one to set. That'd be why. You. If I turn you off, does it all go black again? Oh no, it turns white. Okay, so you're setting something. You're just setting like a way too small of a value to actually be useful. I guess technically, when we turn this one back on, does it look correct? Turn that off. Let me do that. Okay, does it actually blend correctly? I mean, kind of, like, no. So it's, the blue is just ending up, which is that little blue there, it's just too dark. So if we just went like 5, like, I'm assuming that all just blends nicely now. Kind of. Not quite looking right there, but I think that might just again be that the purple's just so dark. And the green's so light. Okay. So now we need the red, and the red just needs to blend between the two colors, which just, I guess, it's just the same formula again, isn't it? Though? Like, we could try the red at a lower intensity. Well, let's just make it white apparently. Well, that's interesting. Why are you ending up with such a high value? If S is greater than, okay. Why are you ending up white? First off, we're setting F to 0, which is not helping. Okay, so you blend, now I can see this line again, which is that coming from anywhere? Like where is that line coming from? I swear I didn't see it when I didn't have this turned on. But no, it's still there. Okay, so maybe it's just, okay. I mean, we just do this. It's kind of boring that, like, that it always, like, it's the same regardless of how we get there. This line definitely needs something. There's something about the transitioning, but it could just be that it's green. No, okay. This is doing it too, where it's not actually transitioning properly. You are not actually the right transition. You're too sharp. The blue is transitioning too sharply. Now, who is doing it though? I'm assuming it's the blue doing it. So if I turn you off, you should turn white. So it's inside the shape somewhere. It's just the blue. It's the blue transitioning to 0 so sharply. Same with you. Interesting. If I turn back on the eyes greater than 1, which is anywhere that, so they're all just saturated, and that's probably what's happening, is it's not saturated. That's what I can see, where it's not saturating, which is actually kind of interesting. So I can see the lines where it doesn't quite saturate. Interesting. My question is, well, this is only doing it outside. Is can we fix that? If div equals 0, so we saturate, this saturates slightly more, so we like just went like 80. That would I can see that line now. But what if we went hey, like if you're inside both shapes, just clamp. Okay. Right. So that should mean that they should saturate completely. And now all we need is to get rid of the halo here, which is to basically say that this is this, maybe? Well, actually, we just got rid of that entirely. Oh, now it's blue. Wait, what? So that happens if F is less than 0. Okay. So if you get to here, then F equals 0. That kind of works. Now we needed to fix the red up so that, like, 'cause I feel like sometimes you can see the contrast because the white gives it more contrast. No. Okay. So that's depressing. That almost worked. I feel like we just want that value, so we want this to be like 0.02 times. I think that's what's happening. They blend really nicely if they get saturated on the way through. No, it's too. Oh, well, we're not timesing you by the 0.8. We need to somewhat bring you down. No, it looked okay. 7.5. I feel like these numbers being different is kind of ruining the effect. Something's not working properly again. This is F is equal to 0. That's why. because you weren't blending across. It doesn't look terrible. Again, I just feel like it needs to come down to the same level. So I'm just gonna say, hey, can you just like do this? So like, just do that. Times by a half. Means that the least you can get to is a half. No, it needs to definitely gradient faster than that. Actually, because we're timesing it by, what if I made the gradient faster internally? Oh, no, I need to like uncomment you out. I need to comment you out so I can select you and comment you out. Okay, then we need to get rid of this. Because I've got lots of code here that's literally doing nothing. Okay, so if you're this, okay, so first off, I gradient significantly slower when you're, maybe that's the problem, is that divide by, say like 10, make a real slow gradient when you're inside. And then we just need to make sure that you have the, wait, is that the problem? Is that I'm timesing you by K. All right, I want to make you accept 75, and you also need to go back to 75, because that's kind of how it works. You are getting done by K divided by 10, but then you're showing up, which means that I think you need to also be K divided by 10. You need to match that exactly. Like that's probably what was causing that line to turn. Okay. So I reckon if we instead just put F into U, right? I think we still need to make sure that we clamp this. Maybe, how are we getting in here? I think this all can go. So something's happening here that the F is getting. So let's go here and say if F is greater than 1, then color, then return, right, turn red. So basically, is it ever getting greater than 1? No. F is never greater than 1. Why the hell are you so greater than or equal to 1? Well, no, okay, so if it's good, if F equals 0.25, right, that implies that F was greater than 1 because we're multiplying it by a quarter. No. Okay, so question, why are you, okay, so first off, let's turn K down. They blend nicely. Why, what have I fucked up with you? You are probably supposed to be multiplied by K. Okay. Right. There we go. Right, so I think that those lines turning up, so I think you're just not adding enough of that color. Interesting. So now I got that blending back nice. Why? What are you doing wrong? So it's something in the transition between the two. I need that one that had that. This is far too purple, which means you're adding far too much red. Where are you getting the red from? The only place you can be getting the red is in, you know, right. This, if we just say cut set red, I'm gonna do that. There we go, okay. Yeah. So this is doing something wrong currently. Interesting. Okay, so what we want to say is if well, we want to work out what F is. We want to go, okay, first off, let F equal this, and then we want to go if object equals first, right? We want to say color dot x equals F, else color Probably plus equals F? I don't know, because so what this means is we're going, hey, this is the first shape and this is the second shape, and so you're pink for some reason, which is interesting, because if you're pink, first off, let's turn off these other ones that add color in. They appear to be overlapping at some point, I think, maybe? No. So you're pink. Interesting. Wait a second. Oh, well, we probably want to say F. F equals 0. So, because what's happening there is we're coloring you red and then adding red in. Okay, so you're red, which implies that you're the first shape and then your greens are the second shape. So it is blending them properly. Like, it is that this shape blends on that side and this shape blends on that side. So I don't know why you're getting this, like, sort of pinkish color here. Because if you're getting a pinkish color there, what if I said U equal color, object dot color times F. Well, we just say color equals this for that section, and then we go. Yeah, okay, that didn't work apparently. So we're saying color. Oh, because I selected this color. Y. Okay, there we go. This. Okay, so here's what I'm not getting is that you're obviously blending correctly, but you don't seem to be adding the blue at all. Is that the other colors coming in and overriding? If objective was first, otherwise objective, and then F equals 0. So what if we don't set the color here? Do we get the other color coming through? Now my thought is that you're probably getting overwritten by multiple things, but each pixel can only have one color first, so you're not doing anything. And if I do you, does this get rid of the pink was the second color because it was green. Okay, so the blue is actually rendering, but the red is just for some reason really overpowering it. Like the blue just stops rendering. Interesting. Right. No, okay. So we would have said plus equals. Then it should be both of them. That would probably make sense. It's the second color's coming through and clobbering it. Okay. See, but the fact that you're so slightly pink means that this should be more pink. This should also be more pink. That's probably got something to do with the fact that this is transitioning at a different speed. No, maybe? You're 7.5, so if I make you 2.5, well, that probably gonna make it even worse, but... Right, so if I make you 7.5 as well, which means that there's no difference between the 1 division and 2 division. Which blends you nicer, which means that you come down to a lower value, which means that I think it's you here need to be 2.5 so that you're less black all the time. Interesting. How do I pump these colors up? I need you to not drop so quickly to 0, which is because I'm doing this. So if I just did F instead, right, then they stay. Well, probably too high is more the answer to that one. So you're getting that. Right, so you should probably do that instead of doing this. See, I think with this is we're just adding the wrong colors. Anyway, we're going to do F, and then F. Do this. Save that, do that. So why are you doing this? So this is got like a paley pinkish color. And it's because we're doing F. So if we don't times F by something, we end up with too much. I need you to gradient slower, my friend. So a bigger number means a faster gradient. Oh, is it no wrong? Shift K. Bigger gradient. So that makes it drop faster. We need it to be like maybe divided by K, and that should make it basically white. Yeah, basically white. I mean, kind of. So actually, if we did 1 minus f divided by k. I think I've got it. Okay, what if we just said f minus f? It's gonna make it way too bright, right? Yeah, it's mostly just white. Divided by 2. Just trying to find a value that like makes it not 1. We need to clamp u between 0 and 1. I'm gonna do that. No. My question is kind of like, if we did that, if we said, this is said times k. Okay, bigger k means faster gradient. It's still fucking white, right? Because this number is going to be quite small. Okay, well, first of all, we don't need the 1 minus. I just did this. Right. The issue is that you start at 1, and then this should have already gradiented down to 1. Right, so we need you to not go down so far. So I need you to be like, only go down maybe to half intensity, which means that then you get to stay up at half intensity, and then you also need to become a half intensity, otherwise they see the blend. Interesting. Well, okay, so the issue with that is now this is starting too low. Alright, yeah, because it's skipping back up. Okay, so we need this to be times 0.5 between 0 and 1. But like, if I just did this, like, doesn't that just work for all of them, which is kind of like boring? Yeah. Well, there's still some weird edge cases. Like, for some reason this is blending to 0. This has got, oh, so there's 2 shapes here, so this gets really quite powerful, like, line drawn in it. Interesting. I'm not returning early on anything, am I? I don't think so. These are identical now. We could even just like, one thing to do, I guess, would be we could make, I feel like you need like an even more powerful gradient. So let's get back to just doing the 1. So if it's inside the shape, you do 1, and if it's a divisible, yeah, I need you to have an even more powerful gradient, like k2. Interesting. And then obviously you would need a more powerful gradient because, you know, interesting. Not quite. I think that's 2 gradient here. I don't know. This needs to be maybe even higher again. I don't know if it fucking works. Okay, so you're going way too quickly to 0. That's the problem. Is that like in here we need this to all not be fucking 0. Which means that I need to go, okay. Okay, that's what we need to do. So I need to, in here, we go, hey. So first off, can we say, I need to bring those debugging, color dot x equals 1, right? So this is anywhere between these, anywhere between 2 shapes. So it's all of this. So we do this blending. Anywhere between 2 shapes, we do this blending. Yeah, okay. So it's still very black. Why is it still very black? Because we have that just basically dropping to a... What if instead of c.x, v, what if we did v? What is v at this point in time? Okay, we can't use v because v is... Wait, shouldn't we be using v? What is v? V. Can we just say if v okay, so what if we did if v is greater than s, color dot x equals 1. So I think we need to be using V, because all we do is we smooth that and we just check. That's how we discard, yeah? No, we continue. We check the next shape. So we only check V if... Wait a second. Why are we only checking V if the... Well, we're only checking V if the smooth value between you and you is... But do we need to care about that? So, first off, nothing else is setting red. You can go away. We go, okay. So, the only thing that sets it white... Okay, so everything sets it white. I think we need to get rid of whatever we're doing that's returning white. If f is less than 0, return white. Okay, right. So get in here and it says that f equals 0. Right. So we're going to go here. Okay. So red, because v is always less than s. Okay, but what about if v is less than that? What if v... Okay, so very rarely. Which interestingly implies that the v is more or less useless. Well, actually, no, because what if we stopped continuing? Maybe that's what's causing me issues, that I'm continuing. So when v is less than s, first off, I don't actually know if this would be the interesting thing to do. Is v calculating v even useful? Can we just like say, hey, if you get to here, can I change this into return red? Okay, so if I see lots of red, so by looking at that, this is completely useless because it just never v is never less than, which means just don't even calculate that. Okay, don't even bother. F equals 0. Well, actually, can we just for the sake of actually seeing everything, is if v equals s, are we just always getting s? No. Interestingly, these are is a like a class of color, like, but it's almost always, so that's almost a rounding error. So v is just almost always equal to s. Interesting. Okay, but yeah, I think v is basically useless. We're just smoothing s to its the value that we already had for s. Okay, so then we can get rid of this. We go, okay, so we are okay. What I need to do is work out what is our outside of both and shared. So at both not to 0. Okay, so I think outside of both and shared. So we just turn this on. Do that. So no, blue is not what I thought blue was, which is interesting. So yellow. Okay. So the green. Green needs to gradient you to 0. I feel like I shouldn't be displaying black. You know what I mean? Like I need to make sure that every blended piece in here gives a value greater than a certain amount, and I need to discard anything that has a color less than black, sort of thing. Like if I is less than 0.1, discard, right? And the issue I was having with this is it ends up discarding like everything, because what we need to do is say, hey, so we add f to I, which means that when we go into here and we say, hey, which one of you was blue? You. Okay, so you're the outside shape. So we need to do this and go, what do I take you down to? 0.5. Right. So for some reason, first off, stop setting the y. We're not dipping deep enough. Right. You're too dark to begin with, which is because you're 0.5 and you're 1 minus this clamping. Are you just not gradienting fast enough? You're just not, no? Okay. Why? I think this seems very much correct. Okay. Okay, so it just doesn't feel like it fits. It doesn't feel like it fits. Why doesn't it feel like it fits? So why? The issue with you is you're just transitioning too much. Okay, wait. What could be happening is we could be running into this issue that maybe it's just no. So it's not that. Why? You go from 1 to -1, and we just take you. Maybe it's your number becomes negative, right? So what if I did this? Okay, so you're way too bright. What if we said what if we did? I think this is gonna be the wrong way, but 0.5 times 0.5 minus 0.5. I don't know if that'll work. We have to wrap it in parentheses because it's terrible like that. 0.5. Something like that. We go like. No, that didn't work at all. Apparently. Does it mean that value is like always one? I don't quite follow. So power of this to this. So if f is less than 0, we need to return something. Return. Okay. If it's red, it means we're okay. Well, first off, apparently f is just never set. If f is less than or equal to 0, return red. Okay, so it's just equal to 0. Power of f times wait, but that's confusing because it says it's never less than. Okay, so you minus that. So you work. It's not quite right. But why is it not quite right? You're very bright. Why are you not the value I think you're supposed to be? That's what's throwing me. Returning red if something's above something or other. Okay, I don't need. No, it's not you. I think it's you. You're the returning red that I don't need anymore. Okay. This isn't starting bright enough. I need to go here and I go, hey, if f is less than 0. Less than or equal to 0.5, return red. Okay, so apparently nowhere is it less than or equal to 0.5. But if I say like 4.9, it should be somewhere, right? No, apparently not. Then what? No, wait, no. It would be 5.1. Okay. Okay, so there's just little speckles. So, like right on the boundary, it is that, which means that you, my friend. Okay, so it's 0.6. That should draw a nice boundary around the shape, right? Then we're saying like, hey, f equals 0 apparently, but we don't care because we will immediately override here. And we say, hey, if f is greater than 0.6, maybe, so you're less than. And then you're greater than, I guess. Then we're going to return. We're going to return different color, but return green. Green probably wasn't the best color. We return white maybe because that'd be really easy to see. White. Okay. So first off, that just apparently never happens. So this is power times this, which means that it can never be greater than 0.5. So less than 0.5, less than 0.6. If f, isn't that always? Okay. So it's always less than 0.6. Okay. But apparently it's never less than 0.5. So, excuse me, but like what? 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 F equals the power of f times this, times a half. So this value is never less than a half, which means that this value is not negative, I know. So wait, if... Oh, I set f to 0. Fuck it, I keep forgetting, I goddamn keep doing that. Okay, now you're always true. Now you're always less than a half. But now when you're less than... When you're greater than 0.4 should mean that you are like... The red and the white should touch now, right? Like, that's how that works? No. First off, very confusingly, the red and the white intermingle, but yeah, it's fine. So, the curious question there is, else if... That's actually good to know, that apparently this can hit the white. Outside of both shapes. That's good to know. At some point or another, they all hit this. It's hit multiple times. Interesting. Alright, so why, if they're the same fucking value, do you not look like you're blending from one to the other? Why? Well, there's also the big, like, it's greater than 0.6, greater than 0.5 and less than 0.5. They should, you know, they just don't exist, so that's fun. I don't know, it kind of just has to be that they're blending too quickly. It's also surprising me that you don't get discarded. Like, one thing we could also do is just like not add the color if it's too much. I don't know. Okay, what the hell is returning white? Well, that's inside a shape. If f is less than... Okay. Right. So can we say if f is less than 0? Okay, so that's why f equals 0 was up here. It's because if we don't do that, then we start filling in stuff we're not supposed to. Which hilariously then also changes a bunch of shit. Alright, maybe we should do you at the end, and then we say, yeah, I don't get it. But it just doesn't feel like it belongs. It just doesn't blend nicely. It needs to be brighter. Which is, I guess, 6 times away 7.5. It just doesn't work at all now. Why do you not work now? You because we're not passing it in properly. See, and now, but you can get that line because there's a sequence where they're a different shade, which makes it actually 8. Right, maybe that's the point, is that like this just feels very wrong. I can't put my finger on why. Maybe we just need a number that's a bit between the two, maybe like 6, 6, and then you multiply this place. 6, 6, I guess. Does that work, or would it be 3, 3? Maybe 3, 3. Yeah, 3, 3. 3, 3, 3. 4, I don't know. And 6, 6. 6. Okay. You are reaching 0, which is actually kind of hilarious. You're not supposed to ever reach 0. Maybe that's what the problem is. Maybe I need them to go back to doing like 0.75, like that. Right. And then that would make this 0.25. Right. But then I need to like... You are in fact at some point reaching 0. 1 minus the clamp power of this times 0.25. Right. Is it because I'm discarding stuff? Maybe that's why it looks a bit wonky on the edge. It shouldn't be, because it's still fucking... Okay, yeah, nothing changed. I don't quite understand how you can just never reach 0. And my thought is also, like, maybe you just don't add things that have, like, no influence. So we'll be like, if f is less than 0.0, less than 0.1, continue. Continue, please. Thank you. Okay. So what that should do is ignore adding things where f is too low. Now we're not discarding things where f is less than... Interesting. So I feel like this number should probably be a bit smaller, because what I want to do is say, like, maybe if it's anything less than 0.1, discard it, which shouldn't get rid of anything because we only add x's. But now we can say, like, if f is 0.5, so it's like you need to add at least 2 colors to keep it if you're adding 2 colors. Now that looks horrendously bad. Why do you look horrendously bad? I love how I keep full screening it, but it's not actually changing anything. Why? My suspicion is that something's causing you to blend wrong. Why do I keep breaking everything? So if I get rid of the F continue, yeah, we can get rid of this bit. Like that. Okay, does this fix that? Not really. Why do you have a fucking seam now? Is it this that's causing the seam? No, you've just got a seam for some reason. You've got a seam too, so that means there's a mismatch in scales. You somehow, I think you're getting a negative number. How are you getting... Sea's not blending here. Something's giving you a negative number. What is giving you a negative number though? Is it that I'm not discarding stuff like, if c dot x is less than -2, continue? No? Where is the seam coming from? I had the seam gone. I also happen to know that if I just, like, do that, then all of the colors should work again. Kind of? Not really. Oh no. Oh no. Negative F times it, clamp to 1. Okay. So you're fine. You're fine. I feel like you're too powerful, maybe. I don't know. That's probably what the seam is that you're too big of a number? Okay. Yes, that was the seam. I remember that was causing my other issues too. I keep fucking introducing bugs and then trying to fix them and then making it worse. Okay. Now, we want to do something like only add color if it's greater than that value, which doesn't really do anything. And then we want to discard anywhere where the color doesn't get set to a very high value. Now, we're not doing kind of like any blending and suddenly you go back to just being broken, which is annoying. Why do you work but not you? That's got to be that we're only adding F if it's above a certain threshold, so maybe we just don't do that. It's adding some kind of banding issue. Not really. That just seems to be an issue with that. Anyway, now to get our blending to come back, it means we need to See, it's kind of smoothing. We just kind of be like, if we just add this. Nope. I mean, it kind of works. That would be the idea, I guess. It's just you just equal f just equals 1, f equals 1, right? And then we blend from f, so f's always solid, and then we blend off f to 0. And then the issue with you is that apparently, because we're using K2, maybe we use K, we get nice smoothish shapes. It still looks horrendous. This is also still way too bright. I want to say dot normalize the color, but I feel like normalizing the colors is going to result in like it will stop those fucking blown out white pieces, that's for sure. Dot normalize, but the issue with dot normalize is it makes it oh no, see, it's normalized, isn't it? I guess what we can do is we can check and say if I is greater than 1, then color color equals normalize color. Right. If I is greater than 1, normalize the color. It's still just going to be white, isn't it, you bastard? We just can't set you to 1, can we? What if we just set you to mult? It kind of works, not really. Well, I guess no. We need to do this to blend them, and we say if div equals 1 else f equals this, right? Does that work? Because now we can say like, I mean, it kind of works. They still just end up being too bright. I also don't understand why you're blending into the yellow like that, but anyway. I hate it so fucking much. One other thought is I should probably like set the color to not just being 1. It should just be like 0. I mean, 7.5 is a good baseline. I think is the point. Is it's not solid, and then when we, because that's what a lot of our issues seem to be boiling down to, is that when we try to blend stuff, we're just hitting the cap. So maybe we just say, hey, please start at 0.5. Maybe that's the way to do it, because we don't have opacity. I don't think we're just making the colors darker. Maybe we just like double the color, maybe. I don't know. I don't think we want to normalize it and then double it. We could double I don't know. So you say if div equals 1, you're just a half, and then that means you can make like you a we make you like 0.5 minus half. Kind of means that you still gradient, but you're only gradient when you're like that, which should then mean that when we come into here, here we want this to be okay. So what is your maximum value? So your half as at a cap to half, right? Which we need to make this like 0.4, I guess, which would mean that you're actually 0.1 times that, because that gives you a good blending point. Yep, you blend in nicely. So I do think that like 90% of my issues appear to be that I was we're just hitting the color cap, like we're just hitting values greater than 1, and then we weren't able to like bring the color back. So you can't call normalize. You just need to work out what the largest value is and then divide by that to bring it back until value to 0 to 1. I guess I don't know. Could do that actually instead of calling normalize. Right? Why are you so pink? Probably because you don't gradient down, right? Hence we need to gradient you down because we don't actually know when you meet. Okay, but I feel like I've worked out a big improvement. Again, I've spent the entire fucking stream doing color. I just don't understand it. All right, so then you're going to gradient to there, which again needs that this, and then we clamp. I mean, technically we clamp it between 0 and 0.4. I don't know how you would ever get a number greater than 0.4. I suspect if we pass the wrong value in, we could probably get rid of the old clamp as well, because, you know, in reality you can't get greater than 0.4 because this function can only return the values between 0 and 1, as long as that number is negative. Right, so we do that, and so we go, hey, you're this, you're this. Okay, which means that you need to start at I want to say 0.1. Is that what you go down to? Okay. Interesting. We need to stop doing this while we test things. Yeah, okay. F5. Right. So, first off, I feel like way too dark. You need to start like way higher. Interesting. Can I start at 0.5? Or does that adds up like, yeah, it's got a bright seam. Right, you just... Wait a second. I don't want you going down quite so low. Maybe if I go down to 2.5? Right, and then the lowest you can be is 2.5, which means that you then become 2.5 times that. Right, and then the colors should blend nicer. You don't feel correct because the red gets to influence all the way up to here, but then the red doesn't get to influence into here, which is actually because this is wrong. This should be 2.5. Okay. Colors blending nicely. No banding artifacts from reaching color cap. Now to saturate the colors back up. So I happen to know that the highest value that a color can reach from all of this is I'm going to say that, or it's the highest that I can ever set a single color. That's interesting. Alright, so I don't think I want this because this just results in really fine colors not turning up. But we want the gradients all to go out to infinity. Right, so then what I think we want to do is we want to say that the color times equals 2. Times equals 2. Then I don't want to normalize it. Because I think what happens when we normalize it is we actually end up setting... See, I reckon what's happening here is these colors are getting greater than 1. So we're going to say, if color.x is greater than 1, then color divide equals color.x. Right, so what we're saying is if your x is greater than 1, then divide the whole thing by x. Didn't do anything. Except I think it did. I reckon if we get rid of that and like reload that again, it's probably not the x's to add it, but if we do this, so see how this is like yellow all the way to there, but then we turn this on, which is basically saying if the x is too high, then cap it down. We end up with orange here, right? And then I think we're going to go if color.y is greater than 1, right? After you've done the x, divide by y, and then if color.z divided by z. The idea is that if you end up with some like a huge y, you should be able to get like if you end up with a huge y and the x is like 2, then you'll divide the y by 2, and then if the y is still bigger than 1, we divide it by 1, which will bring the, so this should matter, like this should be color agnostic as long as the color is greater than this. And then we don't want to normalize. We never want to normalize, because if we normalize, we just bring all the colors to being the same color. I think that's what we wanted to do. Now, what we can actually do is also multiply the color by like a bigger amount. Can we multiply it by like... multiply by 5. Is it going to make the colors change at all? Shouldn't, because they should all drag back down, but I think it will, because it's going to, yeah, it's going to riffle my gradients out, because basically it's saying if you're greater than 1, come down to 1, which makes white the more prominent color. So maybe, because we say that I is equal to power, which is the number of times we added color. So I'm multiplying it by 2 here. Right. I want to say if I is I is greater than 1. Right. color. But can we just return, no, return just 1. Just make it white. If I is too high, return me white so I can see if I is a valuable thing to use. So I is only greater than 1 there. Interesting. It's greater than 1 there. See, I think what's happening here is we're just smushing the colors back out of. Interesting. Okay. What if I got rid of all of this and said, hey, it doesn't look any different, that's the point. I guess. See, this yellow, there's definitely something to it. So, color times equals 2. Right, if we don't do color times equals 2, oh, no, don't color equals 2. If we don't color times equals 2 and we do this, then all the colors just get worse, but and I mean technically if it's greater than R, we should return white, which implies that we have actually reached over the saturation limit. Yeah, okay. So these are all the colors that will be over the saturation limit. So how do I feel like if I just multiply by negative I, I'm just going to set it back to the saturation limit. What if I times color by, we're going to divide color. Well, we know that I is less than R. So we want to times color by 1 divided by I. Because we know that I is less than a half. I mean, that kind of works. Not quite, but kind of actually works to blend the colors out. But then we would need to bring the gradient back in. Because I think what's happening there is because we're multiplying, like I tells me how many times I added the color. So what it's letting me do is blend the color together and then set it all to solid color afterwards, which is actually kind of cool looking. It's kind of what we wanted the whole time, isn't it? If I'd done this at the beginning, then this I would have stuck with this, but I actually really like the gradients that it generates. So it's basically just telling me how many times I added the color in. So I'm gonna say if I is greater than 0, we're gonna do this. So we're gonna do that. Else color times equals 2. Right. So we return white if I is too bright. Otherwise, basically saying like if we know that color, like the amount of color we added, the total amount of color we added is not equal to 1, then it means we never saturated the colors. See, my issue with it is this, what do 2 divided by I? Okay, that just saturates them further. So if we did 0. Well, what do we use times it by I? I don't think we can just times it by I though. Times it by I does nothing. That's it. First up, we just gotta turn this off. Times it by I makes it darker. So I'm trying to make it brighter, but not uniform. Because that's what it do. 1 divided by I times by 1 divided by I makes them all, like it removes the taper, the gradient. Now the question is, if I made it 2 divided by I, that should make it twice as bright. Does that make them closer and closer to white? Like if I went like 2000 divided by I, is this just going to make it? No. It makes them closer and closer to primary colors because if it's greater than 1, it's just 1. Okay. Interesting. If I put this code back in, which is the code that should normalize it back down to maybe don't multiply it by that. Maybe we just What if we times it by 10? I think it's the timesing it by I that's, or multiplying it by some fraction I is what's actually pulling the gradient out of it. We should times it by 1,000. In theory, it should just always bring the color back in. No? Okay. I don't actually understand that, because I would have thought if I multiply it by some big number and then divide it by, if x is greater than divide equals x. I mean, it's so close to being what I want. See, I want to say that we can just dot normalize it. Like, what if we just say color? Or we normalize color? What does this actually look like? What if we remove multiplying it by 1,000? What if we did normalize color? Okay, yeah, that's basically what we're doing. It's normalizing color. Okay, so how do we keep our gradient then? Can I normalize color and then divide by I? Maybe? Why by I? No, we want times by I. I reckon times by I. Because I should be less than 1 at this point. No, it kind of just looks hideous now. They're all like kind of glowy. Also it needs to be I times 2. It's 2. Yeah. And it's made the banding worse, and some cases with colors are oversaturated now. Yeah, we don't want this. Well, you could also like normalize I time. No, it's just gonna be the same thing. I do really like the blending that it can do, but see, my thought with it is though, it's like surely then if we're just doing that, then like why wouldn't it just be one minus? So we just want to bring the range back into it. So we just make like 1 minus times a half. 1 minus times a half, right? Why couldn't you just say that it's equal to u times a negative a half? I think actually because we need it to be inverted, don't we? Can we get rid of the normalizing, just say color, please? I just think we need to go like, hey, can we say that we don't want to divide by I, we just want to say if I is greater than 1, color divide equals I. Like the idea being that if we add more than 1, no. Okay, no, well, that didn't work. Well, first off, we did it. Something's telling me that we're adding like a lot of negative. Oh. Okay, right, because you're this times negative. So this should be in. No, okay, so you just timesing by that. Right, which is why it's the outside, because that's why it needs to be. So we said like 0. Well, we just said 1 minus. We said 1 minus this. Right. And gradient down to our 0, maybe? I don't know. I feel like we're hitting our color limit here. So we're saying if I is greater than color divided by equals I. That's going to make them more flat again. We need to maybe take the floor. of I? No, I don't. At that point, I don't really know what I'm doing. What we need to do is if I is greater than, and we need to bring it back into a range. So here's the thing. So you're 1 minus the power of I in plus 0.5, right? Because that's the same, like the minimum value you can go down to is 0.5. Now, that's not working, obviously. You should be gradienting. Why are you not gradienting? Probably because I'm, like, dividing by the floor of I. Can we, like, normalize color divided by I? Yes, I say color equals. Hilariously, that actually seems to have given an effect, not the effect that I want, but an effect. So first off, we just turn everything else off. We got to get this primary gradient working. So the issue with you is you're brighter at the edges than in the center. Why are you brighter at the edges than in the center? Probably because I is getting bigger. So it would actually be 1. So it's this times 1 divided by I. Not quite. Not quite. Why? Okay. So what if we just always do that? Maybe it's that some color, sometimes the color is making it, but other times it's not. I don't know. Interesting. So it's making it a hell of a lot brighter in those other places, but that's because I. Or you maybe say I to 1. So we're not dividing by 0 all the time. Okay. Interesting. Okay, so it's not working. We're not even getting a gradient. You were backwards. I'm getting so annoyed. I had it working how I wanted. Okay, so maybe times a half. That's what we had, and then it's still not gradienting properly, but that's more because I'm doing whether the hell this is. Okay. So now you're brighter in the middle and darker towards the edges, and I think I'm probably gradienting you a little bit too hard. Might be the other thing. I want a much gentler gradient. I'm gonna save shit before I go back into here. Also, out of curiosity, if I said that f is actually equal to k2, because that makes it faster, right? Okay, that looks fine. See, the issue is that now we can get values greater than a certain amount, right? I'm gonna comment this out. Doesn't do anything, but I do like to know that I could specify different segments. Ooh, it suddenly just looks blurry. Not like that. Right, and so you can go up to that, which means we need to make you 0.5 because you can go up halfway. Right, now you blend blobby blob. Right, so here's where we've hit a cap. We've hit the color cap because we've mixed red and blue. Well, actually, that probably should just be magenta, but I think we're going to say if I is greater than 1, color equals vec3 1. Okay, so we do that. So I is just always greater than 1, right? If I is greater than 2, okay, so they're the colors that are busted, is when we're adding more than 1 I, right? Which is because you here will always add a half. Wait, why are you 1 though? 1 minus the power of 0.5. I don't get why I is. Maybe it's because it's K2. Oh. Well, he pops out the edges. Okay, so that's the issue, is that you're hitting saturation. Why are you hitting saturation? X, which in this case is positive, divided by y plus k2. I think dividing and then multiplying by k2 is the same thing, isn't it? Like dividing and then multiplying. Really put f in there. Well, we definitely need the k2 there. I'm just curious if we take this out here. What that's doing is definitely shrinking the range at which things have an effect. That's k2. Interesting. Right. Well, the issue is that now you two have two different gradients. Which is it? This? No, that's doing something else. Well, okay, so first off, I just don't think you're adding it at all here. Okay, so then you'd be 0.5. And again, anywhere that the value becomes greater than 1. That's the interesting thing, isn't it, though, is that I need to work out what the highest value any of them sets and scale everything down by that, I think. That's the issue, is that if I try and scale anything, I end up scaling U, but not U, which means that these colors don't match anymore. Now, admittedly, what that really means is I just need to make sure that my tapers are hard enough. I don't think I can times by 2, right? Like, well, what we can do, right, is we know that you are 1 and then you're always at most a half, which means you always have at least a half put into you. From, if you're actually a shape, you're always at least a half. We then say that if you're not in the shape, you start at a half, right? And then we say if you are in the shape, you start at a half, right? Then we want to, like, we would just want to say, like, color times equals 0.5. Well, that does indicate that first off, this is getting a ring of color that's a little bit too bright. Interesting. But if I get rid of this multiplying by half, right, well, first off, it's just too bright. And again, you're adding way too much color. I've broken things without committing anything to Git, and I'm getting annoyed at myself for doing it. So half and a half and a half. I think I want to use 7.5 and you do 2.5. Is that the way to do it? No, that's making you darker. So if I make you 2.5 and you 7.5, and then you would also need to be 7.5. You kind of want. That's kind of the issue, isn't it? Right, we need to start. I guess we want to start, like, just sort of somewhere below. I don't know what your issue is. I feel like your issue is that you're constantly inside something and therefore you just get a different result. So this works fine, which is to start at 7.5 for our gradient. So we just need to start at just a little bit lower. So if we said start at 0.2, right, which means that it's always 8. No. 0.2. We want to start at 0.8, right, which makes that 75%. And then you would be, I don't know what you'd be 0.6, right? Because then when we add the 0.2 from you and the 60 from you, and then same with you is 0.6. This means that we start at like not full saturation. And we let colors saturate up to full. Okay, it's still too much. Maybe we need to start even lower. So if our starting point is 75, I don't know what 75% of 75 is. 0.5 times 0.75 divided by 4 is apparently 11857. That okay. Then you would be I don't know what 3/4 of 75 is. Is 0.567. And then same with you, 0.567. Yeah. Okay. And then so you're equal to K2 and this and the okay. So it does appear that like a lot of my issues, this doesn't seem right. This seems too bright. But it does seem like a lot of my issues were that I was hitting the color limit, like and it was just hitting 1, and that's why I was having these jarring lines. So again, as soon as there's multiple colors, why are you getting the multiple colors? I'm not doing anything with the number, right? I'm not. Okay. So my thought is maybe K2. That makes the colors darker on the outside. Why is that making them whiter? First off, I think this needs to be K2. Like this gradient is just too... why is that not working? And go back to K and K. Why are you not working? Okay, so how are you hitting the color banding? You're white. So somehow I'm getting a value that's just really high. A really high value. I just feel like I need to like return some of these colors early, maybe. So here's your principal. Your minimum value is this. I think you're the wrong way. No, your maximum value. So the minimum value you get to, which I think means that you actually... So with this minus at most that, which means that the darkest you ever get to is, yeah, it will be 75 minus that, which is, yeah, okay. So then you have to start at that color to blend. Why is it so bright? It's because you here get to add more than half twice, maybe? 2. Okay, that breaks something. Why? Where is it? Okay, I need this number to not be so high. Okay, I need you to be 2.5. Okay. Then that's where 2 colors overlap. Right, which means I need you to be up at like 0.5. So you're third, which means that you then become 0.25. Because it's the difference between you and you. The most you can remove is 0.25. So the minimum you can go down to is a quarter brightness. You can go down to a minimum of a quarter brightness. And then you add at most a quarter brightness. And then you add at most a quarter brightness. Does that work? No. Oh god, they're all getting a bit saturated, aren't they? So that doesn't work because you need to start at like... What is you at minimum? When you go down to your minimum, you start 2.5, which I think means we need to make you 5, maybe. I don't know. You get your minimum R25. The original was times by 7.5. 1 minus 2.75. I don't know why it's not quite. Yeah. But no, yeah, so 2.5 is the right number. It's just somehow I'm getting to saturating colors again. Like, why are you saturated? You shouldn't be saturated. Well, we're all gradienting very quickly. I mean, if I do 7.5 on you, then you can move down to 0, can't you? Yeah. I still don't know what I'm supposed to be doing. What is wrong with my brain? Why can't I figure this out? If we're inside of a shape, then it is 75% of that shape. Why are you fucking so white? You and both colors are present, which falls into this. Both colors are present because you can add. I had the colors looking so nice, so just go 1 minus, and it was 25, and then it was 25, and then I feel like I was. You're going back to being like, just, why is it like radioactive white? What am I doing? I'm calling normalize somewhere, aren't I? What am I doing? I'm doing something. Probably the K divided by 2, maybe? Is that why? Like these numbers getting too small? Save that. Do that. No, that didn't really change anything. Was it this K2? Is that what the problem is? This gradient is 2. No, what? How did I have it working before? I've reverted back to what I had. And it's not working now. Okay. So F. Well, that kind of works. We would need to bring all the other gradients to the same thing of being F and F, because otherwise, right? And then that makes these values too great, maybe. F times K2. Interesting. Interesting. Not really what I wanted. K2. Am I discarding something? No, I don't think so. Are we continuing somewhere? We're continuing here. Maybe this is what's wrong. Maybe we're continuing somewhere we're not supposed to be continuing. Nope. I don't think this actually changes anything, because we really shouldn't be in these shapes if they're kind of F X X K. Okay, so it means K2. Does it do anything? Not really. What did I have before? No, here's why you commit everything to Git. As soon as I get it working, I'm committing it. So you're 1 minus. I think we need to clamp something here. Maybe something's getting a negative value. I don't think anything can get a negative value. Times K. Okay, well, we're not getting massive white spots anymore. We're multiple of overlapping, but so 1 minus, so F equals, so F is the negative F. So we're saying if F is positive, which means we know that this number is positive, divided by Y plus K, which means we know that this number is positive, which means negative times K. K2, is that making it? Something's multiplying F by a number that's less than 1, maybe? Power equals Fi. Power F. So 1 minus this term 75. I also feel like E doesn't need to necessarily be E, but that's a different. So we're starting at 25 because the minimum you get out of is 25. I think maybe make you K. Okay, well that works somewhat nicer because it makes them blend out further. But I think that means I'll probably want to make this K as well. Yeah, okay. Which means the E probably also want to be K. Maybe we don't want to be giving it K2, I don't know. What was the... We just normalize the color now. I feel like just normalizing the colors is the smarter idea to think. Right, so to make the normalizing the color work, I don't think it actually matters what these are in. I mean, it does mean technically I could make some things, because everything in here just blends equally. It shouldn't actually. It should. You're actually blending the wrong way. It's interesting. I think same thing with you. You're like blending the wrong way. So you're getting more pink as you head away, less blue. Interesting. So, I mean, if we're just going to normalize, I think we can just add all the colors together, right? Like, just add F to it and then go, what does this change? No. Just adding... Oh, no, it does need to be 1 minus, because otherwise you're doing it backwards, but I don't think we need to multiply by 0.75. Right, and then we can... Ah, right, you still dip down to 0. So... times 0.5, and then we make this 0.5. Let's go. Right. I think maybe it wasn't normalizing that we were doing. Well, first off, this needs to be 0.5 as well. We do that. Okay, so that blends all that together, that blends all that together. I think what we were actually doing was dividing it by color divide equals I. Is this how we did it? Or was it 1 over I? Okay, we didn't change anything, but that's because we normalized it again. If we just put color in here, what does this look like? Well, that's actually what we want. I don't know how I fixed it, but... If I get rid of the divide equals I, is it just because we made the color different again? No, so it just makes it darker. Interesting. Does that actually fix the problem? Not really, it's still got banding like this. But I do think that maybe if we then, what if we divide it by 1 divided by 1? Well, actually, we timed it by 1 divided by I, wouldn't we? Times it by... Nope. Sometimes I feel like I just don't know what I'm doing. Okay. All the time. Divide equals... Fuck me. What the fuck have I done? Divide equals... I... This just looks like it's actually correct. We could also only do it if I is greater than 1. Okay. So this looks very much correct. My question with this then is if I... This looks so good. You're still clipping at some point, but do I like pull the values down off the ceiling so you don't clip? But I don't think that's actually going to matter because again we're dividing by I, which implies we're dividing by some kind of constant factor. Now if I said normalize here color, this is going to make them all like blobby looking kind of bad. What if I said the other way? What if I said color equals color dot normalize divide by I, and then output color? Okay, that actually kind of looks pretty good. Yeah, we need to somehow work out where. I think that what that is it's got to be that it's reaching a value greater than 1. See, because doing this should mean that these colors are constant. Like it's not a. If I tweak the values, they don't change. It's interesting that you get a lot of red. Right. Wait, if c dot x, if I do this, does anything change? Ooh, stuff does change. Which interestingly means okay. Well, we kind of want to add all the shapes then. When this to this to this, that implies that some of my color issues could be the. Okay, remove that. Anyway. What do we want to do? We want to make this not quite got to 1. So 0. We start at 0.8 because when we normalize everything, it should go back to being right. Then we change by 0.5, and then when you're actually 0.4, and you're 0.4. So it just takes us off the cap just that little bit, so that we can get colors other than 1. And I don't think it really changed anything. There's a horrible murky color there. You're still doing what you're doing. What if I stop normalizing and dividing by 1? I mean, what if I said color times equals 1.5, it's 1.25 add a quarter. Save that. I'm adding a quarter. Nope. Interesting. I, to be honest, have no fucking clue what I'm doing. It's so close, so fucking. I think normalizing is the right thing to do. See, normalizing gives these nice sharp edges, and you don't end up with these like there's some areas that are black because they taper to nothing, but yet it still leaves this kind of white because the closer it was to black, the more it is just white. The issue is you end up with these horrible mucky colors, but actually, what we can actually do is we can say if I is less than or equal to 0, we can just discard it, but I don't think that's going to discard anything. Discard. Discard. Please, thank you. My brain does not seem to want to work. Right, that's discarding nothing, but if we said like yours anything below 0.1. Also, we're doing this after we do that? No, we'll do this first. First up. I don't think that changed anything. Anything under 0.2? It's just not discarding anything, really. That's kind of cool. I guess because if it gets to here, it's like anything below half. Interesting. But like if I undo this, like there are colors that aren't colored in, correct? Like I don't get how there's these blacks. Okay. Interesting. I reckon we could probably get away with making much nicer colors. What if we're going to do that, I think actually we might be able to go back to doing like individual ones, because the issue we're having with doing individual ones before is that we were like x equals 1. Right, so okay, stop discarding stuff. Thank you. Okay, so can we say when you get into here f equals 0, and like just don't add color? Okay, so everywhere there's red, we can give it a different weighting, because it's in theory red is internal, and I think red, if we go back to not doing this, if we go back to doing this, and then well, first off, because you pass K and we have to get rid of this. Okay, and we go here, we go here, we go, okay. We just don't do anything here, we go here. It's the internal ones that end up really mucky, because they end up with like lots of colors chucked in, so you end up with like white stuff. So if we instead said, hey, like if you're here, which is gonna be interesting, say, okay, anywhere it's black. So can we say color red? This will show us anywhere there's red. All right, and then we're gonna go turn on our color green and our color blue. We're gonna go, okay, so anywhere there's green, I think green can just have green just has this is just green, because green is just the gradient on the outside. So first off, get rid of the green now. Right, so this should just go back to like, now it just extends the color out. Right, so they just get this sort of like halo-y, like it's getting, interestingly, I actually kind of like that. It gets brighter as it gets closer to the end, because we're obviously adding more. But what we can actually do is give you like even more brightness, like, because I know that the only thing that should be adding this color, only bit that's allowed to contribute this is this, which means we can just make just 1 if we wanted to. Okay, apparently we can't make it 1, because that makes the outside really bright and then 0. Okay, so we can't make it quite so dramatic, but we can definitely go like 0.5 look fine, I think. That all we do need to give it a 0.4. No, we can have it maybe even 7.5. Oh no. Okay, can't quite have that much gradient in it. 7. I feel like, again, we're looking for magic numbers here, which means that they'll turn up as being, what we could probably do actually is maybe do like a K2 gradient. Okay, that looks kind of all right, but we need to make it maybe 5. Right, so first off, handful of these just look absolute garbage. But anyway, we see some red, we see some blue. Why are you black? The black implies something, doesn't it? Probably that we want to say like I plus. Don't add to it twice. Also, you don't add to it twice either. Okay, do this. This should make I. Nope, didn't like that. Oh, apparently you can't increment. Okay, plus equals 1. Plus equals 1. Weird. You can't just plus it. Alright. So where there's red, we want to add less color, I think, because it implies that we're going to add. Well, it implies at least 2. Ooh, actually. That's interesting, because we actually know exactly how many we have, because we keep count of that. I think maybe we don't. Div. Do we use div? Do I can I repurpose div? Yeah. Okay. So if we just pop div out here, this is basically saying anywhere we actually want to keep track of you, and we can do this and go ooh lovely. But I want to. Like again, right, now I'm thinking about it. I should commit this before I break it. Looks good. My commit history on this thing is horrendous. Anyway, also you shouldn't do this. Go away. Yep. Thank you. So yeah, F5 here. Okay. So what's happening? What's happening is we have some weird looking colors and some weird other stuff, and then okay, we're gonna go back to the shader wherever I did that. Okay, here. So what we can do is we can multiply this by. Well, we know that. Oh, we know that diff is equal to 0. Interesting. Right. We can't move div outside because we are actually using div. Okay. I was gonna work out exactly what our multiplier should be, but we're only doing this when we have no colors. Right. Which I guess, interestingly, well, so the trick with you is you're adding a bunch of red. So I guess we just, yeah, we're just see, you look really nice, and then I'm guessing you're the same. Where we just need to first off stop adding blue. No, so you're never getting hit for some reason. Well, you are. You're just becoming a horrible motley color. So we want to do like this, and we want to go. Okay, so this is outside of both. So this is the little section here by my guesstimate. So we said like 0.2. Okay. So what that means is that if we so I know that this is the overlap, so I can I like tone this down? Like if I start at 0.2, does it still look nice? Not really. It kind of looks hideous. But it looks hideous anyway. Maybe that's the problem, is that it didn't seem to actually move anything. If we make that like 6, does it get even gradienty? No, now it starts to split. So it needs to be 4, maybe K2 is the answer. No. But if we make it K2 and we make it 2, it's gonna make it even smaller again. No, so we need to be K2 and 6. Nope. Okay. So we kind of just don't want that. Or wait, what do we do? We just want the gradient in here to be much gentler of a gradient. So what if we just didn't do K at all? It looks really bad. Times K divided by 2. I feel like somewhere we should be using is it S? Oh, I just gave it S. I don't know what S is, but we'll give it S and see what comes out. Well, apparently nothing really. I think you just need to be K. What if we gave you S? I don't know what you are. You're these bits here, which all look really dumb at the moment. See, I feel like that might work if we just did S on all of them. We also kind of need to remove the normalizer so we can actually see what it's doing, which is apparently just like setting. So you're just like too low. So maybe we made them all 0.4 again. Make them all the same so that they blend nicely. Interesting. Interesting. You've got like a weird stem out here. I feel like using S is actually like something I should have been doing at some point. You just like don't really seem to work at all. You really don't like that, do you? That's because you're like different, I think. I don't think that's the right thing. Oh no. Okay. What if we said instead? What if S? Ooh. First off, don't times it by 1/2. Now we need to go back to doing like the absolute. Oh, actually, we know that S is positive. So what's happening here is we're passing in negative, 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 negative. Now I think they're all actually doing the same thing. Yeah, no, don't do that. So just don't pass in sc.x. So, you're too high. I feel like S is just not a good idea. Maybe if we put S in here. It actually kind of looks kind of cool. It's just this, which is the overlap of the overlap, which is U. So I think these can't be S, maybe. I suspect what's happening is S is plummeting too quickly or something as we leave the shape. S is getting closer and closer to 0, so we can't use S cross shapes like that. This all looks actually kind of nice. And then you're annoying me. Yeah, I feel like somewhere we need to use the radius of the shape to correct for the fact that like smaller shapes have a problem. But I'm actually gonna say that's pretty good. We're gonna commit this as working circle. Working colors. We're gonna call that a commit, and we're gonna like never touch the colors again. All right. So first off, I need to like maybe make a function called SDF that does the SDF bit, this bit here, because I feel like it's a bad idea to have that all done as its own thing. So we'll make that core. No, because then core has to bring in all the shapes, and this is 2D. So we're gonna say we have a function fn SDF 2D. And then this is going to take in a position and an object, and then you're going to do this, which is to extract the object's type, and then you're going to say C is equal to this. No, so you return a vec2. Because I think we need the vec2 because the first value is the sign distance field, and then the second value is the like power that has. I am curious if it's possible to SDF. We should probably fix the SDF to actually be SDF instead of. Can we go without a default, or is this not going to compile? Okay, it doesn't like that unknown identifier Bevy core shape mask shape type mask. Where did we pull that in? I'm sure I was doing that before. Shape type is just apparently ending with FF. Okay. So shape type is this. Object in FF, which tells us what shape it is, and then we do this and we pull out. Okay, so now you do that, which means that then we can get rid of P and then C. So C equals shaped SDF 2D P and object, which I think we're going to actually go up here, and we're going to take this piece as well. We're going to put this in here, so we can you know, like ID, which is a U32, like that. So this should mean that like basically whenever we want an SDF, we just tell it what it is, and then it'll pump out the ID, and then you call SDF and OBJ. Like so. It would be nice to have like a buffer so that we could like not calculate it every time, but maybe not. I don't think we can, because we probably could do it like a buffery thing, because we at least iterate through the list twice. For every, well, not for every shape, but we at least iterate through the loop at least once for every shape. Anyway, C is now equal to SDF I dot X, because we don't use the radius in here. Okay, so annoyingly, I'm going to probably end up breaking all the code, but I want to refactor it so that it actually returns the SDF So object.position.xyz is doing something. That's your P, right? Yes, that would be probably why we want to do object externally. We don't want to do shaping. First off, we do this. So the issue is that we can't do this, and we kind of. Well, I mean, if we're doing that every time, we might as well just pass in position, and then you calculate. Which would be x. We calculate p, which I think down here is what you would take. So we give you a position, and we extract the object, and then we get c, and then we go. Here's your. I did it wrong. Hit that. Paste it there, like that. Okay, so we get p, and then we say c. Oh, c equals 0 apparently, but no, we want to say match this, and then we want to return that, and then we just don't ever return when we get to here. Well, I guess we would return we just put the default case in, and then you pass in well, yeah, okay, so we just get rid of that, and you just pass that in, and then we actually no, do it this way, because I don't know if assigning, like, I don't know how well the compiler will remove this as not being necessary, because we assign it here and immediately pass it in here, but it makes more sense to me. Default. It makes more sense to me to do it here and then call this, because it means that, like, each function is going to be the same. Object type index. Interesting. All right, so I guess I call you an object that is a circle, and we pass in the circle data. Okay. Now do you work? No. Because I'm passing something P, and it says unknown identifier P. Excuse me. Something up here must be using P. So we call you, and then we do you, and we go, hey, SDF, and you get given our position. Oh. We pass in your position, we say SDF I, and then we say C, and then equal this, and then we shape type, which we don't need shape type because, again, we're doing that already. I don't think we ever use mul, so we should probably get rid of that. Apparently we're setting I equal 1, which interestingly brings up a thing of yes. Well, we need that, don't we? Which makes me go, I feel like I should give you, fine, we're gonna give you your object back. So you just take in an object. It's an object like this, and then we're gonna take this, we're gonna go cut that like that. And then we come up here, and we're gonna say let object equal object. Yes, that's correct. And then same with this. We need to say let object equal yes, like this. Okay. Okay, I don't see. I don't know how efficient that will actually be. And we're gonna go F5. Hey, okay. Okay, so now this all just kind of works. Not quite, but ignore the colors. Ignore the colors. Keep working. All right. So we can call SDF here. We need the object because we need the color. We do this here. We do this here. Now we grab this. Now, something tells me I don't want to merge every single shape into every other shape, but who knows. P equals F, so we'll probably just not do that. We can just use F. Right, that seems like it would be more efficient. Let me use S, but I don't. Do we ever actually use S? Like ever again? I think so. Maybe. If S is bigger than K. Okay. So this means that now when I add squares, I only have to do them. Yeah, I don't have to fuck around and try and add them everywhere. Now div, wait, that was what I was going to test. So what it looks like, but I'm curious. My eye is always set to 1. If I set it to 0, do I actually use eye for anything? I don't think I do, so it's not going to make like any difference. Okay. Cool. Anyway, that kind of also implies that I can just not do that, but 1000 FPS seems fine. It should drop quite dramatically when I turn the time back on, but I'm almost certain that's because I now need to spend a frame writing something to the shader. I'm also curious where my memory leak is. I'm assuming it's me constantly sending shit to the shader, but I don't actually know. Oh. Like, it's using lots of memory. It started trying to read something to disk. Oh, it's probably paged a bunch of shit. If okay, so I don't think we ever use S. No, we did. That's right. We use it there. We got I, temp. I think we use temp and var last. No, we definitely use last. S intersections. Do we use intersections? I don't think we use intersections. Intersections just tells you like how much into like how many different internal shapes do we hit, which I don't think we actually use. And then we obviously use this to just determine how many shapes we actually hit. And then div and color. And color is we could probably initialize color down here. And initializing that down here, I don't know if it'll actually save anything, but it means we don't discard it. We don't like initialize it and then discard nothing. Div position. Okay. So if I F5 this and it works, we can commit that. Okay. So clean up shader. Right, commit this. Okay, so now I need to flip my SDF around, which is going to require restarting the thing. So I need to go find the smooth operation. Smooth. Oh, it's this one. Nope, this is the 2-dimensional. This is the 3-dimensional one. Where is the 2-dimensional left here? Okay. Smooth. Oh, that's why I was in here, because this does have the smoothing. Down somewhere, smooth union. Okay, we should probably grab all of these because we may actually want all of these, and because we have to recompile if we change these, we're going to do this. Okay, so smooth union takes in a distance 1, distance 2, and a k, and then so we're going to say I finished that from somewhere else, didn't I? Wait, it's the same blog. He just had a function somewhere about joining them. So the smooth union is to take the minimum of the, I think I was using the exponential, so this one. So this is the minimum, and then we wanted and I don't know. Well, this is obviously the maximum, and so you take the mix. You mix. Huh. Wait a second. You'll mix. Divided by h. Okay, S min. But how do I take the max then? Well, this is the max. So taking the max, which one of these is subtraction, intersection. We go to the actual explanation. I think they say so. Blending poses is a really powerful tool. Okay, there are many flavors of such operations, but the basic ones come. Let's try it to replace the min and max functions using the op union, op subtraction, and op intersection with move variance. Okay, wait, no, we need this. Okay, so you are the min. Okay, so union, subtraction, intersection, XOR. Okay, so we need this. And so these are our operations. So say the union is the minimum of the two, which is what we were doing, which you now, and this is the maximum. So it's going to comment this out. This is the exponential max. So this is max. Right. So then we went S min, right, which is U. So this is the new union because we're going to swap to this. So SU and F and you return a F32. And so you're taking an F32 and F32 and F32. And then you say that K times equals this. K times equals 1, which we don't need to do because, you know. And then we float so let R equal exponent AK plus this, and then negative log R. Right. So that's our now new smooth union. Okay. Min. Okay, and then this is max, right? So the maximum, which we come down here, we go, is the subtraction, no, intersection. Intersection is the maximum of the two. So intersection. Okay, smooth intersection. Okay, so turn that off. Turn that on. So we have our smooth union. Yes, that would actually be correct. Thank you. Okay, so we have our smooth intersection, our smooth union. Okay, so it's intersection, and then so smooth subtraction. What is subtraction? Subtraction is negative d1. Okay, so just take the max of negative d1. And then XOR is the min of the max of the min of the max. Okay, so the and I don't think it makes sense to have a smooth XOR, but anyway, we're going to comment all this out. But right, so smooth subtraction. So we have intersection subtraction. Smooth subtraction. Okay, so first off, we need you to be a D1 is an F32, and yes, thank you. Okay, so then you're an F32 and you return F32. Okay, so to do that, we want so if this is the intersection exponential, how's the smooth? Okay, so smooth intersection versus the smooth subtraction. So you take you mix this and this by that, but then you take this by that. So you clamp this between 0 and 1 with 1 by k. Okay, so I don't think that's correct. So we just need to take the intersection, which is just the max of the. So I think we want to take the subtraction is the. We just need to pass in negative. So of max, and max is the intersection. So intersection max. So if we just take this, put this here, and we say is it negative? Negative the first one. So we say negative A. And then B. I don't know if any of them are going to work, but we're just going to go. That'll be right. So then this is exponential max negative A B. So then this is A, this is B, this is A, B. Okay. So that should be all of those fixed. You need to be FN, thank you. Right, so that should be all our operations functional. Right, which we're not going to use really any of them, but now we just need to go to our circle code, SDF shapes 2D SDF circle. I kind of wish I could put this up here, but it just cannot work out. I do that. So the way that circle works is when we call circle, we say go here, go the 2D variants, 2D SDF, then we're going to go circle. So circle is length minus radius. Okay, so length minus circle to radius. Right. So when I F5 this, hilarious that worked, but that shouldn't have worked, so that's concerning. Because I flipped the sign of all the bits, but I think it's because like this didn't get recompiled and neither did the operations. So we have to at some point modify something because I've flipped the signs, but it shouldn't be too hard because it should just simply be we want to take the min of u, and then you're the same, so you smooth union of u and u. If you're less than or equal to k2, so nothing's working, but that's should be expected. All right, so yep, and then we're going to say if k is greater than 0, greater than or equal to 0, discard. So we need to make u infinity. So k starts at infinity, and then we take the minimum of k and dot smooth union. Hey, our colors seem a little backwards, but I think that's because again down here when we set this up, we say hey, grab the SDFs, and then we say hey, actually you're the other way around. If you're less than 0, then you'll use this one. If you equal this, and if you're less than k, if you're, well, I guess technically you're, wait a second, I gotta remember how to reverse this. Okay, so that should work to fix some stuff. So then now the main color's back to working. So next is that if S is greater than, is outside of both. So if S is less than K, negative K, less than negative K. Right, because we're not inside the shape. Maybe. I mean, the blending's working beautifully, but the smoothing. I don't think this is correct. And then we can say you are greater than, if you're less than K, outside of both shapes. Right, first off, come in here. I'm gonna pause this. We're gonna go, okay. When, oh, you just really don't like working at all. Okay. So if X is less than, okay, so let's just turn off everything else. First off, I think the F is actually, in this particular situation, ending up being a negative. So I think that's what's happening there. So first off, do that. And that did not work at all. Okay. So don't times it by S. I mean, maybe it's over S. Negative. So you become a negative number. Okay. That looks correct. Where are we adding color still? Something else is still adding color. Correct? Correct. Somewhere. One of you fuckers is adding color somewhere. How? How are you still getting color from somewhere? F. Because F is positive. Right. We need to say here, and we say like F is equal to 0, and same with you is F equals 0. I need you to just not. Thank you. All right. So that gives us this. Okay. The next is to add the blending, which is to go down here and say, you do this, but you don't have the negative F anymore. Right, and then you become negative F times K. That's curious. It feels very blurry. Okay, well, doing that, that just does that. Now Negative f times k. Right. And then it just feels so blurry. It's interesting. F equals 0. Out of curiosity, you look very crisp. You shouldn't be blurring everything. Interesting. Okay, whatever. I'm gonna set you back to not zeroing the F, maybe. Okay. And then we just need to say that each of these takes in oh, it's all just gonna be the same. We might as well just make them the same. Sure. Just use the singular. Like just do this, do this, do this. I'm gonna say negative F. Oh, why are they all getting negative F? Well, you're times by S, so that's actually kind of funny. Why am I inverting you to invert you back? That's my question. Why am I inverting you to invert you back? Like, does this actually matter? It does. Okay. So this S is definitely negative. I don't know. Right. Anyway, this looks fine, maybe? I don't know. It definitely looks like it's blending. This again, you can really tell where it stops and starts, which just annoys me. But I don't really know how I'm supposed to blend it. I just put the normalize back. Normalize color equals color, normalize color. I don't know why I'm making like as if this is something new. Divided by I. Oh, it brings back some nice shiny stuff. Something tells me that I is a very negative number. Why is I plus equals F? Why is F? So F is X, yep. Well, we could have just flipped the sign there, but we... Okay. Right, well, we should probably just also not do this because there's no point checking stuff that we're not actually using. Anyway, get rid of the normalizing. The normalizing is done. Okay. Interesting. How are you getting up so high? Am I setting you too high? Okay. Well, this is only applied to colors that aren't inside, so we can make you like 5 maybe. I feel like you're too high. I'm like 3, maybe. I don't know. Okay, now you're white in the middle, which means that is just incorrect. How are you doing this? Why are you doing this? Anyway. Yeah, see, they're getting way too bright when they overlap. How are you getting so goddamn bright? And why is it only certain colors? Okay, my thought is that first off, you need to come down to like, you need to be 0.4 so that they actually like transition properly. See, but it's so clear where the gradation. Is it because I'm just using a different gradient? Well, that didn't work. F times K. Right. Cool. Blend them together. See, you can see. Okay, stop touching the colors. All right, time to go into the code base, which I'm terrified of because the last time I fucked around in this thing, it just drove me mentally insane. So we want to add squares. So we want to go like square, and we want to go, hey, so our square data, which apparently has a size and a position and a rotation and a color, is like, no, that's not what a square data contains. First off, square data actually doesn't exist anymore. That's right. I refactored all this stuff so that it actually fucking worked. So we're gonna go like this, we're gonna do this, we're gonna go, hey, so you're a square, and the square has a required component shape. Require shape. Oh, not shape, a shape. I think, oh, nope. Oh, shape. I think that's how it. Oh no, reflect. Require shape. You can't find this in scope. Please import from my crate. Okay. Shape. Okay. So then you don't use shader type? Okay. So extract square, and then square is just going to derive extract component. So shape. Yep. So you need to derive extract component like that. So a square has a width and a height. Okay. And then update square data. We're gonna go to circle and work it. What do we do? So first off, we need to update bounding box, which I think is how we know if it's on screen. Right. Detect need clear. Clear object data. Okay. Change circle. Okay. Change setting. See, that's the fun thing. This is telling me that like I did very rarely ever. Detect need change. Okay, then we're gonna go down to here. We're gonna go to square. We're gonna go, hey. So let's just get rid of that and go, okay. So we have squares, and the squares work like that. Okay. So the first thing we do is detect change, and then so this is going to apparently be imported, and we're gonna say that this is actually square and square and square. And then query is empty, and then we set the bit. Okay. I feel like these all need their own plugin. Like, I don't remember how I'm doing this, but I think I want to be like something like plugin. I'm going to say circle plugin. Circle plugin. Right. And so this is going to be like we need to go up to mod here and work out when exactly we add the circle stuff. So this is update circle data and detect need clear. Right, so we just need to like do this, and then are you doing something with circles? Render up. No, this is the 2D shape buffer. Okay. So I do feel like I should probably split the circles into their own circle buffer, but pre-update update bounding box for circles. Okay, so and this also loads the shader for the circles. So this 100% becomes I also probably want to register this stuff all in. Just take everything out of this plugin and come over here and paste it all in this plugin, and then we're just going to take these two away. Just like don't register these types because they're not actually yours. Oops. Okay, so we register the extract plugin, which then pulls it out in the world. We load the shader library, and then you app.add plugin, and then you're going to say circle plugin. Okay, that's what you do. Right, because that should make it much more like clear. Also, you just say update. So it also means it's much more clear that it's when we say like you don't need to. We can say instead of calling update data, can we just rename this to well, not update circle data, just update data, and then we just need to make sure that we bring in all of these. So import render shader set. I don't know where that's coming from. What? No, import. Then we have to import. Yes, please make that shape set. So this is update bounding box, which happens. Yeah, okay. This is also an import that I need to do, and then we need to also import. What? No. This. Okay. So then we can get rid of preload that we apparently have twice now, and then we're gonna go, okay, so it probably needs a little bit of rearranging, but we should be able to go like A, C, A, V, and go replace the word circle with, replace with square. Oh, this is not where we want to place this. We want to undo that. We're going to go here. We're going to go, okay. So first off, make sure you've got word square. Okay. A, V, Control, F. Replace the word circle with the word S-Q-U-A-R-E, square. We want to do this everywhere. Okay. So square, and then so it's not square.radius because the square has a width, which is an F32, and a height, F32. Well, actually, we could probably just put a size. I don't know, I feel like keeping them separate for now, but we'll probably just replace it with size. And then we want to say that it's actually, I don't think we need no times that way too, we just say width and height. That is your bounding box, which is why we should probably just replace it, because then we can just say bounding box. So then we're going to say default, and then, so first off, I don't think there should be a default square. I mean, there's no reason we couldn't, but, okay, is visible. It takes in self and distance and says, okay, so if distance is less than, no, that's not right. We want to say that if the distance is less than, okay, if we said distance times distance, right, just rather than trying to calculate a square root, is less than, okay, so the hypotenuse is, so I actually also don't know where our, so our center is going to probably be in 0, which I don't, yeah, you radius times 2. Okay, that should be fine. So your distance, so we want to say like, is less than or equal to self times width times divided by 4. I don't know if that's right. I mean, that should work that way. So like if we said like 2 times 2 divided by 2 is the same as, it's not though. See, because 2 times 2 is 4, divided by 2 is this, which is not the same as 1 times 1, which is what we would get if we said a half times a half. Alright, let's try something else then. So if it was like a length 3, it would be 3 times 3, which is 9, which is divided by 2 is 4.5, which is not the same as 1.5 times 1.5, which is 2.2. So sadly, we'd have to say that H width equal width divided by 2, height divided by 2, and then replace that like that. Multiply that by that, and then we say if the distance is less than that, then you're that. Okay. First off, you should be the word squares, and then you should also be the word squares, and then you should also be the word squares. Okay. So when we say update data, we get square buffer.squares and we clear it. These should probably be their own buffers, but anyway. Then we say for I entity square transform color squares.iter enumerate buffer squares push square. Okay, and then we say id, let id equal objects push create. Okay, so push object data, which is the offset, and then our color to linear RGB, and the shape, which is square. And then shifted board with I shifted 8. Okay, commands entity insert object index ID. Okay. Right. Then we want to detect need clear, which is to say that, and then we can do the plugin, which we render this and we render the squares. Okay. So then we want to go up to you and we want to say, hey, you're fine. There's no such thing as square data anymore. I'm also going to say like, there's no such thing as triangle data, but it can be one for later. So now you hold squares. Okay, apparently we have to leave triangle data. So I don't know. Okay. So we have our square, we push our square data. Somewhere down here we have our 2D shapes plugin. Yeah, which then we're going to go, hey, can we add circles plugin? And then we're going to add the squares plugin. And don't add the triangles plugin because it doesn't exist. Then we go down here and go, what the hell is your problem? Because you're supposed to be square. And storage buffer read only. Okay. This feels like it's a colossal waste of memory. You seem to have a problem because SDF squares doesn't exist. Right, which is Control C, Control V, rename you to SDF SQ UAR square. Okay. That fix you. You should be fixed now. Except it's capital. Okay. Should we go fix that before Linux user tries to use it? Square. Okay. So circle is complaining about something, which is that radius is never used. Okay. How do I get you to shut up about that? I don't care. Okay, so then we go back to our main and we go somewhere, move shapes, we spawn in, pick target, spawn squares. So need to go up here somewhere. I think this square, new, width, height, transform, shape, color. Cool. So to go up somewhere we spawn in. Right. So we spawn in squares. Alright. So that should then work, and we should be able to go here and run this. And let's see what it does. I have no idea what it's going to do. Probably nothing, because I told the squares that they're the same as circles, which means it's probably going to panic because the square data is different. Okay. First off, you don't bind group 1, you bind group. Okay. So first off, it doesn't like whatever I've done. That's fun. So we're going to bind you to bind group 1, and you're also going to be a square, right? Which has a width F32 and a height, which is F32, and done. Right. So width, height. You are an array of squares. You're a square. Oh, yeah, no, that's correct. Squares. Then sure, fix everything and I'll just make sure. So you square, and then that's incorrect, but anyway. So the distance to your center, which is what this number represents, is the square root of width times height. And then apparently we're just doing length, which is just going to treat you as a circle, but that should be fine. Sure. It's not correct, but so we have to like recompile it now. So squares are bound to 1. Now my issue here is I don't think I've bound the shader to actually stick the square data in, and this is the part that I hate the most because it's just so hard to find everything in here. This is object buffer. Somewhere we're looking for object layout. No, shape layout. Shape layout. When do I actually assign to shape layout though? This is core layout. We have to find where we assign to shape layout, which is to get layout here, which render device create one group layout. Here, and this is for shape to the editor. We map shape the layout. Okay, so well, according to that, we actually bind them accordingly. Okay, but when do we use this? Maybe like because I feel like as soon as I try to touch that data, it's just not going to exist. Shapes layout. When do I actually use you? So you're here and you say shapes buffer 2D get layout. Right. Okay, so you should be binding them correctly. And then we go down here and we say create bind group with the shapes layout bindings. Yeah. Okay, bindings. Where do you get bindings from? Okay, bindings like create. Okay, if new match. Okay, buffer is shape buffer. Okay, shape buffer is changed. If buffer to right buffers, am I just ignoring it here? No. Like I'm not doing it. Okay. Somewhere I have to be using it. So we bind it to the shapes layout. That's it. Like, okay, somewhere I use this bind group here, shapes. Okay, shapes group. Where do we use shapes group? As ref set bind group 2 bind group. So maybe it's because I was just never using it. Maybe I was never setting it. I don't know. So you don't like this because something about SDF shaped circle unknown identifier. Where is this? Okay, so again, you like a lot of commented out stuff that I don't care about. So what are you complaining about? You're saying that SDF shape SDF circle unknown identifier. That's going to be inside of here. Wait. What do you mean? SDF circle, which in here is SDF circle, yeah. And then this is SDF square, which is its own thing entirely. Did I override the circle? What have I done? Unknown identifier. No definition in scope for identifier. SDF circle. Did I break the circle? So you're saying that the identifier doesn't exist, which Bevy SDF shapes circle. So that's got to be like a right at the beginning thing, right? Like I'd export it. Maybe it's because I'm exporting them both as shape. That's interesting. Maybe I if I do that and then restart it, that would imply that you can't have the same something. I would assume that you could have, but maybe not. I would have thought you, like, if you exported the same path, then you just have to specify the specific thing in the path. Okay. So first off, something's just returning 0 a lot, which is theoretically, I'm curious actually, is can I discard early? Like if I came down here, can I say discard? Like, is that something I can do inside a function? Discard like this. Like, can I say like, hey, you tried to render a shape that doesn't exist, discard? Apparently so. Now apparently there are no circles. There's nothing anywhere apparently. Okay, so first off, entity object has no object index compound. Generating noise, circle data has changed, setting clear flags, square data's. Okay, so first off, what is happening? So we're saying SDF circle. My assumption is that you're getting a square and then you're discarding a square. Right, because we have to actually tell you to match on square, which is case square, which is to SDF square. Right, which means we have to come up here. We have to go. We probably want to go the SDF circle. I want to call you circle. That. And then we want to go back to here, and we're going to restart to do this. But circle, right? And then we're going to go. I want to pull in ID, but like, you know, yeah, it's called a square. Right, okay. We should probably rename them to rectangles because that makes a lot more sense, but you know. Is that what they call in here? Yeah, just rounded box. No, we want a box. Okay, well, we're gonna call them rectangles because box is terrible. Rectangle. Rectangle. Okay. Thank you. The spelling of rectangle. So first off, you're called a rectangle. You are called a rectangle, and you're called a rectangle. Okay. I'm gonna keep calling them a square in the code, but they are called rectangles for sure in here. Please export shape rectangle. Your rectangles, rectangle. Oh, I don't know what you're trying to do. Yes. I said yes. Please. Rectangle. Okay. So if I first off, surprised it actually did do anything. It should complain that it doesn't exist, but it's not. So that's a little confusing. It's called square, but it's actually called a rectangle. Okay. So const square didn't find something about const square. Case square. Because it's not case square, it's case rectangle. Rectangle. Right. And then we come up here and rectify. It's because it's called SD rectangle. And then we go F5. Hey! Now, some of these are not like the others. And that is that they are rectangles. But because they use the circle SDF function, they're just circles, but with a rectangle data, which annoyingly has the same issue of I need to reboot to actually see the changes. So anyway, we're just gonna, this is not what we want to be. Okay, so we want box exact. I'm curious if like, is there as an orientated box? Interesting. So the orientated box to me, like as a concept, would mean that we probably want to go, hey, if your rotation is 0, then we're just going to say that you're a box. And if your rotation is not 0, then we will use orientated box, which is, I mean, not that hard to do. Which, what is P? P's position are A, B, so B's bounds, TH is theta. So what the hell is A? That's what I don't like about these, is because he's not named them properly. Like, well, I say properly, they're not, he's named everything with letters, and it makes it really hard to know what the fuck he's passing in and out. So okay, so what are you changing? So pause this for a second. You're feeding in a random position and A. So what is changing with A? When do we decide what A is? Animation, cos time, right? So that's changing theta, which theta is then I time. V. Okay, where is our box? So we have V1 and V2. V1 and V2. So annoyingly, one of these is like width and height. Is it the corners? Is that what he's passing in? No, that would be stupid. Passing in two values, V1 and V2. The issue is that we need to set, like, can we set time to 0? How do I get time to 0? 0 second. How do I get you So you're passing in V1 and V2, but like I want to know what happens when I change V2 because you're obviously rotation. So time times 0 plus vec2 of 0. So no matter what, both passed in 0 all the time. No, because you're adding a half to it and you're multiplying it by time. God damn it. What the hell? Because since your box doesn't need it, right? Like if we go back, a box doesn't need whatever A is. Right? The box just takes in a bounce. So I don't know what A is. Because it can't be thickness. And it'd be really weird to specify a length and a height. So you've got an A and you've got a B. So I'm thinking this might be A and B. Position 1, position 0.1, 0.2. So it might be position A, position B. So to specify the corners, which... But then why would you just specify the angle? Because you just know based on the two corners. No, because you need a width and a height. So you're a bounding box. I reckon you're a bounding box, and you might be... yeah, I don't know. I don't get it. Anyway. We're gonna put both of them in, simply because it's like significantly more code for me to I think I have to recompile twice if I don't put them both in at the same time, and I want to add the second one. So we're gonna say that this is this. We're gonna get rid of this weird orthogonal box exact. Okay, so first off, you're a FN. You're an FN. So you are an SD rectangle that takes in a F. You take in a P, which is a vec2, and you return this, and you say that D, let D equal the absolute of P minus B, then you return the length of the max of A, B, D. Okay, and then you need to be, so that's the length. Now, the thing is, like, do you pre-compute the half thing? Also, I think you are supposed to be half W. That's the other issue. Is the bounding box supposed to be the half extent or the actual bounding box? The max of D. Oh god, this is just terrible. So first off, you need to return a vec. Well, I mean technically, we could just in here get our rectangle. Why not do that? So you can just return an F32, and then you, instead of doing whatever the hell you're doing, you return the SD box, right? So, and then you say SD box like this, and then we say we pass in P, and we pass in this like that. I don't think this is correct. I think this value here should actually be half these, but you know, I can't be bothered. Let HW, and then it's do that. Okay, cool. So that should fix that problem. And then you're the square root of that because we actually want to pass the length back. And then the box is this, and then this, we're going to go, hey, how good are you at fixing this? Okay, so P is this, and A is this, and then this, and this, and then you're saying that let Q equal this, and then, so you obviously need to be a var, because we reassign you all the time, so var Q is equal to P minus A plus B times 1/2. And then Q is equal to this times Q, theta absolute, and then this, and then okay, so we're gonna say like orthogonal box, so we need okay, so we need FN SD orientated rectangle. Well, I'm just gonna be lazy, and I'm just gonna say return return oriented box, except I'm gonna do this monstrosity of a you don't do this. You take in again. I don't know what A is, so I don't know how to extract A. What the hell is A? Okay, what is A doing with A? So we're saying that the length L is the length of B minus A. So it must be the two corners. Like if you want to specify a rotated box, no, because why would you need the angle? If you just have the two corners, then you know how to draw a box. You don't need an angle for that. So that also means that a rectangle probably needs a rotation. Interesting. Well, but then does that make them a separate shape? I feel like it shouldn't be a separate shape, but the thing is, like, circles don't do anything when they're rotated. Okay. Anyway, I don't know how to pass in this. I'm gonna have to keep them separated, which means annoyingly, I need to pass in A and B as like their own thing so that I can specify them at different points, which is that I need to pass in. Okay, no, just no. Just pass A and B through, but I'm fairly sure B is just the bounding box again. So we're gonna say vec2, and then you're just gonna return the square root of interesting of length B minus A times B minus A plus theta times theta. That's not correct, but just gonna I have no idea if that's the right number. Okay, so the thing with that is we have no way of passing a rotation in anyway, so it doesn't matter. But what I can does let me do is that it means that when we recompile, I can like just hard code in different rotations for the boxes and see what happens when I change the variable that is the A. Alright, so you didn't like this because mat2 unknown identifier. What the hell is mat2? Do you declare mat2? Mat2? No, I think you just use mat2, which means mat2 is like a function, which I think is matrix2. So we want to go wgsl mat2. See, that's the thing. I don't know what that. I'm assuming it's I'm assuming it's a matrix multiplication. WG mat 2. You annoy me with this. Okay, so mat2 here. I don't know what language shaded toys thing is in. What? The start and end of the line segment the box is built on top of. The theta argument is the width and thickness of the box. Oh, that's so bad. So what you do is you specify here and here and you have a fucking thickness. Removes one square root division and has no numeric. Okay, so first I'm kind of curious. Distance box. Are they just floating it? Oh, drawing a circle. That's kind of cool. So C, center of box, half extent of the box. Orientation vector. Okay, I don't know what the orientation vector is. Sine, cos, pair of rotation angles. Okay, and S and R. Yeah, rounding radius and stroke width. Right. But D minus S. Distance A, BB, bounding box. Transpose mat to U, skew, U, P minus C, distance A, B, B, B. So at least they wrote skew, which means that I can know what the fuck skew means, which is apparently just negative Y, Bx, distance A, B, B. How the hell do you do this? So you pass in fragment. So distance bounding box of M, which is position. Oh, this is mouse. No. Where the fuck are you getting D? Okay, so D is bounding box, which is P, so the position, right? C, which is the center of the box. Okay, so I don't like that your distance box. Your P minus C. Yeah, so you literally just say P minus C. Okay, anyway, so C and then R, which is the roundness of the corners. So I don't care about R. And then HE, half extents of the box, vec3 of width times a half, height times a half. And then U, which is the something about a rotation, orientation. Okay, so I'm take that distance box. So we need the distance box function. Okay, so copy the distance box function over to our shader here. Okay, so we have a distance box. We're gonna go here. Should probably put like things on stuff, like comments saying like where I'm stealing the stuff from. Paste this here. So it's just fucking, why not just name this shit properly? But anyway, so we only pass in U here, and we don't use this. Okay. So P is the center of the box, which because we just say P is equal to. And then your U, skew U. Okay, so we need to copy skew, and we need to copy the URL to the shader toy person. So copy this, and we're just gonna say first off go here, and then go so credit for distance box. Credit. Is that okay? Why did you remove the closing parentheses? That very odd. Anyway, anyway. So C is center of box, and P. So we're gonna say C is the center of the box, and then don't do anything with P. We need skew. Skew. Stop opening this. Open this. We go skew. Skew just is like a function that does a thing with a number. Okay, so skew. Now transpose apparently is a real thing. I don't know. So there's an FN skew. And this returns a vec f32, and then you're the same, you take in v and vec 32. Like, this makes me think that the shader is like loaded onto the fucking GPU as the code, like it's not compiled, so that's why they use just fucking single letters, is because it's faster to parse it. But this is just horrendous. Okay, so I have questions. Distance AABB, which is annoying. I need to copy distance AABB, which I think is the normal rectangular one. So it seems like it's constructing a rectangle on the fly. So FN, and then, yep, do that. Okay, so distance AABB, which is to take P, which is this, HE, which is our something, half extent of the box. Okay, and then F, and then we say that D is the absolute of P minus the half extent of the box, which is I think what you were doing. Rectangle. So SD box P, which is the absolute of P, absolute of the position minus the half extent of the box. Then we return the length of D max min max div. Okay, so this is our SD box, which we're going to get rid of now. And we're going to say, okay, so we want the distance AABB, and I don't want to calculate this every time, which means we're going to pass half extents in. So pass this, don't do this. Okay, half extents. Yes, okay, so this is the rectangle, it gets AABB. Okay, then we need to say the oriented rectangle. So this is going to go away because we're not going to use this because you didn't name anything and it annoys me to no end. Okay, so distance AABB. So you take in that and then the half extents. Okay, and then you are distance AABB. So distance box. Okay, so we need to say the half extents, right, which we can pass in, and then the U, which is the orientation of vector, sine cos pair of rotation angle. I mean a sine cos pair of the rotation angle. Can I not just pass an angle and then extract sine and cos out of it? What is mat2? I need to work out what the fuck mat2 is. For an oriented box without any okay, so what I don't follow is so how did you calculate the, what is it, U? So you take the cos of time and the sine of time, so it's just a cos sine. So why don't you just take in a single number? I guess it's probably expensive. Sure. So the idea would be we could probably put in the rotation, right, and then we put in it's gonna be a vec2, like so, right? So cos sine pair of rotation angles, and so you're a this means I don't think we can just stick the same data in, but anyway, we pass you in. Okay, so we still need to work out what the fuck mat2 is. I think it's a matrix. mat2. Okay. mat2 shader. Wait. What does mat2 actually mean? But what the hell is a mat2? mat2. So it's just a matrix. So you say mat2 is equal to transpose and then mat2 of U and skew. Okay, so why do I keep opening this one? So we're gonna go WGSL transpose. transpose. Okay, so transpose is a function, and transpose takes in a matar ct, where t is a float or f32, rotates transpose for e. Returns the transpose for e. Okay. So I have to make a, was that mat r x c? But I'm assuming r, x, and c are like a specific kind are something specific. So you're mat 2, so something r, x, x, c. So what was it called? Why can I not remember anything for more than 30 seconds? Mat RXC. So what I'm not following. See, mat XC is in it, mat CR, or RC and CR makes me think that it's actually mat 2x2 equals transpose mat 2x2 u and skew. I don't know if that's going to work, but how did I end up doing this? Please help. What have I done? Okay, no, you go away. You don't exist. You're okay, so let I don't know, is it must be M. I've deleted the original thing now. It's funny. Okay, what was it? It was M, yeah, M. Let M equal transpose this, and then it's this times this, because P equals times or apparently your P P, right? So transpose this. Right, I don't know if this is even going to compile. That's the annoying part about this. SDFs. So the issue with you is, first off, you're not even the same size, so I'm somewhat surprised that they didn't crash, probably because it didn't compile. Sorry, distance here. Something I'm using a let d, vec d. No, it says let d equal that. So now I have to recompile the whole thing. We should probably also make sure we include in our rotation doubling. So you didn't like that because something about something transpose expected found, so F32, I'm guessing. So we also need to go to our what was it? So we need to go here. We need to go like, hey, no, it's here when we say square. When do I stick the square data in? Detect need update data. So we take our square and we take our square buffer, and then I think we stick the object information in. So we could make the object contain the rotation, but I think that's actually kind of inefficient. But like, when do you actually square push square? So that implies that the square here, when we stick in the square, because it's a shader, needs to actually have the rotation, which is annoying. Which means that we need to actually make the we need to make a pub struct square data again, which is going to be pub width f30 f32 height f32 and our pub rotation, which is a vec 2 yes. Yes. Okay, So the question is the sign of sign? Oh, okay. Oh, apparently the sign of 0 is 0. So that means that what we can do is first off rename this to square, so it starts yelling at me that it shouldn't be capital. So what we're going to do is we're going to take in your offset. Interesting. So we need a square. The square, annoyingly, can take in a So, you know, admittedly, probably a shape rotation. I feel like if we're gonna do that, we might as well just stick it on all of them. Obviously, circles don't use it, so we can just ignore it. They're kind of bloating out circle data. I don't think it's a problem though. So we just find, we just go, hey, when we push this object data, we also need to push rotation. Okay, so squares don't contain a rotation, for one thing. So we have our, right, we need a shape rotation, which is something we need to calculate. So you need to transform, which we have access to, right? I'm going to say, go away. We need to find where we declare object. We need to say that an object, object has a rotation, right? Which is a 0, 0 implies no rotation. Right. So it means like don't run the rotation version. Obviously, like circles are always going to not be rotated. And you know, rotation, square, rotation. So first off, update data. We have access to the square. So the square definitely has a transform. The shape offset. I reckon we need to go to shape offset. We need to go. We need to import. We need to pub struct shape rotation. Right. So like this, I feel like I want to change how I'm doing this, but anyway. So we're going to import this, and it's new, and it's going to take in a rotation, and it's just going to return the sign and the cause of this rotation. Yep, cool, that should work. So this mightn't work in 3D, it's the other issue with this. So shape. So a shape needs a bounding box, and it also needs a shape rotation. Shape rotation and shape offset, right? Shape offset. Now I do feel like maybe I should be removing, right? Yeah, you're not a component apparently. So my question is, do I extract component? Yes, we extract the bounding box. I'm curious. For one thing, are we actually ever extracting shape offset? That's an interesting question. I don't actually know. Like when the fuck do we use? So update offsets. Right, we manually do this one because we need to only change it when it actually changes. Which I guess we should also say, like, since all of them have an offset, and mute our shape rotation. Except I don't want to kind of make these a requirement of shape. Interesting. My thought is, like, I wanted to make it also feel like I don't want to update it every time. So we want to be like rotation. So we just want to like store the rotation as well, so that we can check. So we say, hey, if shape, hello, Sunny. Okay, so shape offset. We say shape offset to 0. And shape dot rotation equals 0. Continue. Otherwise, shape dot offset. Oh, well, so it's more like if shape offset doesn't, then do this. And shape dot rotation. And then if shape dot rotation does not equal Euler XYZ. I think the Z's are on axis. We want to say, yep, set that. Otherwise, stick in a shape offset with a shape rotation, like so. I don't know if this is gonna work, but I feel like this is gonna have a bunch of duplicate stuff in the main world and then on the rotation, whatever. Okay, so then you set your rotation to a we need to grab out the shape rotation like this. Shape rotation, and then we can say shape rotation. Actually, we want to grab that as color, then rotation. I'm going to go here and we say rotation is rotation dot to rotation. Well, I guess to vec 2. And then we need to go actually to the shape rotation and import that. So shape rotation to vec, which is sine and then cos, and then we go okay. Missing field rotation. So you need to do the same thing. Where first off, you're a circle, so your rotation is just always default. Oh, the answer to this is from. Well, first of all, we bring in shape rotation, don't we? Import this. Then, what did I call it? New, and then just 0. It's a little expensive to compute that every time, but yeah. Okay, no, yeah, you just actually just vec to 0. Circles, yeah, circles don't have a rotation. I like that comment. Okay, so we pass in all that information. We pass in the square data. We still haven't actually been rendering squares, but you know, future me problems. So annoyingly, right. So now we're actually passing in the rotation, and then we also extract the rotation. So that should work, I think. I feel like I need to extract all this stuff separately. Okay, I'm sure I probably can. If you stick a shape on something, you probably make extract shape. No definition in scope for ident SR or box. Okay, so we renamed something, didn't we? That's in here. Okay, it's because it's not that. It's distance box. And annoyingly, I need to know, well, what's fun with that is I kind of do need the rotation to be stored inside of the fucking rectangle, don't I? Because I can't get the angle otherwise. Well, I guess I can, because I can pass it to rectangle, and then you would take in, I guess, ID, U32, and what was the other thing called? It was called like U, which is just a vec2. Like so, and then we go, hey, can you call in distance box? So you call AABB, you call distance box, and you pass in, yeah, do that. Now I do feel like the fact that I'm using a square root every single time, I should probably just store that in that. Yeah, I feel like that probably should be stored inside that. So annoyingly, it's more sort of bloat that a rectangle needs. So apparently a rectangle doesn't have a rotation anymore. That comes from, but it does have a I guess c square. So that's it. The dist. Well, I guess it's a h dist, which is the 32. Right. And then you just return rectangle.h dist. Rectangle.h dist. Right. And so the rectangle.h dist is just the hypotenuse distance of the rectangle, so from the center outward, which when we calculate something when we say new square, you need square here needs a hub h dist, half the distance for visibility checks. So no, so your h dist is equal to the square root of 10 times 10 plus 10, a squared plus b squared. Okay, first up. Also, I think default should just call new, and then obviously new is going to be this, and then we go, hey, can you just like call new? Square new 10 and 10. Thank you. Right, so is visible, and then you just say you don't need these anymore because we've decided it's actually the h distance, except it's not that. It's if distance is less than self.h distance. There you go. Okay, so now we make a new square, but now every time you change the size of a square, which kind of means I need to make these not public. You can get the h distance. Actually, no, it shouldn't be public. It should be okay. Anyway, right. So if I make them private, I feel like they still get changed, which is annoying. So yeah, you don't like that, but I need to restart to do that, and then I'm hoping that the h distance is in the right spot and it just works now. The issue, I think, also is that I need to come to wherever I have stored object. Object is in core. So core, so I need to go to core, because it means all the objects are like going to be wrong, because, you know, just wrong in general. This is immutable. Okay, yeah. We need to go to wherever I've got core. Core needs to go here, and we need to say object, and you need a rotation, which is, yep, angle compares, dash 0 0 0 0 time 0 implying no rotation. Okay, so okay, struct view translation size. Okay, so we buy our objects, and then we go here. Okay, so first off, we have to fix this because annoyingly, S, replace it with an S. Cool. hopefully that works. I have no idea if it's going to work, but apparently the answer is no, because something about failed to build function SDF distance ABS is invalid, and so it's saying that the max, which takes in the D and then D. Okay, expression 5 is invalid. Arguments max as expression has invalid type. Right, so we're calling max on something. Max on D, and D is the absolute of P minus H. Okay. But the length. Okay. That's confusing. I'm assuming only like vec2. Like, is it this that's it's saying like you can't do that because it needs to be comparing two vectors? Oh, that one. Hey, there's lots of weird blobby squares floating around. I don't know if I like that. Those squares like just sort of fuse together in a really weird way. Now something's definitely going wrong because we really lost our frame rate when we wait. Am I iterating through everything again? Did I accidentally remove that optimization? I thought I was only iterating through the visible objects. Yeah. Okay. So that, well, one just tells me that I'm probably saying that a lot more objects are visible than they are. I think it's like the F12 I made it. Yeah. So how many objects did it say that I can see? It says 29 shapes are visible. I think you're running a little bit more than 29 times. I'm going to say if, first off, we should probably pause it so that they don't keep moving in and out of the frame, because that would kind of break the point. Okay, so if I hit F12, then it's going to tell me that I have so many things in frame. Okay, so 28 shapes visible. Right, 28 visible shapes. Okay, so if view dot visible visible len does not equal just say 28. White, black. So we're gonna say 28. Right. Did I save this? Did it reload? Okay. So that implies that it does equal 28. Why is the frame rate so bad then? What the hell did I do to my frame rate? I was at like over 1,000 and now I've done something and it doesn't like it. Whatever. I'm iterating through something wrong. Is there actually 28 things on frame? 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm going to say 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. There are 28 things on screen, so obviously I didn't have it wrong that it's just rendering a bunch of shit. It's not there, but I don't know why my frame rate's fucking down to 800. It should be up at 1,000. I know it's particularly low. Okay, so if I found one of these, so it's one of these ones that doesn't have it, so we need to find like 702. I suspect it's part of my frame rate losses because I'm iterating through like all of these every time. 702. Which doesn't make sense. Why are they even doing it? Alright, 702 is definitely one that's on screen, right? Right. 702. Right. You don't say circle, which means that you must be a rectangle. Or a square, as I called them. So H distant is okay. I don't know what square you are. What color are you? Like this weird, horrible green color. Make you white? Is it this little one in the red? No, where the fuck is it? I actually have no idea if it's even updating the thing. It's not. So since objects, yeah. So when we change that, which is shape color, I should fix that. That seems like a bug. Well, seems like it should be a bug. So somewhere, maybe here, I need to detect need clear is shape color changed. Yeah. So why are you not detecting this then? How do I, well, I was gonna make it opaque, but I did that one. Okay, it is actually working. It's just not telling. What? Can I also move you a little bit? I think you like not be inside the big red cube. Oh, okay, because I made it black, right? Okay. Well, now you're pink. For some reason, making you pink made you white. I don't get that one. What have I done to you? Oh, what's making you white all the time? Weird. Alright. Oh. Because something else is getting into the screen and I've got it hard-coded to the number of shapes. Alright, anyway. If I change your rotation along the X. Right. We need to actually implement that code. So we go circle and we say, hey, rectangle. So you've extracted the object here, right? So we're going to say if object dot rotation dot x equals 0, which implies that you haven't actually rotated it all. Do this one. Else return that one. And then can we something like that? Oriented rectangle. What did I call it? I think maybe I'm just not importing it because I'm almost certain that that's what you're called. Unknown identifier oriented rectangle. SDF oriented rectangle. Can I? Hey, okay. So it doesn't appear to actually be doing anything, which is annoying. But how do I get you to actually do something? First up, this is the Z, and it's not actually doing anything. If I change the other values, maybe I'm not extracting properly. When do I extract objects and rotations and whatnot? Usually I feel like I'm doing it on a per thing basis, which means that I am, because I'm specifically going circles don't get one. All right, so when I called rotation to vec2, interesting. Okay, so call that rotation to vector. Yeah. Rotation to vector. And when I call that, you just pass in your sine and cos. Okay, so question. Can I say, first off, because every shape should check every shape, this first thing to check is, are we actually ever hitting the condition? So if you please, and thank you, can you return, just return back to -1, I guess. I don't know. What the hell is -1? Yes. You don't like that I'm returning like that? Okay. So Are we never getting here? If object dot rotation. So my question is, maybe I've got rotation in the wrong spot. I just return lots of 9s, then like every shape should be inside and it should just do something. Oh, it definitely did something. Can we 999? And then I want to go, none of my shapes should be big enough to be 999. Then we can go here and we can say, hey, when you check a shape, if c dot x equals 999, negative 999, and c dot y equals 999, can we return black? Okay, so the answer to that one is we are never getting to object dot rotation equals 0. So if we say that object rotation equals 1, implying that all the rest of them, okay. So we are definitely just never getting here, which I need to get rid of that thing that specifically hard code checks for a very specific thing. No, don't do that. Okay, so you, interestingly, that also implies that we've got this wrong, because as you can see, if they go off the screen, they disappear, which means that our distance function for them is incorrect. Which I think is because we actually want their half extent times 2. So first off, we have to go to square and we have to go, hey, detect. Somewhere you calculate, you update data for one thing. So reloading SDF shared. So update bounding box. So because we're using half extents, it's actually let's do. I don't know if it's faster to do it that way, but do it. So that should fix the bounding box issue. So why are you not rotating? So my thought is that we don't update shape rotation, update data. And when do we update shape data? I think this is update data inset update, detect new clear, need clear. Okay, so this is when that runs. So can I just like print if rotation dot rotation does not equal 0, can we info square rotation, but we don't ignore the rotation, so fuck you. Can't compare you to a float. There we go. Can't compare you to an int. Okay, so first off, if we go find a random square, so if we do like this, no, here, then we can go, one of these is a square. So anything in the 500s plus should be a square. Let's also pause time. So 900 here. So first off, we're going to go, can I copy the whole thing? No. Can I just copy this and find the camera? Let's go to like number 1000. Okay. Yeah, you're a square. So we're going to just go to this one because it should be easy to find again. We're going to go camera. We're going to go transform somewhere. Transform. Paste this. Oh, we're moving around as I fucking type. Okay. First off, why are you moving? Okay, so for one thing, you're just not working. I think you're just really far away. Let's just redo that. Okay, so we need to like pause and then go, one of these is not like the others. I think we're spawning way too much shit in. So we need to find 870. So in theory, when I turn this, I could have done literally any of them, but you know, when I change your rotation, you're not actually printing that the rotation has changed. If I move you, you render. You now render black. Okay, so it's not detecting a change in rotation. So is that because the global transform should be changing? Shape color. Did I not say that about? Because I'm not seeing a shape. Oh, yeah, shape rotation is there. So the global transform is changing. Yeah. Yeah. Okay. So it does say that. Okay. So why are you not detecting that change in rotation? So update data. So you need to change, so change square. So you only re-push square if square change? Yeah, but that's fine. That's fine. I think what that means is I need to go to, it must be mod. And then here we say, hey, change the color, change the offset, or changed the rotation. Shape rotation. So I should probably like combine those into a transform. You just use a transform. That would be too easy. Now if I rerun this, it should now detect rotation changes and then render it with a rotation change. Okay, that should work fine. So again, we need to E, debug, and pause. And then we need to hit F12 and go, one of these is a rectangle. Surely. Okay, 905. Okay, so we're going to go here, we're going to go, hey, 905. 999, let's say 995. That's why I was looking in here. My brain knew, but anyway. Transform, rotate it slightly. So now it's printing stuff, which means it's detecting the rotation, which means we're actually rendering the rotation, which means we can go back to here and we can say, hey, you can just like not do that anymore. That would be helpful. I'm going to come down here and we're going to say, hey, not. Turn this back on. And then we're going to go, well, we need to F5E. So by that logic, one of these is supposed to be rotated. Can we change its color? So it should be lime greenish. Well, if I make it black, it's this one over here. So you look a little skew, but okay, so 0.7 maybe. I mean, it seems to be doing something. The issue is I can't see it while this camera. Can I change this to a different camera maybe? Not really. It's so annoying. Well, it seems to be doing something. Okay, so I mean, it's reading the rotation. Okay, cool. Well, it's rotating. I don't know if it's rotating correctly, but it's rotating. So I guess the only way to really tell would be to put some kind of rotation on them. So first off, we need to probably stop whatever the hell this is from spewing out this ungodly amounts of debug information that's completely irrelevant. So rotate, yep. So we do that, we pass in the rotation. Okay. Primary reason for that is because we don't want to compute it every time. Something tells me I should probably just pass the rotation as a single value of the actual rotation and calculate the sine cos in the shader, but look at the shader, it's already chugging down at 800, so we don't really need to be adding extra compute. And so, but also we only use the rotation version if rotation actually included. That's nice. So rectangle, and then so you take in distance AABB, which I do feel like I should probably just like move up there, and I don't know if it's faster. because I don't know how well the like GPU does compiling and stuff. Like I feel like I should put that into the same function and use it because it'll be faster. Let's see, have a look at shader toy and go, you have like a compiled and zero. So you do like a whole bunch of stuff, like you're actually making a whole bunch of really weird. So something tells me that this translate, like it's converting it to this, which pragma vector cult c tor float 2x2 mat uniforms. I mean, kind of cool. Fragment shader end. Okay, right. Anyway, we should probably have like less shapes for one thing, but I suspect that a lot of my frame time is not going to rendering, it's going to updating something. Potentially like the number of visible things on screen, maybe? No, this seems terrible. So the number of visible things, like how do I calculate what's visible? This updates offsets, that's fine. This shape changed global transform. Yeah, that's fine. Bounding box. So extract component changed stuff. Update visible shapes. This I think is probably the one of the functions that's being slow. So we get the camera and we say display, and then we camera into inner size. So size window.size, and we scratch.clear. See, I'm using a hash set, and I've been told that hash sets are slow if less than a certain number of things are being used. So since we're clearing scratch each time, and then if display.0 does not equal scratch, that's why I'm using a hash set, because if display.0 equals which cool, actually Bevy has an entity set, I believe, which entity hash set, right, and which is a hash set pre-configured to use the entity hashing. So first off, what's our FPS at? Like 800, fluctuating between like 870, 800. All right, and then we're going to go, hey, where are we using you? We're going to say entity hash set. Entity hash set. So in theory, I don't actually know. You take 0 arguments, yes, because you don't need to specify that your entity because you're specifically designed to take in entities. All right. Then there should just be a swap in replacement, and let's just see if we get any extra for FPS by like not doing that. So every bounding box in shape. Well, first off, we pause time because what that's telling me is that a lot of our, well, didn't really help. What the hell is consuming so much of my frame time? What is consuming all my frame time? Let's clear this. We remember swap. Yeah. So obviously writing a bunch of shader stuff is slow. I don't know. We could profile it and actually work out what's doing it, but I think I need to add triangles to my thing before I get annoyed and give up. Okay, paste this in. So triangles might take in rotation. I don't know how they will take in rotation. So it needs clear. So we're gonna say, hey, up here we're gonna define something like you're actually a triangle. So I think you're going to have a width and a height and like a h distance, right? Which is the update your bounding box. You can take a triangle, a bounding box, and so I guess, yeah, your bounding box is twice. Actually, technically, I think your bounding box would just be your width by your height. I mean, times a half, maybe, I don't know. Times 1.5. Say, yep, the default triangle is new width by height. So your H distance, which is the distance to the center of you, is going to be the min of width divided by I guess it's width and height divided by 2. Right, so the furthest you can be inside a triangle is either halfway up or down, halfway left or right. Because if you, I don't know, you've got to check this. If I draw a triangle, yes, right, like the furthest you can be inside of a triangle is like here, right? Which even that technically isn't. This is an exact value, isn't it? Not really. But the idea is that, like, if you're more than halfway up, then you're closer to this edge. Wait, yeah. So I've said half, and it's basically the half point. Because as the triangle gets narrower, the furthest inside you can be is this edge, and then the furthest in you can be is this edge, and then yeah. So draw like 3 lines, and then where those 3 lines meet, the furthest inside you can be. Again, doesn't really matter for what I'm doing. It probably does, but I can maybe work out what this should be. Why? Wait, really? Consider importing the function. Okay, right, because it doesn't work. Like, I've been doing shaders for too much. Dot min of height divided by 2. Okay, so the min of the 2 divided by 2. So let's go steal the shader code for the triangles. So back. Back one more. So we're gonna go somewhere. There's like a triangle, equilateral triangle, isosceles triangle. See, what you want to know is what the minimum times the sine of y, the length of p. Wait, really? I know you update p. Const k is the square root of 3. Okay. Well, something tells me it's the square root of 3. So where do we use k? So we work out that which is... Where the fuck is... What is r? What is r? Is r the length of the side because it's an equilateral triangle? Maybe? Again, why don't I fucking name this shit? R. Okay, so p and r. So we're saying that the absolute of p minus x minus r. And then we say that the y is equal to the p's dot y plus r divided by k, square root of 3. So that's here, right? It's like the square root of 3 up, because it is side length, and the square root of 3 comes from square root of 3. Okay, and so that does mean that the furthest you can be inside is the square root of 3. So if r, so kind of feel like we want to have a triangle. So I reckon, actually, just for the sake of making it a little bit spicier, we're going to go, triangle is actually an enum. And we have triangle, and it's going to be triangle, well, that just says triangle again, equilateral. Just pasted the word triangle in there. Equilateral, and equilateral is going to have a side length, right? Which I guess also technically needs a h distance, doesn't it? I don't know. Isosceles. and scaling. Is that what this one's called, or is that triangle exact? Okay, so this would be more like triangle. I don't think this is correct. We want triangle point points, which is then just going to be a vec2 and a vec. Yeah, vec2. Okay, base and height. Okay, so only non-empty structs with named fields are supported. For what though? Shader type? Yeah, that's because you're not a shader type. You can't be a shader type anymore. Thank you. But we'll do it. So the question is, do you calculate, like, is it computationally that much more straightforward to do? Because couldn't I pass in? So yeah, that does seem a lot more expensive. Takes in a dot product and a clamp and a fine min and then a max. Okay, so yeah, and it uses negative square root. Okay. Now I do wonder if you could rotate the triangle, because I suspect you'd have to be able to rotate it, but like the way you would rotate it would be just to transmute the position. Anyway, we're going to say grab these three functions. Right. And we're going to go to here. We're going to go, can you make a new file called SDF underscore triangle. That's spelled correctly. TRINGL dot WGSL. Right, I'm going to paste these in. I'm going to do nothing with them because SDF SD equilateral underscore triangle. Now I do feel like the shader type should probably your comment and your comment and your comment. Okay, so yeah, fn and then returns in 32. The in type is p, which is a vec2 of 32. Log b vec2 f32 f32 and then float r, which you're an f32. So const, so it's up here, const k, which is 32, goes to the square root of 3. So we're going to say how do I assign you as mute? Can I go like mute? Is that actually a thing that I can do? Absolute negative r absolute p dot x and then something dot x. What do you expected fn? Okay, so you can fix that one and then here. Yeah, sure. And then you can fix that one, and these are all just like let. Oh no, I don't know if I trust that. That seemed like you added a way too many lets in there. Let. Let. E0 equals pp. Okay. Yeah, no, you did need to do that. E1. Oop. Let. Okay. That's very confusing. Okay. So v and then let. And then let. Okay. And then you are that, and then you are that, and then you become that and that. which is in the min of the dot and the it's going. That's a hell of a fucking function. All right, so we want to go back to triangles. I want to go, hey, so the way equilateral triangle works is update bounding box. So the bounding box for equilateral triangle is well, you just width and height, I think. Right. So we need to match triangle. So your bounding box 0 is just right. So that seems correct. Is that it's the x is the side length, yep, and then the height is the square root of 3. Yeah, you can do that. That's cool. And then you'll just base and height because base tells me that, and the height tells me that. Right, and then your I guess the minimum of the x. So you take the x of a, b, and c, and then you take the maximum of a, b, and c, and then the minimum of a, b, x, and then you say that you're the max x minus the min x, and you're the max y minus the min y. Okay, and then just don't do this. Okay, so that's how we set the bounding box, which is to do this. I think for some reason I want to set the bounding boxes need to be slightly larger, but alright. So when we say new triangle, we need to say new, and then specify the type of triangle, equilateral triangle, and then and then new isosceles, and then new point. Okay, and then is visible takes in a distance, and then it goes okay, so if distance is less than no, it's is visible, we need to match self. Right, so side length, if distance is less than its side length, right? The is visible, I think, is just about if distance is less than the max of all of these divided by 2, I guess. I don't know, I'm just letting the AI fucking roll here. All right, so stuff square is apparently a triangle now, which is kind of funny. Triangles, which we annoyingly have to push triangle data, so we need to be like dot into, right, which I think you get to specify that you're type T, right? So yes, we should also make sure that we clear the triangles. Yeah, please rename that to triangles. You are now called triangles, and you are a triangle. Triangle. So we need to turn you shape triangle. Okay, so and then the default is equilateral with the 10 side. Okay, so what I need to do is make our struct triangle data again. So we need to go pub struct triangle data, which needs to include ooh, interesting. So the thing is we could split the triangle into 3 different types, but I think we want to just be like pub type subtype, which is then just going to be a U8. And then we need like and then like, so if you're each triangle needs so you either need 1 float, 2 floats, or 6 floats. Okay. Okay, so I guess we just have can I, so first off, can we just declare derive data type, which also needs to be cloned, I believe, clone and copy maybe. Then we go, so it's a subtype. So it says cannot use type. Okay, so you have to be U32 because we can't use it. Okay, and then we have to say pub data, which is then a F32 by 6. Hey, we can do that. Okay. So basically the idea is when we call we import into, I guess, from triangle, from triangle or triangular, and we say hey, and then you set title length, and you set base and height, and then you say AX, AY, B, AY. Okay, so cool. Now your problem is that you need to type annotation, because push T. Shouldn't you know the type? Triangular. Yeah, but that's what I'm saying. Like, you should know the type here. I think it's because I'm dereferencing you. Maybe. Nope. Okay. Okay. So we just say triangle data from triangle. Dereference. Yeah, dereferences. Okay. Right. So then we have to go. This is a monstrosity. We have to go to wherever triangle is here. We need to go somewhere we load the triangle, which is apparently just loading the square. So we want to load triangle. Yeah, read yourself. I don't know why this is having a fucking fit. We need to export like we were doing here. So so first off, you define this except home is we need to be like, hey, you're a triangle. And then yep, triangle, and then we need to be like triangle type, so U32, yep, cool, and then P0, except you're a data, you're an, I think it's an array of like that. I think that's how you declare that. So I don't know why. How do I declare it const? I do it up here. What the fuck is wrong with you? So it's const, yeah, equals that semicolon. What is your problem? Maybe I can't use square root. I don't know. So triangle needs to also bind to 2 because, yeah, triangle. So SDF isosceles, SDF triangle. So so first off, I think you need to be point triangle. That's what you are, and then we can construct you out of the other stuff. So we're gonna say fn SDF SDF triangle, or sign distance triangle, which is going to end. We're going to take in a P, which is vec2, F32, and an ID. And you say, hey, get triangle, get subtype, and then get data, and then we say, hey, if subtype equals equilateral triangle, subtype equilateral triangle, passing in data 0, and then returning data 1. That's not how you work. Although it very well could just be how I make you work. Okay. Then we say isosceles triangle, which is then it's U, and then 2. Okay, and then you're just this, and then apparently data 6, which is going to return 0. Probably not the best idea, but Now, I have no idea what you're having a hit is about. So something. So maybe because I've got the word mute here, but I don't actually have any idea why it's complaining. Okay, I feel like I just need to like reopen this. So I think you're going to complain because I'm trying to do that, but I don't actually know if that's allowed. Maybe I have to take a back pointer. I don't know. So I am curious if I just like restart this, is it going to work? Probably not. Before I do that, I should probably make sure I actually include the triangles. So mod U shapes mod here. Okay. I think you're right, triangle dial, which means I think you should work fine. Somewhere there's a plugin, and I need to make sure I include triangle data. No. Yeah. Okay. Then we have the square plugin, and we're gonna say triangle plugin, and then we go to triangle plugin here, and we go make sure that the triangle plugin actually first off, you get this, you get this. Then this is I don't remember how I calculate the. Is it the bounding box? How did I work this out? So I said that it's the square, like title times the square root of 3 apparently. So that goes here. It's just side length times the square root of 3. That's not a const though, so you know. Is it Bevy math? No, why wouldn't it be STD math? STD math. Math. No, F32 math. Square root of 3. Surely that's const, right? No? Okay. Huh. Core F32 math squares. Okay, not constant. Fine. Can I not say const SQ 3? Cool. That looks right. Yes, replace that with the square root of 3. Okay, then you were this, and then to the base and the height. How do I calculate you? You just reckoned base and height, but I think I would need to know. I'm curious where the square root of 3 comes from. That actually doesn't. Oh, so the square root of 3 is 177. That doesn't seem right because it can't be 177 because it needs to be less than. Right, like the. Maybe I don't know. I'm trying to think how you'd work out the thing. I don't know how this works. So I think you're the min of what your base divided by divided by 2. Your dot min and then the height. I don't know if that's actually correct, but that's what we're going to use for the distance function. Right. So triangle plugin, no method. Cannot find triangle plugin module. Have I not saved triangle? Did I not rename it? I didn't rename it to triangle plugin. Triangle plugin. Okay. So we've actually added the triangle plugin. Are we actually extracting triangle data? I don't know. Possibly. Update U, which is anytime a triangle changes. You stick it in the shed like that. We should probably actually spawn some triangles, you know. That could be helpful. Up the top here, we want to just like turn this one back on and turn that one off because we don't really need to spawn lots and lots of triangles. So new, and then I guess well, technically we're gonna go let's start with just isosceles. So isosceles, no, equilateral, a new equilateral, and we're just going to give you a width. Yes, there you go. Then we're going to run that. We're going to get equilateral working, and then once equilateral is working, then we'll expand from there to isosceles, and then okay. So you're not liking this because at some point somewhere we hit a object that doesn't exist, I think is what's happening. So we need to come down here and we need to say so const triangle is equal to 2, and then we come down here and we say case triangle, SDF triangle, I guess. Yep, cool. And so you need to bring in the import triangle, SDF triangle, and triangle. I don't think you actually use any of this, so I don't know why I'll bring it all in. Like, you don't ever actually access this stuff, you just call SDF triangle. So let's just bring in SDF triangle and see if that actually works. All right, so then we can restart this, I think. All right, so first off, you don't like that because somewhere I must be a comma. So SDF triangle needs a comma, array, that must be that. And we restart this. And we go, okay. It doesn't like that either. Why does it not like it? Because we've got the word mute, which apparently is not a thing you can do. Okay, fine. We need to be like var p equals p. Can I do that? I don't know. I'm assuming you can't because that's a bit weird that you can just rename a variable. Like you can declare a variable when it's an input parameter, but you know, who knows? Yeah, redefined. Okay, so let's say let's call it s, and then we can say p equals s, and then do your weird witchcraft on the thing. I'm assuming there has to be a way to declare it mutably, but like, I just don't know how to do it. So p, if, all right, if this condition plus k times p is greater than 0, p times equals this. Okay. Right, and then x minus equals clamp x and r. Run that. Run it back. See how it does. I'm assuming you're going to have all these problems too. Probably. I will declare it there as well. So we're going to say your s, and we're going to go here and we're going to var p equals s. Then you say here, and we do go vec2, except as you're supposed to say let b equal that. And then you're the same with let. At least you don't overwrite p, I don't think, anyway. At least it doesn't have to recompile Rust, it's recompiling the shader. And this time it's recompiling Rust. Oh, because I'm changing built-ins. Okay, so why are you saying so let s redefined s? Oh god, okay, too much. So, wait, what? Let s? What do you mean redefined s? SD isosceles. Ah, okay. Q, R, A, R. I'm kind of running out of fucking letters. R, okay. Let's try that one and go. Please compile. I beg you. Hey, except the triangles are upside down. But we've got like a sequence of equilateral triangles sort of blurred together. So that's fun. The equilateral triangles is really funny because I don't think I'm giving the right distance for them, but that's fine. Okay, so one thing is the triangles are actually pointing down. So how do I rotate them? Like, I'm curious how you actually. We go to the square. How did the square actually rotate them? So this is the rotation one, and it calls distance box. So how did you do it? You took this and you transposed the skew, and then you multiplied s, so s, and then what is it with plus s? P. So the position of s and he. So that's the bounds, and so we just directly pass the bounds down. So we this, I believe, is the actual rotation that we're doing. So we take in a sign and then we skew it with a, and I'm pretty sure skew just flips the signs, right? Because up here we skew. So skew just puts negative y and in x and x in y. All right, and so then when we take a mat 2 and we transpose and we flip this, so when we multiply this by this, this gives us a rotated version, I believe, is what's happening here. So that would imply that if I took, annoyingly, I have to take multiple functions. So maybe we should take skew, so we can square. Don't X the whole thing. So we're gonna Control C this and then get rid of skew. I'm gonna put skew into core. And we're gonna go bring this down here. So this is skew, and we're gonna go circle here. Well, I guess we go to square, and we go to up top of square, and we go, hey, can you whatever this thing was called? How do I import these things again? We go here, and we go import. Okay, import Bevy SDF core. Okay, here we go. Okay, so it's import Bevy SDF core core skew skew. Let's get how it's spelled. Skew like that. Okay, import skew. Okay, so then you can use skew, and then so what you're doing is you're doing this, which is let m equal that. So I think the triangle. So what I'm curious about here is SD equilateral triangle. So the way that works, from what I understand, is we're going to say SDF sign, we're going to FN SD triangle rot, right, which is then going to take in a P, an ID, and a U, and then you say sine, triangle, subtriangle, and then we're going to say paste this. We're going to say M is this, and then we're going to pass in S, which is M times P, pass in S, and then again S. Okay, so that should, in theory, imply that I can rerun this and see if it actually compiles. So we should be able to SDF rot that as well. And then you. Okay, so we're using unknown identifier skew. We need to import for skew, and then we run this and we go, okay. So I think what this is doing, though it does seem like it might be a bit expensive to be doing it, is it's taking a transmute. So the idea is that anything in the 1500s, so let's pause time, then there's just there's lots and lots of shapes. I really should just reduce the number of shapes that I was spawning. We're still up at 700. We've lost over 100 FPS, but that's fine. Because again, I'm pretty sure that's all in Bevy side of it. It's not actually my shader that's any slower. Outside of the fact that there's obviously like shitloads more things on screen at any one time. Anything in the 1200. So no, because you're type circle, which implies that the ordering is no longer the order I expect. Okay, so first off, let's go fix this debug code. I don't think it's editor. Somewhere I've got like the word shape transform, maybe search for nope. stop controlling a shape. We're looking for something that looks like a shape. There. Format args shape. Okay. So we need to go something like get circle. Right. So we go this, and we go, hey, if it's a rectangle, square. I call it a square, but it's actually a rectangle. Which is kind of funny. Square, and then no, you need to say t width is width. Why can I not? Because it's all private. I need to impulse square. I need to have a I do feel like I should probably just make you a size. But anyway, width just does that, and height just does that. All right. And then we probably should go back to here and go width, which is square dot width. Height is square dot height. And then when you come down here, we go, this is a triangle. Triangle, and except you are we want to, I guess, match triangle, and then yeah, remove this. Go away. Tick. Okay, so variable can you yes yes, and yes. Okay, go away with your yellow lines. Okay, so now I'm just going to rerun this and try and track down a triangle, and then we can see if we can rotate the triangles. Again, I really should just reduce the number of shapes that I'm spawning, because not only do I need to go through every single shape, every single frame, to determine if they're visible or not. We also appear to be doing triangles. So you're a triangle. I don't think you're on screen. So what we're going to do is we're going to go here, we're going to go here, we're going to go, hey, pause time. We're going to come over here, we're going to go, let's like minimize the number of triangles on screen, okay? Then we're going to go F12. So this tells me that there's an equilateral triangle that is entity 12, 6, 7. 12, that's a lot of fucking triangles. 12, 12, 12, 12, 12, 6. 12, 6, 7, this one. So we're going to go, hey, what color are you? You're the yellow one, so you must be that one there. Can we find a different one, please? Equilateral triangle, Okay, so what about 1178? 11, there's no reason I can't just make it bigger. 1178. Okay, what color are you? You're the red one. Why do I keep finding the ones over here? So first off, we also need to make sure that the triangles are actually big enough, because it's not quite getting them. Anyway, apparently you're not the right triangle either. Equilateral triangle 78. What about 934? That's a long way away. 934. What color are you? You're the like yellow. Why are they all over there? God damn it. Stop. Equilateral triangle. 1376. We want like we gotta look at the ones on screen. We can go like what we want is with the green one's 30, so it's probably the 1320. 1322. Okay. And here 1322. That one. What color are you? Like purple. That's a rectangle. Actually, that's interesting. Well, you say you're an equilateral triangle. And do you say you're a triangle? You do say you're a triangle. You're just not on screen. Okay. You're just rendering the complete wrong color, which is interesting. because first off, that implies that you're on white. You're still white, still green. Okay. That tells me that you're probably putting the complete wrong color in. I have no idea how this. Why is it always white? Okay, now you're red. Who cares? Would like to know if I rotate you, will you actually rotate? Triangle for triangle. If I rotate you, do you actually rotate? The answer is no, but I think that's because I didn't tell the shader to rotate them if they're rotated. Yeah, okay. So if object, where do we get the object? And how do I know that? Where have I grabbed the object? When have I grabbed? Oh, you pass in the object. Okay. So if object dot rotation does not equal equals 0, otherwise else return rot with object dot rotation, like so. And we just need to make sure we bring in the SDF triangle triangle rot. Yep, like that. Okay. And then we go, can I F5 that? Hey, look, it's turned. Hey, okay. So that kind of implies that I can rotate any shape. I'm curious to test to see if the isosceles triangle thing will work. So first off, what we probably want to do is reduce the number of other shapes we spawn, simply to like unclutter the screen. Like originally I had like lots of each, but that was to do with like making sure I could find a couple in the really big area that I'm spawning. I guess check performance wise. So we want to go here. We're going to say if RNG dot genbool with a 50-50 chance, new isosceles, new equilateral, else maybe. I mean, I guess. So there's a 50-50 chance we spawn each type of triangle. Okay, you did not like that. Why didn't you like that? Something panicked. Has duplicate component triangle. Oh, wait. Main, okay, triangle, Bevy, oh, because I just stuck the triangle in twice. I'm gonna pull the old one out. So width and then width height, and we go, okay. So, okay. You're funny looking triangles, but that's kind of cool. Cool. The question would be, is it worth reducing the complexity and the scope? Sorry, reducing the scope. You can tell which ones have the wrong fucking distance functions. It's too big. What I could do, because anything that's not pointing directly up is the wrong kind of triangle. It's drawn with 3 points. And hence they're doing it wrong, is because they're calculating the wrong distance. But anyway, what was I saying? What was my point? I love it. I could just use the 3-point triangles and then make all the other triangles as like with just specifying the 3 points. Now the depressing thing is that apparently triangles are really expensive because I'm down to like 500 FPS. And I'm assuming that drop to 500 FPS is almost exclusively to do. Wait, so we spawned 500 triangles, which is fine because we're trying to test triangles. I just want to know if I like say that particular type of triangle just is unacceptable. I can just spawn them so the rotation. So I'd have to modify the triangle code. No, rotating the triangles shouldn't be that expensive. It's got to be that the specific type of triangle is expensive. So how do I'd have to modify the shader here. So if I just said like, hey, if you get this particular type of triangle, just return an isosceles triangle. Like, just don't do this. Just do this. It's a bit silly because the data is going to be all messed up, but because of the way that works, we could just also calculate the maximum value. Anyway, because no, okay, it's interesting. Did it not recompile? Did I not save it? I mean, I didn't see it recompile, but the fact that it didn't relaunch immediately makes me think it just didn't recompile. No. Okay, so we're down at 500 FPS. But again, I don't know if that's my shader or if that's some other code. Like it could still very well be just like the amount of time it takes to extract data. Anyway, I got shaders working. I got triangles working. So I mean, it's kind of cool. Now the issue is that like all the shapes are also kind of like weird. Can I go back to taking like let's triangles here? There was I was doing something with, is it normalize? Like normalize and divide by I or something? That's like kind of cool. The issue is that I think triangles are just getting the wrong value given to them, but that's fine. That's kind of cool. Okay. These look like a stick. There's a bunch of other shapes I could add, but I feel like at this point I'm gonna head to bed because it's getting late. Oh fuck, it's like 1 AM. And I feel like shit. Alright. Thank you for tuning in. It was a lot of fun. We got triangles working. I should commit this. Added squares and triangles. I feel like each of these shapes should have their own buffers and everything, like, but at the moment I'm not doing that. This I can't spell. Okay, enough to try. Well, rectangles anyway. Rectangles and triangles. Okay, commit. Right. At some point I should probably publish this repo so people can have a look. But okay, don't know if I'm gonna work on a video tomorrow, but if I end up streaming tomorrow, I think we're gonna pivot to working in 3D and doing ray marching. Or the, like, I guess ultimate end goal of this is to do which, I mean, the fact that I did it with shaders kind of defeats the point of this, but to do marching cubes to turn like a 3D world of SDFs into a mesh like that you could like export. But that's probably ages away considering how fucking long it took. I don't think I'm gonna do colors in 3D, but who knows. This can go away. But yeah, thank you for joining in and watching stream. I will see you all with whatever I do next, whether that's make a video or do another stream. Okay, and broadcast.